Okay, let's give it a sec. There we go. Good morning. Thank you. Can we get a good morning? Is it not a beautiful, lovely morning? Okay, so give me a good morning then. Good morning. There we go. Welcome back, everybody. We're so excited to have you. Welcome back to day 2 of the React Miami conference. Just like yesterday, we've got a list of amazing speakers that you're going to be hearing from today. I just want to remind you a couple of things. To everybody who's been tweeting and interacting with each other, we love it. I was up a little too late last night going through the tweets. So please keep me up again tonight. We want to hear everything that you have to say. So please go ahead, tweet us at React Miami Conf. If you have anything you'd like to say to me and Patar, my handle is Andronica, ANDRONICA _KLAAS. I'm one of those who has an unnecessarily long Twitter handle, but we're working on that. Patar is PTAHDUNBAR. I'm going to pick on a few people if nobody volunteers. Do you guys want to tell us what some of your favorite things were about yesterday? Somebody volunteers so that I don't pick on anybody. Okay, I'm going to pick on someone. Kathleen. Do you want to tell us? Well, you were one of our speakers, so we know that, you're good at speaking. What were some of your favorite things about yesterday?
Oh, well, one, my talk is done. I loved Kent's talk. I loved Jenny's talk about burnout. It's amazing. Jennifer's talk about mobile.
Nice.
Yes. And all the costumes.
All the costumes. We enjoyed that.
No, clearly like the carnival, like défilé was like the best.
Now, anybody in the audience who's not a speaker, I am not shy to pick on anybody. I will come pick on you. Okay, there we go. 2 volunteers to save the masses. Do you want to tell us?
Sure. So my favorite party yesterday, that's very close, was one, the burnout talk, and the last one with the dev tools. That was really cool.
Thank you. Was that David? Thank you, David. So your hand.
Hi. A lot of the parts were my favorite parts, but I also like the variety between technical, UI, also like thinking about thinking, and also about like yourself, not always about like technical stuff.
And your name?
Pedro.
Thank you. Thank you for volunteering. We love to hear what you guys' thoughts are. Okay, now that we've heard what the audience has to say, let's get back to our speakers. So our first speaker for today is Una Krovitz. She's currently a staff developer relations engineer at Google. And Una's going to be talking to us about how the best JavaScript is no JavaScript. Give it up for Una.
All right. Hello, everyone. Good morning. We got early crew up in here. I love you for coming this early. Thank you. I don't know if I would have made it, but I'm glad you did, because I'm very excited to be here today in a room full of JavaScript developers and React developers to talk about why you don't always need to write JavaScript. But ultimately, this talk is going to cover a lot of new features in the web UI space, CSS, HTML, and UI space. It's going to make your life easier. I promise you that. And the main thing is, it's going to help you separate your application logic from your styling logic. I'm not saying don't write any JavaScript, but right now we still have to do a lot of our styling logic in JavaScript, and it doesn't always make sense. So I am going to do a really fast speed run. I'm going to talk about logical components, a few different math functions, container queries, some advanced selectors that we now have to embed logic in our individual components. That works really well for a React framework. I'll talk about CSS-driven interactions like scroll-driven animations without any JavaScript, and new components like popover, anchor, and select menu. And I'll even talk about typing your CSS with app property. So get ready for this journey. And let's start with grid functions. Who here uses CSS grid? All right, that's most of you. I'm proud of you because this is a great feature. It's been around for a long time. And with CSS Grid, we have a few new functions like repeat, we have autofill and autofit keywords, and min-max. And one of my favorite things to do with CSS Grid is make these responsive layouts without media queries. So one thing that I'm doing here is I'm using the repeat function. So instead of writing 1FR, 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 1FR to create 4 segments of columns at one FR space, one fractional unit of the space, you could just use that function repeat, and you could very quickly and easily make these column adjustments. But that's not the responsive grid we want. First, we have to start by setting up our sizing. So instead of the 1FR spacing, we want to set this to min-max. And min-max will let us give it a minimum value size, so say 150 pixels. And then we can use 1FR or one fractional unit as the remaining space. So now as I resize this, it's going to stop at 150 pixels and not get any smaller, but it's going to then stretch to fill the rest of the space. Now, the next step is to set this value to autofit or autofill, and you see that autofill here will try to retain around that 150 pixel size. Autofit will let this stretch. And the coolest thing now is it's going to shrink to 150 pixels until we don't have any more room, and bam, it'll snap on to the next line. So this is just one quick way where in one line of code, you can use grid template columns with display grid, that's important too, to create responsive layouts by leveraging the power of modern CSS. And if you're interested in this type of thing, I built a whole website called onelinelayouts.com that goes through how to center a div. Like, you know, I could edit the content here. Woo! It's place item center. That's the spoiler alert. That's how you center a div with display grid. So you can check that out and all of the other patterns on one-line layouts. This just shows you different ways to use Flexbox and Grid and really leverage the power of CSS Grid. So the next thing I want to talk about are more math functions. So not only do we have min-max for grid functions, but we have min, we have max, and we have clamp that can be used as a value whenever you have a property value pair. And this lets you choose between the minimum of 2 values, the max of 2 values, or a value that it clamps between 2 different values. And again, browser support here is very strong. It's been around for over 3 years. And so the way that you would do this is you would set an actual value, say it's 50% here for the width. And then if I get smaller, if that 50% is smaller than 350 pixels, it's going to clamp at 350 pixels. Then it's going to grow until I hit 500 pixels, and then it stops and it hits that maximum clamp size. So this is really handy when we do things like responsive typography. So we could do something like font size, clamp, give it a min value, an actual value. This is using VW or viewport width units, and then a max of 8 rems. So I do this all over my site. Here's an example of it. I'll just inspect element to show you where this title has this font size clamp 2 rems, 10 VW, and 5.5 rems is the max. And then as I'm resizing this, it's going to shrink until it hits that minimum size. So for mobile layouts, it's going to be around that size. And then for larger layouts, I like a really big title. So I'm doing that with the header and with the first paragraph. It's like a nice little enhancement you can make that is well supported and a way to leverage functional CSS. So we also now have trig functions in CSS. Yay! This is new. We got this in Chromium this year, but we now have sine, cosine, tangent, asine, a cosine, exponents. Like we have all of these powerful trigonometric functions in CSS, which means that you no longer have to do these math calculations in JavaScript and then send your styling values over to your browser. We can do it in CSS, which means we can make more organic layouts, like this radial menu where I have these items displaying on a little circular plane. We can use the power of math to be able to map this out and build this. So when I was building this little radial interface, I was thinking, okay, so if I have the center button and then I want the other buttons to align on a plane around it, we can remember math, we can remember triangles. We know 2 things. We know the radius, which is the size of that button, since we have 2 of the radii next to each other, plus some additional space. And we know the angle at which each of these will sit, because we're starting at 0. We have 5 items, 45 degrees, 90 degrees, 135 degrees, 180 degrees. From there, we can use sine of the angle times the radius to get the x value, and the cosine of the radius times, the cosine of the angle times the radius to get the y value. We also flip it -1 for the y value, so it doesn't go downwards, it goes up. And all in all, that looks like this in CSS. We get the radius by calculating the button size plus that extra space. I also update the background color for each of those items. But the magic is really happening here, where we can use translate X and translate Y to place those values, and then set a transition here, so we're transitioning that transformation. So it looks like this, and it aligns to that grid. And we can do this all in CSS now without having to go to JavaScript to place these values and send them over, and it's so much nicer that way for more unified interfaces. But when I built this demo, I just built it in CSS and HTML as like a trigonometry demo, and that is not accessible. Components that use CSS and HTML alone, for the most part, don't let you do things like we learned from Kathleen's talk yesterday, where you have to hit the escape key to be able to get out of interactions and other things. So Scott O'Hara forked this and made a popover version, which was awesome. Something broke, so it doesn't work anymore. But the popover attribute is something that you can use in Canary Behind a Flag. It's an experimental implementation that should be hopefully landing soon. There's a lot of work that's been going into this by the OpenUI community group. And what popover essentially does is it lets you enable pop-ups. So popovers, those can be dialogues, different types of attributes and elements. And it gives you a lot of built-in accessibility. So it connects the popover target to the popover button that's opening it up. It gives you keyboard behavior, like hitting the escape key. It gives you keyboard behavior for navigation and focus. Also, if you click out of that popover in the space around it, you get light dismiss for free, and it manages the focus for you. So you don't have to do all of this yourself. You don't have to manage all of these things yourself, and it should hopefully make things a lot easier to build components. So to build a popover, it is as straightforward as this. You need something to open the popover. So you might have a button. I have some text, open me, and then I have a popover that I give an ID, and that popover ID is profile settings popover, right? So then I can hook that up to the popover target on the button of profile settings popover. I'm using that ID. And the last part that you have to do is add the popover attribute, and that is how you build a simple popover. Just a couple of additional lines of code. And so I'm doing this in CodePen to show you that there's no JavaScript here. There's no JavaScript here. But as I click on these little profile settings icons, they show up with this little animated, like, pulled in popover. And there's additional features like this close button will only close the popover. Again, if I hit escape, it escapes, it closes out of it. If I click out of it, you get that light dismiss, you get that focus trapping, like all of those things that are really hard to do and cumbersome to build yourself, you get for free with the popover attribute. And popover is great, but it is one half of the equation, because the other half is anchor positioning. So say we don't want to just center things when we create these dialogues. Say we want to connect that pop-up to the thing that we just opened it from to make a tooltip or toggle tip, as I learned yesterday, great word, that connects it to those icons. So the way to do this would be to use anchor positioning. And similar to popover, this is an experimental API. There's been a lot of work to get this right, but it gives you a lot of cool functionality. So what we would get is something like this, where we can do the same thing, like dismiss, escape, all that good stuff, but it connects this popover to that button so that it gives more contextual sense of what it is and where it's coming from. And the way I do this is we would then need to add an ID to the button. So say it's a profile settings button, and we would add the anchor connecting that ID. The anchor is profile settings button. So this is all just about connective tissue in HTML. And in CSS, we can then use the anchor values to position this settings popover. So we can use anchor top, and that'll anchor it to the top of the value. And then we want to give it some additional space, like 1 rem. And then we can position at the right value using anchor right. So we get this to the right and top of this element. And then I added this little arrow as well as a pseudo element. Straightforward and cool. But let's take it a step further. What happens when you want to, go to the edge of your screen and then have this still stay on the screen? So we want this to flip, right? We want this to stay on the screen. Now you can set this up using try statements in CSS. And the way that you do this is setting up these position fallbacks like you would a keyframe. You would set at position fallback, give it a name, top, then bottom. And then you would say first try positioning it from the bottom to the top. Here I'm using left anchor center because later I'm doing this translate from -50% to center it. But it would first try positioning at the top. If that doesn't work, if there's not enough space in the viewport, then it'll flip it and position it at the bottom. So you can get really granular with this. You could do a compass, you could do top, left, right, bottom. You can write all these things. The best way this will probably go down is with reusable position fallbacks, where you would have a library of position fallbacks for your popovers. But in just a couple lines of code in your CSS, where it makes sense to write your styling logic, you could have all this. And this is a popover, but this is not limited to popovers. With anchor positioning, you can apply this to elements that aren't popovers. So this might be something that's always open. And the difference too is that popover promotes something to the top layer, which is a separate layer from the rest of your page, which is another benefit of popover and dialog, where you don't have to fight with Z-index. You're on a separate layer. Yes, it's great. And you also have that backdrop property and all that stuff. But if you wanted to use popovers for, say, data visualization, for charts, or for any other type of content, this will then look at its parent. So you can use that same exact fallback, but it will look at its direct parent, which in this case is this little resizable div that I have here. So you can use it all over the place, super handy. And this all adds up to the select menu component. And yes, all this stuff is currently available for you to explore behind a flag and canary if you're curious and interested. One of the biggest problems on the web that I hear today is just styling dropdowns. We can't do something like this. We can't style options. We can't put arbitrary content. We can't put flags inside of a dropdown for countries. And this is a visual indicator that can really help your users select things. We can't currently have like a username and a title and just any type of additional content like that. But with select menu, you can. So instead of using select, you would use the component select menu. You can also have a custom label and button, and you can have your custom little arrow as well here. And then you would just have these options. So I have options like red, and the value is red. And then inside of that, you can have your figure, you could have the text of that option, and you could have any sort of arbitrary content, because when your user selects it, it's looking at the value. So we're getting drop downs that you can customize in CSS and HTML. It's happening. Okay, I told you it was a speed run, so we have to move on. We can't, I could do a whole talk about anchor popover and a select menu. But next I want to talk about something that I think is really exciting in the UI space, and that is the has relational selector. Has anyone here heard of has or used has? Okay, most of you have at least heard of it. I don't know if many of you have used it because it's still not cross-browser available, but it is behind a flag in Firefox, and hopefully that means it will be landing soon. But has gives you so much logical control. It can act as a parent selector and so much more, because you can style things now based on the presence or state of child's elements. So it works like this, where you could have a figure, and if it has a fig caption, then you can give it a border bottom and some padding. So in this image right here, we have this fig caption. A way to separate that from the rest of the text would just be to use has. So this is us applying styles to the figure, but you can also apply styles to any elements inside that figure, or even siblings. I could do +P, and now we have the styles applied to the paragraph that follows it. You can combine this with the not selector. So I could have not has fig caption, and now apply this style to the element that doesn't have a fig caption. So the more you start to chain these styles and to build these sort of logical interfaces in your CSS, the less you have to manage and the better you can componentize your code. So an example of that is here. I have this little You've Got Mail inbox demo, and I have a couple of elements here that have like the star like element present. And so if I look at that list item, I have here, if item has star, then give it a background of light gray. Again, you could change this to any value. We could make this pink if we want. It's not super legible, but there it is. Another thing that I'm doing here is in the second list item, I'm looking for if this item has something that's checked, give it a background of highlight, which is a system color. So I can do that and even override my star because it's later in the code. But here you can now look for the state of something or the presence of something. And taking that a step further, this element that has the star, if I look in that, you can see that the title is bold. And that's because I'm saying if the item has star, then style the title. So it's not just for the parent, it's for any children inside the parent or any of its siblings. Like this can get really, really robust as you start to build on this very powerful selector. And one of my favorite things to do with has is quantity queries. You can style based on the number of children in a given element. And a little while ago, I had a role where I'm working on a media product. And so for some of our articles at the end, we'd have credits, right? Sometimes on set, you'd have hair, makeup, costuming, all of that. And when it was, a few people, we could list them in a block context, so one after the other. But when it got to like 6, 7 people, listing them all one after the other looked kind of weird in the UI. So I had to build a component where we're looking at the number of children, and if it's many children, then display them next to each other. So we can do that very straightforward with has by using has nth child n plus the number of elements you're looking for. So here what I'm doing is if there's 5 or more items, so if the unordered list has nth child n+5, then style those list items to display inline instead of display block next to each other. So here they're inline. Additionally, I'm styling the parent here just to kind of show that you can also style the parent, give it a background yellow. I'll delete that because it doesn't really make a ton of sense, but you can style the parent that way. And then the second part of this is to add a semicolon after each item except for the last item. So we can combine has and not, where here I'm looking at if the unordered list has nth child n+5, so 5 or more items, then give all of the list items except not the last child and after pseudo element of the semicolon as the content. So we can build on top of this and make things logical in our CSS where it makes sense for styling. Okay, let's talk about container queries. What about show of hands? Who's heard of container queries? Nice. Okay, there's more hands up than expected, which is awesome. It means y'all are up on it. So this is now stable across all modern browsers. Yay! This is an API that we didn't know could be possible in browsers, and an API that developers have been asking for years, like years. But now we have it. And the biggest difference between something like a media query and a container query for people who are not yet aware of this is with media queries, we have one central input, right? We have the viewport. So this is the global styling information on our page. And that's great. We can do things like change macro page layout, but it doesn't give us the ability to look directly into elements and their parents. So maybe we want to query the sidebar. Maybe we want to query a card. With container queries, we can query any element inside the page and apply styles based on the size or style of that parent. So we get a much more granular input into our interfaces. And again, for people who are building in component-based UI systems like React, this is going to be a huge thing and a great way to make your websites a lot more nuanced and work a lot better. So back to this demo, these components here are all containers. So all these items are containers, and it's the same component in the sidebar versus that primary inbox. So you can see I have the date here. I'm adjusting some of the layout. And then when this gets a little bit smaller, that date disappears or the time disappears. Now, we're still using media queries for the macro layout. So that favorite sidebar is swapping from the left to the top. But then as I resize, you can see that date comes back, and we're doing all of this logic for each individual item throughout the UI. So you can stack this and see this grow. And one way to stack this is in this example where I have this responsive button. You can get as granular as styling these buttons to be responsive, where I have this little add to cart. It's going to get some detail there. Then when there's enough space, it adds the add text. Then as it gets more space, it gets to cart. And then if there's more, the plus. So we have all of this nuance and detail inside this responsive button where I'm using text and SVG to create that. But we can take it a step further. We can now put that responsive button into a responsive card. So now I have a responsive card with its own space and its own responsive container, and that has a responsive button inside of it. So you can see how you can stack these and make them very granular, your button component, your card component, and you can see this grow and grow and grow in your UIs. This is the new way that we need to think about responsive design. It's no longer about just the viewport. It's now about really customizing your UIs from the ground up. And that includes embedding logic in your interfaces with these advanced selectors, with these container queries, and thinking about your users' preferences as a part of the design process. So remember when we talked about fluid typography? That example was with the viewport, but with container queries, we also get container query units. So you can do this within your interfaces as well, within cards, within sidebars, heroes, etc., by using container query units. So instead of viewport units, we get CQ, and here I'm using CQI or CQ inline, container query inline, which is like container query width, but as your language changes, it allows for some internationalization benefits there too. If you haven't heard of logical properties, check those out. Again, speed run. Moving on to style queries. So style queries are a part of the same spec as size queries for container queries, and they allow for you to style things based on style values for a parent. And they're currently only available in Chromium, but you could definitely try them out and see how they work for you. With style queries, one key difference as well is that you can directly query a parent, but if you want to query anything other than a parent, you would have to give it a container name and then query that by the container name. So an example of how we would use that right now, what is currently available is with custom properties. So we can set a custom property like sunny or rain or cloudy, and then style things based on that custom property value. And if you're thinking, what about data attributes? You could technically do this with data attributes. Yes, but with data attributes, you can't, one, update the style in CSS, and two, you're mixing metaphors. You shouldn't be applying your app logic in your style sheets, and you should have those separate so that you can really separate those concerns. Another thing that you can do here is combine these. So if your style sunny is true and cloudy is true, then you can style it a different way. So here I'm doing that, and I'm looking for both of those. I'm giving this like this purple background and this different icon where for all these weather cards, you could see that I'm applying these styles based on style and at container. So this is cool and all, I guess, but what's even cooler is what's happening next in the space. So next we'll be able to do Boolean queries to see if a custom property value exists at all. And we'll be able to do range queries. This is currently in discussion in the working group, where you could do something like give it a chance of rain. Say the chance of rain is 30%. And if it's 30%, that means if it's between 25% and 50%, also using range media queries, which are now stable in all browsers, we'd be able to do something like this, where you can get really granular with the style, give it ranges, give it different features and functionalities. And this is made possible by @property, which is a great feature that just landed in WebKit as well. It's been around in Chromium for a while, and it enables semantic CSS. So this is like a huge thing that I cannot wait for more browser support for, because now what we can do is we can set an @property value, give it a name, give it a syntax, so give it some semantic meaning, whether it's color, percentage, number, initial value, like magenta in this case, and then set if it inherits or not. So now when we're using it, say that value is color primary, when you have a card and you use it directly, you get the fallback background color, so magenta. If you update that value in a highlight card, if you update color primary to yellow, then we get yellow. But if you update it to a false value like 23, which is not a color, it's a number, then instead of getting transparent or ignoring this line of code, it falls back to magenta. So this is a way to almost type your CSS and do type checking fallback values, a way to sort of foolproof your CSS by giving those custom properties actual meaning. Right now, when you use custom properties in the root, they're strings. So this takes it a step further and gives them values. And because we're giving it semantic meaning, we can do things like this, which is animate gradients. This is something that you currently couldn't do without specifying what these meaningful values are inside the gradient. But now we have this grad point @property, custom property. The syntax is a percentage. The initial value is 40%. And then in this background, I'm using it in the linear gradient. I'm setting it as a transition, so I'm transitioning that grad point over half a second. And then when you hover or focus on this point, you're updating the value to 100%, and the gradient can animate. So you can animate color this way or different values. But this becomes really handy for interactive pieces. And speaking of interaction, I'm now at the last sort of CSS thing that you can do, which is scroll-driven animations. Has anyone here like done parallax effects or other like interactive things? A lot of you have, and the only way to do that right now is a JavaScript library, which is fine, but does it really make sense to do that styling logic in JavaScript when you should be able to declaratively do this in CSS? So again, this thing that's coming soon. This whole presentation is in Canary, so these are all live demos. Sometimes it's a little bit buggy, but there's a list of known bugs and it's getting there. Essentially, this is what it does. It allows you to do these like transitions. Here I have a clip path that's transitioning up. Here I have an image that's loading in. And yeah, that one's supposed to animate. There we go. So seeing this in the browser, playing with it is really cool because it works very similarly to CSS animations, where what you do is you set up your keyframes. So I have keyframes fly in, where this is for these here, the block quotes, they're sort of flying in. The opacity is going from 0 to 1. And then I have a transform here that's just translating the X position from -100 pixels to 0 pixels. Then the only change that we have to do that's new, you set up the animation, is animation timeline. So here, this is probably the simplest way to create these animations for the entire viewport, where you set animation timeline to view, and now it's looking for that animation fly in, and it's applying those styles. So this, I think, is a really big change. You let the browser handle all of this for you. Instead of doing animations on a timer, you're doing animations based on a scroller. And you can do animations on scrollers within your page. Again, there's a lot of complexity, but I'm definitely running out of time. So check out scroll-driven animations. There will be more content around this coming soon as it starts to land in more browsers. So another thing that you can do is entire presentation frameworks. This presentation was fully built with vanilla CSS and HTML, other than some of those iframes, because I wanted to show you, like, look, mom, no JavaScript. And you can create really robust interactions by just leveraging CSS and HTML. So all of these style blocks, like these are live style blocks in the browser. I can update and edit any of these. These are just style tags. So these are style tags with display block and content editable applied to them. So I'm just using the content editable attribute and giving this some visual, and that's the style block that you can edit in the browser and do live code with. I'm doing the smooth scrolling with scroll snap and using mandatory as a scroll snap type. So I can use my arrow keys. As soon as I hit the arrow key or scroll a little bit, it mandatorily snaps, I don't know if that's a word, to the next position in that scroller. And this whole thing is a scroller. I don't know if any of you noticed that, but it's a scroller. And I'm using access key to do navigation. So I can do on a Mac Control Option and then go to the home or go throughout my presentation and access it. So I can do that with HTML. Another cool thing about this is that CSS and HTML work in every framework. So they work in React. They work with the other frameworks that your team might be using. A lot of companies have multiple frameworks throughout. So this is something that is very interoperable, I will say that. And you don't need like specific components to make this work. You can use popover. Like with dialogue, you don't need a specific React component for dialogue to do that, or a Vue component. You can use the HTML native components and get a lot of this work for free. And that's why I think that the best way to level up your developer skill set is to pay attention to and not underestimate and get good at CSS and HTML, because you probably are already very good at React and JavaScript, but what might be missing from your skill set is understanding semantic HTML, understanding the power that CSS can give you to separate your application logic from your styling logic. And you might be making your life harder by doing these things, using scripts, setting additional dependencies to your user, doing that observation and some of those events in your JavaScript. So leverage the browser and don't underestimate CSS and vanilla HTML components. That's all I have for you today. To check out some of those demos, check out the QR code. Thank you. If you want to see more, oh, sorry. I just want to say, if you want to see more, I do write a bunch of articles about this stuff. You can follow me on Twitter at Una, U-N-A. You can check out my website, una.im. Or for the news, things that are landing in the browser, developer.chrome.com and web.dev are where we write about some of these new things for the Chrome team. So definitely follow those if you want to be up on when things are landing and what's coming. Yeah, that's all. Thank you.
Amazing, amazing. By the way, there's coffee, there's fruits outside. Please get some. Amazing. It's done. Wow. That was in Canary, by the way. Raise your hands if you're testing in Canary. I see no hands. Raise your hand if you knew that you could do video editing in the browser. Oh, yeah. Oh, well. I have a fellow Frenchie who is going to go deep and down into this rabbit hole of video editing in the browser. Please give it up to Christopher Shadow.
Hey everyone. And Should I have my slides? Yes. Cool. Well, thanks everybody for coming up so early. I know like the night has been long yesterday nights. So today I'm going to talk about video editing in the browser. So my name is Christopher Shadow, and you may have seen me in the movie about React on the first day. And I'm French. And so unfortunately, we didn't win the World Cup last time. Like Frankundo was able to do it, but yeah. Cool. So since COVID, I started doing like more video editing and like watching YouTube and everything. And so I started like really like going deep and serious into it. And so as you can see, like with all of my views, like I should not leave my job to be a YouTuber yet. So how does it work? So what I did was to start like investing in like a $20 green screen and starting to do using Final Cut Pro to do video editing. And the thing that was really annoying is like it felt like all of the latest developments was not there. So for example, for the green screen, I needed to like actually pick the green color and like select the ranges of colors. And it didn't work really well like with the background, with the shadow and everything. Same for like when I edit videos, I want to see like, hey, what am I actually talking about? And what's the interesting thing? But I only get sound waves for spoken words. And I really want to see like the actual text. And the good thing is, I was like looking at the web, and like Yuna's team has been doing an amazing job in the Chrome, like to actually build all the APIs. And so we can do video editing in the web. So with web codec and for background removal, we can use TensorFlow.js. For text, speech to text, we can have like the Whisper API from OpenAI has been translated to C++ and then ported to Wasm. So like we have all of the building blocks. And so I was like, yep, I'm going to do it. I'm going to like write a video editor in the web. And unfortunately, it was not a smooth sailing. And I came in with some like ideas of like how it would work, but in practice, they would turn out to be false. So for example, like I thought that like time only travels forwards. I also saw that decoding one frame gives you one frame back. And finally, I thought that Wasm was faster than JavaScript for video decoding. And so in this talk today, I'm going to walk through like all of this journey that I went through and let you know like why those three things that I thought were true were not. So let's start with stating the problem. So we have like this like super cool like React Miami video, which is like some text and like a palm tree, and the palm tree fades out and the React Miami like comes in. So what do I want to do? Like the very first step I was thinking is, okay, I'm going to load the video. So I'm going to take a file on the file system, load it, and I was expecting to get a list of images back. And then I'm going to modify those images. I'm going to like apply the background removal. I'm going to do crossfades and those kind of things. And then I'm going to like want to save the video. So I was expecting an API, take a file, like a file name, and then like a list of new images, and it's going to save it. So unfortunately, it didn't work that way. And so the first, like the reason why is, let's start thinking about what is actually an image and how is it like encoded, how is it stored. So for this is like an image, and like it's 1024 by 1280. So like very typical size, like not super big, not super small. And so now let's think like how big is this actually in the file system? So we have so if you have a rectangle, you want to know like how many pixels, you multiply like the width by the height, and then you get like 1.3 megabytes just for this. And then you probably know that like images are encoded like using red, green, and blue, or you can other things, but this is the most common. And so now we're already at like 4 megabytes. And so this is just for one image. And now if you want to actually make a video, you need to have like many images per second. And so if we use like 60 FPS, now we are like at 200 megabytes per second. And so now you can probably start thinking where I'm going with this. Like if we use the API that I talked about, like you're going to run out of memory like very, very, very quickly. So this didn't work. And like a lot of smart people were like working on the problem like from like many decades. And the first thing that you're trying to like thinking about is like, okay, I'm going to like start compressing the video, the images. And so we need like a shrinking machine. So this is the interesting part, like I'm going to go through like many like specific details of like how image compression work and like video compression work. And in practice, like I wish we didn't need to know about all of this, but right now all of the APIs are designed around them. And so this is why in this talk I'm going to go through like do a very quick primer around like all of those techniques. You don't have to fully understand them, but you should be aware of like how they work at a high level. So let's start with thinking about the image as a list of pixels. So in this case, like the palm tree, like the edge of the palm tree is a few black pixels and a few white pixels. So the first idea that comes to mind in order to compress it is instead of saying like, oh, there's like 5 white pixels in a row and 7 white pixels in a row, like white pixel, white pixel, white pixel, what you can do is start encoding, oh, there's 5, the number 5, like one number, and then like 3 values for the white pixel. And so this way, instead of like 3 values for white, 3 values for white, 3 values for white, you can have like 1 value for the number and then the pixels. And so this is called run length encoding, RLE. And so this is very useful for images that are like have like many pixels that are look like each other. So like all-time printers and everything. But in practice, if you're using like a photograph of this, like you're never going to get like exactly the same pixel like in a row. And so people had to find like other ways. And so this next one is going to be a bit out there. And so you're going to want to think about the image not as like individual pixels, but as a function, as a signal. And so you can represent your image as a continuous function. Like if you've done math, this is like should like have some like reminders. And one of the interesting theorem that was proven is that you can decompose any continuous function into a sum of many sin and cos functions. And so there's an algorithm called the fast Fourier transform that lets you do it. So now why do we want this? And so the interesting thing is each of the cos and sine function is basically like takes the same amount of bytes to encode. And so it has the same amount of information. And so what you can also realize is like the first few sine and cos functions contain like way more like information that like make the shape of the overall function. And then the more you go, the more it's going to be like very small variations. And so what you can do is to start converting this original signal into this series of sinus and cosinus function, and then just skip and ignore everything but the first few ones, and then re-encode it back. And so this way you're able to get a very similar like looking image, but remove a lot of information and like have less bytes. So again, if you don't understand like the full mathematical detail and everything, this is fine, but you need to understand like the concepts. And the third one, like the third image compression I'm going to talk to that you need to like have in mind is now instead of thinking of it as like pixel or instead of thinking of it as a continuous function, now we're going to think of it as like 0 and 1s. And one other thing that you may not realize when you're looking at this is the distribution of all of the 0s and 1s is not the same. And so in this case, there's 15 times 0, 1, 0, 1. There's 7 times 1, 1, 0. And then there's a bunch of ones, 1, 0, 0, 1, that is only one time, and a bunch of different that are like only one time. And so now what you can do to compress this is you can start creating a mapping of remapping all of the like binary numbers. And so for example, what you can do is to map 0, 1, 0, 1 to like only one bit, like 0. You can map 1, 1, 0 to like 1, 0. And at some point, you do all of this mapping. And so like the ones that are like not likely to happen may have like a larger binary representation than what they had originally. But if you sum all of this and plus the actual decoding table, now it's going to actually like let you have an overall size which is smaller. And so this is called Hoffman encoding. So those are like 3 techniques in order to compress images. And with this, we are basically able to get roughly like divided by 10 the size of the image. And so for this is image compression, and you've probably seen like JPEG, PNG, WebP. So those are like the names you're going to like see and hear. And so now we are able to get to around 20 megabytes per second. So this is much better than like the 200 megabytes per second at the beginning, but unfortunately, like it's still like pretty big. So now, like the people working on this, like continued working on this and had more ideas. So now, what was like the key idea? So if you look at this video, all of the frames are basically like look very, very similar to the previous frame. And so like we have like 60 React like 9 in this case transition between the two like slides, and they look the same. So now the idea of like how do you actually like compress this, instead of compressing like every single image independently, now you can start thinking how to compress them in relation with each other. And so for this, the main like the first idea that comes to mind is, well, I'm going to do a diff of what is the first image compared to the second image, and I'm going to only encode the diff that happens. And so with this, you're able to get like sizable wins. But then people realize that in practice, for this animation, you can see that the palm tree is like going from this side to this side. And so one thing you can start thinking is like, I can actually predict what is the image going to be on the next frame. And so for this, the algorithm that the people have invented is like a prediction algorithm. So you start predicting from the previous frames where the next frame is going to be, and then you do a diff based on this. And from this diff, you use the previous algorithm to compress that diff. And so this is essentially what a video codec is. And so some video codecs, like the most popular is H.264, which is also named AVC, the same way like JavaScript is named ECMAScript in the spec. And then there's a few other ones like AV1 and VP8, VP9. So this is like a video codec. So at this point, what we have is the first frame, which is called a keyframe, which is like basically just JPEG encoding the image. And then you've got like a series of frames that are delta. And again, you get like a 10x factor out of them. So now the way it impacts our API is that in order to decode the second frame, you need to have decoded the first frame. And then in order to decode the third frame, you need to have decoded the second frame. And so now there's a dependency happening. So you cannot decode like an arbitrary frame. You need to have decoded like the frames before. And so this is why if you're trying to seek an arbitrary point in a video file, it can take like some like seconds to actually like redo all of those decoding up until that point. So this is all nice and good, but the people working on video encoding were not done yet. They had more ideas. And one of the key ideas, one of the key ideas that they had is, right now what we're doing is predicting into the future, but what about if we start from the end, we can also start predicting backwards. And so what they started thinking is, I'm going to try to predict into the future and see what file size I get. I'm going to try to predict in the past what file size I get, and then I'm going to pick the best out of them. And so this way you can even get like better like file size compression. Now, for example, in this example, like the slide number, like the image number 5 is what they call a bidirectional frame or a B frame. And so in this case, you need to have the frame number 4 and the frame number 6 to be decoded in order to decode the frame number 5. And so now, as you can see, this starts getting interesting. So that like in order to decode frame number 5, you need to have like 1, 2, 3, 4, and then also like 9, 8, 7, 6. And so the way you actually like start encoding this is you're going to like in your file system, you're going to like, you're going to need to send to the decoder all of those frames like in the right order in order to be able to decode like frame number 5. And so this is Another concept you need to understand is there's two notions of timestamps. There's the presentation timestamp, which is the time at which the image is going to be displayed to the user. So this is like the one you're thinking in your head. But there's also the decoding timestamp. So this is the timestamp at which the frame needs to be sent to the decoder in order to decode in a presentation timestamp. And so as you can see, like the first notion of like time is broken, where the decoding timestamp is not actually the same as the presentation timestamp, and they're like in different orders. So this is our first like mind-bending thing, which is like time doesn't only travel forward. So now we're not done yet. So now, like, how do we actually make like create and design an API for this? And so now the API is around like we're going to like load a video, and then we're going to create a decoder. And so the great thing is the Chrome and more browsers are implementing right now are implementing what they call web codecs. And so this is like video decoder and video encoder. And the API is like it takes a bunch of options, and one of them is on-decoded frame. And so it gives you a callback when a frame has been decoded. And so what you need to do is to start sending like frames in order to the decode function. And so when you send the first frame, then you're going at some point in the future, so it's not synchronous, you're going to get your callback being called with the actual image, like the actual bits and like RGBs for every single pixel. And so you're doing this for the first frame, the second, the third, the fourth, and like everything goes well. But then the next one is like you're going to send frame number 9, frame number 8, frame number 7, number 6, and you're never going to get any callback in all of this. And so it's just going to like hang until finally you give it frame number 5, and then it's going to like churn the work and everything. And then at some point it's going to give you like 5, 6, 7, 8, and 9. And so the consequences of this is that the mental model where like decoding 1 frames gives you 1 frame back doesn't actually hold true. And so this is like mind-bending because like in all of my career, when I called a function, it gave me a value back like instantly or like some delay, but like always gave me something back. But in this case, we came like, oh, you're just feeding stuff, and at some point, maybe in the future, it's going to give you other values. So this is this is the second one. And now the interesting thing is because like we have to give frames in a different order and everything, now there's basically a lot of metadata that accumulates, and we need to store it somehow. So it's no longer just the frames, but like there's a lot of information, such as, for example, like is it a keyframe, is it a delta frame, what is the like frame duration, and like what are the differences between the frames. And so if we were to build it in like 2023, like we would probably use JSON. Now all of those video encoding and like all of this space has like started like 20, 30 years ago, and they use like binary encoding. But in practice, you can think of this as like basically a JSON format, and with one particular, it is that there's some binary data, which is like the compressed version and the delta versions that is inside of this. And so, for example, like, oh, the encoded frame, like the first one is like a 400 kilobytes blob of data, and like all of the delta, like, I don't know, like 40 kilobytes. And so this file, this kind of files is called a video container. And so this is something you're probably like more familiar with, such as like MP4, MOV, AVI, MKV. And so this is how do you encode all of this metadata that's eventually going to be passed to the decoder. And so one other thing which is interesting about this is there's many different file formats like video containers, and all of them have different ways of encoding things and like different like names, but they do like very similar things. So at this point, we need to think and talk about performance. So I told you that like video encoding and decoding is like really performance intensive. And so in practice, the part that's very performance intensive is doing this, all of the compression, decompression that I talked about. This is like manipulating the binary data. And so this is one thing I was thinking about is like, okay, can we use like WASM to start using it and everything? But in practice, the industry today, in order to get like the best performance for video encoding and decoding, the hardware, like on your CPU, there's dedicated operations that are implemented on the GPU to do those operations, like Hoffman encoding, like fast Fourier transform and everything. Like there's literally like hardware dedicated for this. And so if you just write C++ and re-implement them in C++, it's going to be an order of magnitude slower than using the hardware accelerated version. And so the magic of web codec is it like it lets you use the actual hardware to do those operations. And so this is why like I'm super excited, and now we can actually do like proper like video editing on the web is because of the web codec API. Now, the thing, if you're trying to do it in JavaScript, like first, like even in C++, like if you use FFmpeg, it's going to use the hardware, and like the C++ is going to be slower. And then if you use WebAssembly, there's another like overhead happening on top. And so this is why we should like use like JavaScript and web codecs to use that, and like it doesn't make sense to use WebAssembly for this. The second aspect of performance, which is interesting, is like, oh, you need to actually parse all of this. You need to decode all of this, and you need to start sending all of this data to the web codecs. And one of the things is, okay, so WebAssembly is faster, so why like shouldn't I use JavaScript? And so for this, first, in terms of like what is the amount of time spent in this, so if you can see, like each line is like, I don't know, like tens of characters, but the binary data is like hundreds of kilobytes. And so like the overhead of each line is like completely negligible. So even if you're like spending like 10x the amount of time parsing this, like it really doesn't matter in the grand scheme of things. So writing JavaScript and like JavaScript engine are like pretty fast right now. So this is not a big bottleneck. But even more so, the way WebAssembly works is you basically recreate an entire memory space, like which is the C memory space with malloc. And then what you're doing is you're sending all of this data from the JavaScript memory space to the WebAssembly memory space. Then you do your computation, and then you send it back. And so as I mentioned here, like we're talking about like pretty big files, even with after compression. And so even if the running in WebAssembly, the code to parse all of this, you still have to send it to web codec, so you still have to send it back to JavaScript. And so now you have to do like a big copy, like 2 big copies in order to be able to use it. So in practice, it's like slower to run this operation, which is called demuxing in the jargon. So you'll probably have to know about it if you're implementing anything about this. And so this is why it's actually faster to use pure JavaScript to do video decoding in the browser. Now, one thing I want to note is that WebAssembly still has a role to play, because as I mentioned with demuxing, like we're talking about a bunch of video file formats, like video containers file formats, and have like a lot of like complexity. And there's been like for the past like 30 years, a lot of C libraries that have implemented this and are battle tested and are very robust. And in JavaScript, like this is just in the nascency. And so one of the use of WebAssembly is for code reuse. So we can actually convert and compile all of this like battle-tested C libraries into JavaScript, into WASM, in order to be able to use it. So now I've gone through like most of the like talk and everything, and like I don't know about you, but I was like pretty disappointed. I was like aiming to like basically like change the world, like make the best video editor, like start a new YouTuber career, and I barely got like video encoding working. So what I want you to get out of this talk is first, I created like an end-to-end solution that is actually doing like full video encoding, decoding, and re-encoding. And right now it clocks at around like 500 lines of code. And so, but this is working. And so this is something that like at some point, if you want to like play around and everything, now you can get something working and you can like start prototyping with it. So this is like good. And the second thing that I've done with this is I've proven that it actually works. And so the decoding and encoding process, I timed it against Final Cut Pro, and this is like almost the same time. And so like all of the like browser APIs and like are fast and are solids. And so now you can build like all of the cool stuff I wanted like on top of this. But the thing I want is like even more is like to challenge you. I want to challenge like every single one of you to like start taking what I did and build like basically the jQuery of video editing. So turning like those 500 lines of code, turning like you need to understand like all of the concept I've showed you into like, yep, I can just use an API that's like, hey, loads video, like do a video transform steps and like save the video and like everything just works. So this is my challenge to you, and this is the end of my talk. Thank you.
Whoever said never meet your idols because they disappoint you was absolutely wrong. What an honor it has been to share this conference with an amazing person who's part of the pioneering group of React. So thank you for that talk, Chris. Next up, we have Dax Rod, who currently is a part of the core team at SST. And Dax is going to be talking to us about the hidden infrastructure powering our front ends. Let's give it up for Dax.
All right, can you guys hear me? I'm not a Mac user, so this is gonna take me a second to figure out something. Oh, there we go. Okay. You guys have to help me out here. What do I do? Go that, and oh, I don't want it to be mirrored. I'm usually on Linux because I'm better than all of you, but there you go. I want this up there, but I want that side. Oh, there we go. And check the mirror. Perfect. Got it. Let's go over here. Oh no. How do we full screen now? What green button? Oh, this thing? I swear I know how to use computers. Okay, so welcome everyone. So we are here at React Miami, which is a front-end conference about a front-end framework. So I figured let's talk about back-end and infrastructure because I guarantee you no one else is probably gonna be talking about that. So to introduce myself real quick, my name is Dax. I actually live here in Miami, so I'm local, as you can tell from my outfit, probably. I live here with my wife, who's right there, who's here to support me, which is really nice. Everyone look at her, make her feel weird. I also live here with 2 cats and a dog. They're not here because they don't support me as much. So like I said, I do know how to use computers, despite what you just saw. I am one of the creators of SST. So SST is a framework that helps people build applications on AWS. I know big bad AWS, the thing that nobody wants to use, the thing that everyone hates, but we try to make it easier for people to use it. There's basically like 3% of AWS you need. Like some of you that were here from Michael's talk, he kind of went over a lot of that. And they're actually fantastic services and they're great to build with. It's just hard to use them, and we totally understand that. So we build a framework that is focused on that 3% and building a fantastic experience with modern developer experience to the degree that we can push it. We try to make it as easy as possible for you to build on AWS. And specifically, we're very focused on serverless and how can we like provide a really good developer experience for people that are building on AWS. So that's my background. That's what I work on day to day. It's a fully open source project. I get to work on open source full time, which is fantastic. And lately, we've been thinking about your front end. So SST historically has been mostly a backend framework. We focus on things like deploying APIs, cron jobs, queues, databases, all the stuff you need to power your backend and make it effectively infinite scale because we focus on the serverless side of things. And you know, that's where we started. It's where we grew. It's where community is. But of course, there's your whole front end, and we had people come to us say like, "Hey, we love you using you guys for the back end. It's going great, but my front end is still deployed somewhere else. Like we have everything in our AWS account, but our front end is deployed elsewhere," which is a totally fine setup. I think a lot of you might use things like Vercel or Netlify or Amplify to deploy your front end and have them take care of all that for you. But there are some benefits to kind of, in this case, we can consider it self-hosting your front end. So we've been thinking a lot more about that and helping people deploy various front ends to their AWS account. So just call it out. Like, what are some front end frameworks you guys use? Just yell it out. No, go higher level, meta frameworks. The framework on top of the framework that is the thing. Remix, what is that? Just kidding. So we got Remix, what else? Gatsby, okay. What else? Are you the same guy from yesterday that was yelling Angular for everything? So I'll finish it for you. So we got obviously Next.js. We've got things like Solid Start, which is newer. SvelteKit. We got SvelteKit. We got Astro. We got all these new things coming up. And the key with a lot of these new frameworks is, I think for the last 5 to 10 years, we've been building our sites statically and deploying them statically, which is very simple. But a lot of these new sites or new frameworks are all about server-side rendering. So we're bringing back the backend. We're bringing back the ability to run code per request. And that enables a whole lot of features. And these new frameworks are taking advantage of that and making it easy for you to render your front end from the backend and do everything you need to do there. But as a side effect, they've gotten a lot more complicated to deploy than just like building your stuff statically as an SPA and then deploying it to a static file server. So it's gotten very complicated. And like I said, a lot of you are using things like Vercel, Netlify, Amplify, so whole suite of companies making it very, very easy for you to use these things. And I wanted to dig into, it's great to use these things and like they hide a lot of complexity for you, but like just for fun, let's go look to see what they actually do. So that's what my talk is going to be about. The amount of work it takes to actually deploy what feels like a very simple front end to a provider like AWS. So this is hardcore engineering. This is like serious stuff that these people are doing. And I really wanted to capture the effort behind these things. And I found the perfect metaphor. There is something called the Airlander 10. The Airlander 10 is the world's largest airship. And it takes a crazy amount of engineering effort to get this thing literally off the ground. But when you see it, it's just this like, big thing that just floats. And like, you don't really think much of it. But it took like a crazy amount of effort to really get there. So here's a picture of it. I don't know why you guys are laughing. This is crazy engineering effort right here. And as we can all tell, this picture screams one thing, right? It takes a whole lot of back end to deploy a front end. I still don't know why you guys are laughing. So that's what we're gonna get into. So this talk is gonna be about Next.js. Sorry, Kent. I would have made it about Remix, but a bunch of Vercel employees showed up at my house and started threatening me, so I had to switch it and make it about Remix. I mean, how do you guys think they hired all those great engineers from React team? They threatened their families. But no, more seriously, the reason I'm going to do it on Next.js, I actually have never used Next.js. I'm giving you a whole talk about Next.js. I've actually never used it. But the reason I'm going to be talking about Next.js is, weirdly, so we do support Remix, and Remix is actually extremely simple to deploy to these. Probably Ken's nodding. There you go. I got your back. Extremely simple to deploy on all kinds of providers, and because I think they followed a model where like they actively made that a thing that they cared about. So if I did this talk about Remix, it would be like 5 minutes. So I picked Next.js because it's a lot more complicated and it's a lot more interesting to like dig into the deployment side of it. And I'm not saying it's complicated for no reason. It's because there's a lot of great features in there that are hard to replicate outside of Vercel. Let me see. Oh, just a disclaimer, because you're all a bunch of nerds in this room. This is going to be a little bit of an idealized description of how to deploy. Infrastructure is already boring. I don't want to get into details like, well, technically, AWS can only give you 20 behaviors per CDN, and like, there's going to be some things that seem inaccurate, but I'm like kind of smoothing it over so the talk is, digestible. Do not tweet at me being like, well, technically, you were wrong about this. I know. Yeah, exactly. Don't give me the actually. So disclaimer, it's more about the concept, less about the literal exact details. So how do you actually go about building and deploying Next.js manually? So the first step is called something called standalone mode. So Next.js does make it, they do provide some help to get you deploying in other places. They have something called building in standalone mode. What this does is it just ships a version of Next.js in a very raw format. It's like the output from the output of it is in a very raw format, and you can kind of take that and start to deploy it in different ways to get it all working. There's also a secret trick in there called minimal mode, which lets you do a few other things, and I'll get into that in a little bit. So when you build it in minimal mode, you get all of this stuff. And this is just I did a create next app, and I ran a build in standalone mode, and you get all this stuff. So you look at this, and you're like, okay, I'm not, like, who wants to deal with this? Nobody really wants to deal with this. So it is a lot, but in this talk, we're going to go through each part of it. It does seem really complicated. By the end of the talk, you guys are still going to think it's complicated, but maybe it'll be interesting to understand how it all works. So let's deal with the simplest things first. So static files, like what exactly are static files? These are things that do not change per request. So you can think about things like images. It doesn't matter who's requesting it, when they're requesting it. Certain images are just going to be static. Things like your CSS might be totally static. Your JavaScript might be totally static. You might have fully rendered pages that are totally static because it might be like, a landing page on your marketing site. There are things that just do not change. So what's great about these frameworks is you can opt into the parts that are dynamic, right? You can say like, okay, like these pages are very static, so just serve them statically. These pages, need to talk to the database. They do other more complex things. And when you run the build, Next.js will kind of split it out in that way. How do we deploy static files? So specifically on AWS, we use something called a service called S3. Yeah, S3. I'm sure you guys have heard of S3 before. So S3 is one of AWS's oldest services. It was the beginning of them terribly naming everything. So I think S3 stands for Simple Storage Service, something like that. And they abbreviate to S3, but they're also like, no, it's an S3 bucket. And now like we talk in terms of buckets, which is like, I don't know what a bucket of files is, but I guess that's what they went with. So S3 is basically an infinite file storage service. It can store as much data you need. It can serve it to as many people as you need. It's extremely cheap. It is one of the cheapest ways to serve static files. And then there are things that are cheaper, but for what you get, it is fairly cheap. It can handle serving files at any scale. But the issue with S3 is when you create an S3 bucket to put your files in there, it only is in one region. So if you deploy to Virginia, which is where half the world deploys to, we're all on the East Coast right now. You fetch a file from the S3 bucket. It's probably going to be pretty fast. People around the world, it's going to be kind of slow for them to fetch all the way across the world to the S3 bucket. So that's not enough. So you also need to put in front of it, it's called a CDN. And I'm sure a lot of you are familiar with this. A CDN is a content delivery network. So S3 buckets are located in AWS's main regions, and they don't have a ton of main regions because they're big, like huge data centers with multiple availability zones, and they're very expensive, and they have the most extreme architecture and performance and servers in there. But they also have these other locations, these CloudFront locations, which are a lot smaller, but like distributed way closer to users. So if they have like, 4 or 5 main regions in the country, they might have like hundreds of CloudFront locations across the country. So these locations are smaller, but they're nearer to the user. So CloudFront will sit in front of your S3 bucket. So when someone comes to request a file, they're going through CloudFront first. So they might connect. So if we're all here in Miami, we might connect to a CloudFront location nearby. I don't know where it is, but I know they do have some locations in Miami. We might connect there very quickly. And CloudFront will say, okay, what file are you looking for? you're looking for this image, maybe the image that we showed earlier of that airship. Does that location have it? No, it doesn't have it. Then it's going to go fetch from the S3 bucket. So that first initial request ever from someone requesting that file from this location will probably be slow. But from then on, CloudFront will cache it. They'll keep it around here in case other people in Miami also need to request it. So that's how you provide good latency across the world. These locations kind of lazy load all these static files over time. And of course, they evict them. If there's like not a lot of people here that are accessing it, they might evict it and they might refetch. But for the most part, building something that gets a decent amount of traffic, you put CloudFront in front, you're going to see some pretty good latency benefits there. So it effectively acts as a cache. It also handles things like custom domains, like if you want to route, mysite.com to the CloudFront to your site, you route it to your CloudFront distribution, and AWS will make sure that people get routed to the nearest location for them. At this point, you could be done with deploying your Next.js app if it's all static, right? If every single page of your Next.js app is 100% static, you can be done here. That's kind of what's great about a lot of these new frameworks. They support every mode. This is a fully static mode. They might support, slightly dynamic, like highly dynamic. You can kind of choose how far you want to go with all of this. So I think for most of us, for the past 10 or so years, we've been deploying kind of like this, and we kind of stopped here. And that's pretty easy. So next question is, what about dynamic routes? So if you look at the files that are here, you do see some JavaScript files, right? You see like pages, API, hello. So these are routes that are dynamic. So Next.js lets you create API routes, which is, they're not really meant to serve front ends. They're meant to serve things like JSON requests, just you kind of mix in API endpoints as you need, which are clearly dynamic, right? An API route is probably going to need to talk to your database. It's probably going to need to do some additional work. You can't statically compute this. So this needs to be deployed somewhere completely different. So these dynamic routes get deployed to a Lambda function. So are you guys familiar with Lambda functions? I'm sure. Yeah. Yes. OK, cool. A lot of excitement for Lambda functions. So what is a Lambda function? So this is something that AWS came out in, I don't remember the year. I'm going to make it up, 2014, let's say. Like I said, this talk is not going to be accurate. It's more about the vibe over the accuracy. So Lambda functions are a really innovative concept, and they're a very interesting way to do compute in the cloud. So instead of, historically, it was rent a server. And when you're renting a server, what you're saying is, I am pre-buying capacity that's going to be running all day. It's going to be running 24/7. I'm going to need it every month. And I think when I started getting into the cloud and all this stuff, you paid per month pretty much for the server. Then at some point, AWS was like, OK, you don't have to pay per month because we know that you might only need it 8 hours of the day. So you don't need to pay for the whole month. You can pay for the server by hour. So you might want to run the server up during the day and like shut it down at night, or like have fewer at night. But they kept going with this and saying, OK, now you can pay by the 100 milliseconds, right? And that's when Lambda functions first came out. They were saying, OK, you don't have to run up anything at all. Just give us a code. Whenever it needs to be executed, we'll spin something up, run the code, we'll bill you per 100 milliseconds, and we'll shut it down. So that gives you crazy granularity on how much compute time you're actually using. And these numbers end up being very counterintuitive. I think a lot of people think like, oh, that's probably like 20 or 30% cheaper. I consulted with a company where they're like a full real stateful deployment. They were spending around $3,000 a month for. For real workloads, you need to make sure it's highly available, all kinds of things. We moved it to Lambda functions, and it dropped down to $50 a month. So from $3,000 to $50, like it is kind of crazy when you use this stuff correctly. It can get really cheap, especially at scale. And another interesting fact is I said 100 milliseconds. That's what it was when it first came out. So if your function ran for, let's say, 20 milliseconds, it got rounded up to 100 milliseconds, which is fine because it was still cheap. And then at some point in the last couple of years, AWS said, hey, you know what? We can now bill you per 1 millisecond. So overnight, if that function was running at 20 milliseconds, your bill just dropped 80% overnight. And so what's kind of cool about using some of these platforms, people are afraid of things like vendor lock-in, and that's definitely a thing. But with the modern set of cloud companies, they've kind of learned from the previous set of companies that like really focus on lock-in and trapping their users and how that doesn't work long-term. AWS definitely understands that they need to be driving costs down infinitely, because the moment they stop doing that, people are going to hate them and want to leave somewhere else. People already hate AWS enough; they don't want to hate them for the pricing side of things. So Lambda function is one of the best ways to say, I need to run some work. Here it is, and run it. And not everything can be modeled in a Lambda function. I think a lot can. I think people underestimate how much can be built this way. Like I built some really crazy full applications purely on Lambda functions. But people kind of see them as maybe they're kind of like toys. So, but you can do a lot with them. So we take the dynamic parts and we deploy them each as a Lambda function. So each route, like your hello route, maybe like a front end route that rendered something from the database, each one of those gets deployed as a Lambda function. The CloudFront CDN will check, okay, what path is this request for? And then it'll send the request to the appropriate Lambda function that handles that. So just a quick aside here, why not just one big function? Why make a separate function for each route? The one thing to consider with Lambda functions are cold starts. Cold starts are not well understood. Not every request creates a cold start, and what a cold start is you give them the code, they need to boot up something to actually execute the code. I think there's some misconceptions that every single request causes a cold start. It's not exactly how it works. The first time you deploy your app, nothing is running. When a request comes in, it will cold start to boot something up, but then they keep it around. They kind of keep it warm for a little while to serve any additional requests. So over time, you'll have a pool of warmed functions. But cold starts are a real issue. When you split stuff into separate functions, that lets there be fewer dependencies per function. Hypothetically, you might have one really fat, chunky dependency in one function that's not used by the rest. So if you put it all in one big function, it kind of gets put into one bundle, and that kind of creates worse cold starts. So we try to split it up into separate functions so that you'll get more cold starts, but they'll be faster. It is kind of a tricky trade-off. So the next thing here is NFT files. And this is the only time in the history of Miami that someone's going to say NFT and it's not going to be a scam. So what are NFTs? So NFT files are, they kind of show up alongside, you see in the JavaScript files that we deploy for the server functions. This is a cool thing that I think Vercel actually created this library. And there's a few different ways to do this and a few different tools to do this, but NFT basically takes the function that you want to run, the code you want to run, and traces all the dependencies and says okay, they're using this dependency and that dependency is using these files and those files are using these other files. And it creates a tree of all the dependent files. So you can't just deploy this hello.js to AWS Lambda. You also have to include all its dependencies. So we will trace these NFT files, find all dependent files, bundle them up into one single thing, and then deploy to AWS. So it's great that those files are there. It helps us do that. Keep track of what dependencies everything needs. So what about middleware? So middleware is a new feature in Next.js 13. They're basically little plugins that you can add to your Next.js application. They can intercept requests, modify them, return the responses. So they're not meant for heavy logic, but for simple things like, oh, I want to add an internationalization header. I want to do a little bit of auth, kind of basic things like that. So we need to deploy the middleware. So we deploy the middleware to Lambda at Edge. So originally, AWS released just AWS Lambda functions. Over time, they released Lambda at Edge, which are basically just the same Lambda functions, but running in those hyper-geographic CloudFront locations. So the reason we run middleware there is because they intercept the request. Sometimes they can just short-circuit it and respond right away. So let's say someone's trying to access a page that requires authorization. The middleware function at Edge can decide, okay, this person isn't even sending me an auth header. They're not allowed. Why even let the request make it all the way to the regional location? Let's just give them a 401 right away. So middleware is great to run at Edge because it can kind of intercept some of these things early. You kind of get better performance. It can also modify the request and add additional details before it goes to the Lambda function in the region. So you can do things like look up the client's geography, different things, whatever you want to do. And you can deploy that at Edge. We also support running everything at Edge. So you can also say, don't even put the Lambda functions in the region, just push them straight to the Edge. So everything is running at Edge. There are a lot of benefits of doing that. Most architectures aren't really set up to do that well today. So we don't see a lot of people taking advantage of that. But it is a very cool setup. You just need to be, the reason it's tricky is if you move your Lambda functions closer to your user, they're getting further away from your database. So a lot of things that you assume will be fast start to become slow, and you might actually get worse performance when you push Lambda functions to the edge. So I generally don't think everything's going to go to the edge, but if you do build a very sophisticated architecture where you still have like a regional API and your Lambda and your Next.js app never talks directly to your database, they send like single requests to your regional location, then it can make sense to use kind of push everything to the edge, but you have to very specifically architect for it. The next thing is ISR. So what is ISR real quick? I'm running out of time. ISR is complicated. It's a feature in Next.js that lets you cache pages that you've rendered already, and then serve a stale page, but say, okay, if we've been serving this stale page for too long, let's like recompute it asynchronously. So the next person that shows up gets a new version of it. So it's a little bit complicated for now. Basically, a request will come in to basically they'll hit the middleware, and the person will always get an instant response. So whatever the last known version of this page is, we're going to serve them right away because we have that saved in the cache. But we're going to say, okay, we served them this page, but we haven't regenerated it in a day. So let's put it into a queue. SQS is another AWS service. It's effectively just a queue. You can put stuff in there. It can reliably trigger other Lambdas. If the Lambdas fail, it'll still re-trigger because it's stored in the queue. And you can kind of do very powerful because you can make sure stuff never fails. You can scale things out massively in parallel. It's a great fit here. So we'll put those requests to say, hey, we want to, okay, we serve this old page to them, but in the background, we're going to send it a request to regenerate a Lambda. That's going to regenerate the page and then save it in the S3 bucket. So the next person that gets it still gets a new version of the page. And that's very useful for things that like you want people to have the latest version, but you don't like absolutely care about them having the latest version all the time. So you might say, okay, it gets stale after an hour, so at most recompute it per hour. But like outside of that, I don't really care about them having the newest thing. And again, what's great about these frameworks is a level of control to say exactly the trade-off between performance and the amount you're willing to pay for computing things. The reason I said complicated for now is there's a new feature coming to CloudFront called SWR, stale while revalidate. These are a standard, so ISR, incremental static regeneration, was a kind of Next.js Vercel creation. SWR is basically like an open standard that effectively does that, and CloudFront will be supporting that soon. So ISR will kind of go away. It's kind of an artifact of the way things are currently done. So one last thing, because I know this is getting boring, image optimization. So another great feature about Next.js is it does a bunch of image optimization stuff for you. So there are special routes in Next.js. I think it's like underscore images. Something. Again, I'm not a Next.js user. I don't know what I'm talking about. There's an underscore images route where it'll do image resizing. So instead of directly serving images of a certain size, it can kind of compute depending on the screen, depending on whatever it needs. Here's the size of image I need, and it'll make a request to this special path. So we deploy yet another Lambda edge function, because again, this is the type of thing that can be done at edge. It doesn't need to really talk to a database or anything. Where that'll try to figure out, okay, have I pre-computed an image of this size already? If no, let me fetch that image from the S3 bucket, resize it, and then save it in the cache with sort of appropriate cache headers, so this doesn't have to be recomputed all the time. So what we do here, it's kind of interesting. Lambda also supports ARM, so there's a flavor of Lambda that runs on ARM CPUs. These are a lot faster, these are a lot cheaper, and they're a lot more efficient. So for doing things like image resizing, we pre-compile a library called Sharp for ARM. Sharp is a native image resizing library that has JavaScript bindings for it. It just resizes images very fast and very effectively. So we do that and we deploy that to Lambda at Edge. And that is roughly it. So again, a little bit idealized. There's a lot more chaos here than what's already the chaos that you're seeing on the screen. But this is pretty much it. So your Next.js app, which feels like a single simple thing, is actually this amalgamation of like all these different services working together. And this is just one opinion on how you can deploy Next.js, right? This is our flavor of deploying on AWS. Every single piece here, you could have made different decisions. So we try to figure out, okay, for 95% of people, what is the best setup for them? And this typically works. And of course, none of you want to do this yourself. Don't do this yourself. It's dumb. There's no point doing it yourself. I got to show my product a little bit here. So this is very complicated, but ST can do it for you. This is 4 lines of code in TypeScript. So the way we work is everything we build You can like spin up all the infrastructure you need just by defining it in TypeScript, and we will deploy it into your AWS account. So 4 lines here, new Next.js site, add the path to your Next.js app, add a custom domain. We'll do SSL certificates, everything, and just get this all deployed. Again, most of you probably don't need this to deploy to your AWS account, but if you're working at bigger companies that are at a scale where some of these other providers are too expensive, or you just need everything in one place for compliance or organizational reasons, that's why you might do that. So yeah, go check it out. I appreciate it. And that is all I have. Follow me on Twitter. 9 out of 10 tweets are not useful, but 1 out of 10 tweets are very useful, just like this talk. So yeah, follow me, and thank you, everyone.
Thank you, Dax. One of those 9 out of 10 Twitter, tweets rather, Dax was talking about is where he started a rumor that Bad Bunny is coming to the conference and that he's going to be headlining. So quite entertaining on Twitter. But thank you, Dax, for that talk. Next up, we're going to welcome Alexandra Sikora. She is currently an open source developer, and Alexandra is going to be talking to us about taking a rest from rest. Let's go ahead and give her a round of applause.
Oh, we're good. We're good.
Yeah, I think so. It's down. I will close this.
Just go ahead and hit play on it.
No, wait a second. Because... We got it. Awesome. Thanks for your help. Hello, everyone. I'm super excited to be here. This is really an amazing conference. I'm really I was sorry that I missed that last year, so I'm even more excited to be here as a speaker this year. So a few words about me before we begin. I work on open source at the Guild in the GraphQL ecosystem, and I was previously a Blitz.js maintainer and was working at Hasura. And in my free time, I love all things climbing. Actually, after this conference, I'm going to Italy to do some hiking and climbing, so I'm super excited about that. And as you might have guessed, my talk will be about APIs. But when I was preparing this talk and when I was thinking about it, I found quite an interesting parallel, and it was super tempting to include it. So here it goes. This parallel is fashion. And we're going to find out why during this talk. So first, I'm not like super obsessed with fashion, but I like nice things and I like staying up to date. But it's quite hard. Like fashion evolves like really, really quickly. So if I wanted to be up to date all the time, I would have to replace my wardrobe like every few months. And it doesn't sound practical or sustainable. And on the other hand, it's worth to notice that not everything new in fashion is truly new. Like every few years, we see a trend from the past coming back. For example, like my dad's shoes. I'm not sure if you can see them, but this is like the second one on the slide. And they were created in the mid-90s, and yet they are still super popular, and I absolutely love them. But I don't love everything. Like those things can get quite crazy. And do I have to love everything? Like, do I have to absorb everything that's latest in fashion in order to call myself fashionable? Probably not. But you didn't come here to this conference to talk about fashion. So what does it have to do with APIs? Well, during this talk, I want to show you that the evolution of APIs and the evolution of fashion actually can have a lot in common. And we're going to see some trends that are coming back, and we're going to see how they relate. And as attendees of a React conference, you are likely aware that the ecosystem around full stack development in React is like really, really evolving. And you have amazing frameworks like Next.js, Remix, Redwood, and more. So in this talk, we'll explore this full stack development. And in particular, we'll explore working with this API layer and what are the problems and what are the solutions there. So first, why are we talking about it? I think my slide didn't change. Yeah. Okay, so why are we talking about it? Like a common scenario for a full stack application is that you have a client and a database that you want to access. But even if your database was like publicly accessible, you can't call it from the client because that would expose all your database credentials. So we have servers that are responsible for talking to the database. But since we have servers, we need an API. We need this bridge that connects the client and the server. But whenever you have to connect like two separate entities and make them talk to each other and understand each other, that's when we can face some problems. Even if those entities are in the same repository, written in the same language. So we face some problems like a lot of boilerplate, we are losing type safety between client and server, and we also have to deal with repetitive error handling. So now let's take a look at it from a full stack TypeScript application perspective. We are in the world of React, possibly within a Next.js application. The server and the client are already so close, and they are both perfectly type safe. However, adding this API layer can compromise our type safety. While we could generate types or we could write everything manually, it's an extra work, and it's something that sounds tiresome. So what can we do about it? Well, before I tell you, we're going to do a little bit of time travel, and we're going to the past to see how the API changed and evolved. First, we go back to the early 90s, the beginning of web services. So what was the beginning? Remote procedure calls, the simplest and least constrained form of an API. And let's start by explaining what our RPC is. Look at this example of a local procedure. Now, imagine that this welcome function is on a different process, a different server. So now, in order to call it, you need to use a network. And this should sound like a common full stack scenario. So what we're doing here, we remotely call this procedure. So that's an RPC, remote procedure call. And RPC API is built by defining methods, and then the methods are called with arguments. So for example, in the context of HTTP, if the API was using HTTP, we would send a request to an endpoint with the method name, and we would pass arguments in a body or query. Of course, that's not how RPC looked like in the 80s because there was no HTTP yet no JavaScript, but that was the idea, to be able to call remote procedures as if they were local. Yet there were a bunch of problems with RPC. And this whole procedure convention made client and server tightly coupled. So it was quite difficult to be consumed by many client applications. It was also bound to a specific language, which was considered a problem at the time. There were some other problems like no request cancellation, having to use multi-threaded servers, parameters marshalling. And some of those issues are not even relevant anymore. But since the biggest problem was being non-agnostic, the next thing that came after RPC was supposed to solve this problem. So now we're looking for something agnostic. And we're going to the early 90s. And what was cool back then, apart from boy bands, Nintendo, and rollerblades? Object-oriented programming. So we have Corba in the early 90s, a language-agnostic standard. A server in Corba is a process that contains objects, and the client is a process that makes calls to get those objects. In order to be agnostic, Corba introduced something called interface definition language. And what it does is it's doing the mapping between different languages. That was quite a huge improvement for distributed programming. And one of the most popular ideas that you might have heard about is currently protobuf. But the goal of being, my slides didn't change. Oh, yeah. Okay. The goal of being platform language agnostic added a lot of complexity and caused Corba to have a steep learning curve. And this mapping problem turned out to be quite difficult because we can't really map everything. So maybe being agnostic wasn't worth all the complexity. And the next thing that developer wanted was something simple. So here we go, literally, a simple object access protocol. With SOAP, the request to the API is an HTTP post by default, and it has an XML body. This XML body consists of something called SOAP envelope, which is like a wrapper that identifies the requested API. There's a SOAP body, which holds the parameters, and so on. That was quite an improvement after Corba, and in fact, it's still being used till this day, particularly in older systems where security is crucial, like airline systems. But it was heavy. It was XML only, which made requests to require more bandwidth. So another problem was that it was tightly coupled with the server, like the client was tightly coupled with the server because it had this strict communication protocol. And we're kind of back with the same problem as RPC. So what we're looking for now is something light. So we have 2000s, and this is when the web started changing. The work on HTTP was progressing, and Roy Fielding from the same working group created REST. In fact, HTTP 1.1 is the first API that strictly follows REST principles. It's not a protocol like SOAP. It's rather a set of architectural constraints. By default, it's intended for the server. It's intended to be consumed by many clients, and it makes server data available in simple formats, and very often in JSON. Client and server are completely independent, so they can go over many changes, and it won't affect the communication as long as the schema won't change and the constraints are not violated. So to compare it with SOAP, in SOAP, you really had to say a lot. Like there was this SOAP envelope, SOAP body, SOAP parameters, and so on. And with REST, it's much simpler. So to compare it with RPC-like APIs, REST is about resources instead of procedures. So here's a comparison of a similar API in REST and RPC. So in REST, you ask the server, give me the state of this resource, or here's the state of my resource, please store it somewhere. And with RPC, you're more like, hey, can you call this procedure for me? Then what was the problem? Well, REST is quite hard to implement. Having those strict constraints, like it gave developers a lot of guarantees about the API, but following all of them was quite difficult. And in fact, most of the REST APIs that call themselves REST are not fully RESTful. But like no matter where your API is on the scale, we have some other problems like overfetching, so requests containing a lot of unneeded data that the client doesn't really need. We have N+1 problem, so having to do multiple round trips to the server to fetch data for a single view. So in summary, REST turned out to be quite inflexible for the rapidly changing clients. So now we would like something flexible. So here comes GraphQL, aiming to solve some of those problems. With GraphQL, it was very easy to eliminate the N+1 problem from the client perspective, because you can send one request to the GraphQL endpoint and fetch all the data you need. It was also easy to eliminate the overfetching problem, because it's the client who decides what data it's going to get. So the server provides it with a schema, and the schema has information about what resources are available and what are the relationships between them. And based on that, client can decide what it needs and articulate a query. But the truth is that GraphQL shares some similar concepts to SOAP, which means it also shares some of its problems. But the difference is this time we have JSON instead of XML. So with GraphQL, we have to have a type safety, we have to generate types, which isn't a huge deal, but it's an additional step we have to consider. We have the same post caching problems because the requests are by default post, and post requests are considered normally idempotent, so there's no caching on the HTTP level unless you use GraphQL CDN that popped up a few years ago. And writing GraphQL servers is also considered quite tough. It usually pays off, but it's a lot of boilerplate. So maybe with the next thing, we could have something without this extra work and the type safety out of the box. So now we have 2020. And in 2020, we had 70s and 80s coming back to fashion. And it was the time when vintage clothes were becoming super popular and the vintage nostalgia was like everywhere. And if you're not into fashion, you might have noticed that somewhere else, like in TV series like Stranger Things, it was all about vintage nostalgia. So now we have, again, RPC, and we're going to revisit the original promise of remote procedure call. But first, let's quickly bring up the topic of fashion. So why does fashion evolve? Like, there are a few reasons. We are bored, we are looking to stand out, we want to express ourselves, or maybe fashion designers and influencers like influence the mainstream trends. But another factor that is very important for the evolution of fashion is the world around it. One example is that my slide didn't change again. Oh, yeah, here it goes. Okay, so one example is that pandemic led us to having like much more oversized clothes because we all wanted to feel comfy and protected. And interestingly, around the same time, there was a shift in the world of APIs. One technology in particular, Prisma, had a significant impact on the development of the new tools. If you're not familiar with Prisma, it's a fully type-safe ORM that makes working with databases like extremely easy. Everything is type-safe. They really push TypeScript compiler to its limits. And after it was released, like the initial version in April 2020, we saw new tools like Redwood, Blitz, TRPC coming up, and they all leverage the excellent developer experience given by Prisma. Because suddenly, like, working with database became much, much easier. So it was time for APIs to catch up. And let's revisit the picture of the server and the client. We are working on this full stack TypeScript application. How can we minimize the problems that I've been showing you before with the API layer? We can minimize the layer itself. So we have those amazing tools right now. Like we have TRPC procedures, Blitz RPC resolvers, Quick, Remix loader pattern, React server components, and there are more that I didn't even include on this slide. And what they all try to do is to minimize this API layer and to kind of take the burden away from us. So let's start by looking at Blitz RPC. This is an example of Blitz RPC query resolver. So it's just an async JavaScript function. It's called getProject, and inside I can do any processing that I want. Currently, what I'm doing is I'm accessing the database and I'm getting a project from it. So that's the backend part of Blitz RPC. Now, what if I want to call it on the client? This is a React component, and inside I'm using useQuery from Blitz RPC package, which is just a wrapper on TanStack query, which adds some additional stuff to make it work with Blitz resolvers. And inside, I'm first importing the function that I wrote on the backend, and I'm providing it as first argument to this use query. But you might wonder, like, what's going on here? I told you before that you can't call database from the client because that would expose all your database credentials. So what happens here is Blitz magic. During the build time, Blitz replaces this import of get project function with an HTTP fetcher function so that there's no backend code ever ending up on the browser. And my slides are super slow today. Okay. Yeah, this one. Okay, so now let's take a look at a similar example of tRPC. It's basically the same logic. I also have a get project function. The difference now is the developer experience. I now have I have to create a router, and inside I have to provide information about all the procedures that I want to be available with my tRPC API. I then expose a type of this router so that later on the client, I can use this type to create a fully type-safe tRPC client. And in my component, I'm kind of using it in a similar way. I'm calling this, I'm using this client that I created, and it already knows what procedures are available. So I'm using get projects from this client, and it knows that it's a query. So I can use query and provide arguments. But now, what if you can push it even further and have the backend code in the same file? So let's take a look at an example of Blink, with Tanstack Blink. What happens here is I'm using useQuery from Tanstack Query, and inside my query function has a call to the database. You can see this async function, and I'm literally calling the database in a React component. It's the client component. It's something that will be rendered in the browser. So how does this happen? So you can notice this server $, function, and what it does is two things. First, it extracts the content, this async function that makes a call to the database, to a separate file and makes an endpoint from it. And then it replaces it with also a fetcher function. So kind of similar thing as with Blitz, but this time instead of using Webpack, because Blitz RPC was using Webpack, this time we have Vite. And now React Server Components. With React Server Components, we can push it like even further, because now I'm not even having like any macro functions and other utilities. I'm calling the database directly in my component. So how is that possible? It's possible because it's the server who drives what data is fetched and what UI is rendered. So then the client becomes only responsible for the UI interactions. So all the backend stuff will happen only on the server. It won't end up in the browser. It should look kind of familiar to, it should look like back in the good times, around 1996, when the Fila Disruptor shoes that I'm currently wearing, those ones, and PHP and me were born. And I'm almost done now with my presentation, but I wanted to leave you with one more thing. Look at this iconic denim total look from 2001 by Britney Spears and Justin Timberlake. It's something that kind of looked ridiculous, and it was being laughed at for years. And now it's kind of coming back to fashion. Like, we can see those denim total looks back on the runways and in this season's trends. So in the world of APIs, we also see another trend coming back to fashion. Speaking about all the solutions I showed you before with RPC, they are all awesome. They serve a purpose. They tightly couple the server and the client, but they do it intentionally because we operate in a full-stack TypeScript application anyway. But now, what if we wanted to decouple it? There's still a use case for it. However, now the bar is much higher, because now type safety is a must. TypeScript de facto became a standard, so the type safety part is non-negotiable. So let's talk about REST again, because now we have tools like Bridge.js, Stainless, and Fets bringing it back. And during this talk, I'm going to show you one of them. I'm going to show you Fets client This is something that my colleague from the guild is working on. So with Flex client, you can create a REST client based on an open API specification. So based on a specification that describes your REST API. So, so you just have to have this specification, and then when you have it, you can pass it to a create client function along with an endpoint that your client is supposed to access, and everything there is type safe. Like you can access some information like what's under the project / ID route. What's the type of that? What are the methods available? You can make calls to, if my slides change, oh, okay. You can make calls to your clients, and all the responses, all the errors, and everything else will be fully type safe. And it's all out of the box. There's no generator. You don't have to generate this client. You don't have to generate those types. You only have to, have this open API spec. There's no runtime overhead, so because we're only providing the type, which will be stripped, so no schema will ever end up in your bundle. It has support for Node.js, Deno, Bound, Cloudflare Workers, and more. And we have, out of the box, we have all those editor features like auto-completion and so on. So let's wrap it up. With all that I showed you, like this going back in time and going back to some previous solutions, it might look like we are going in circles. But perhaps we are just getting closer to the core of the problems that we want to solve, and perhaps we are just removing all the layers of boilerplate, and we are just removing all the complexity. And as we all are different, and we have different styles and preferences, so are our projects. So same as we compose our wardrobes based on our needs, we need to evaluate the needs of our project before deciding on an API solution. And same as in fashion, something that is super trendy right now and works in one place may not suit everyone and everywhere. So it's good to know your options. It's good to know what's going on in technology, but don't jump to the newest trend only because it's hyped. And don't hate on your previous API solutions. They are like last year's clothes. They still serve a purpose. So let's learn to follow trends and take what's best. And always embrace the change and be ready to adjust your approach, whether it's trying a new outfit or a new API paradigm, because adaptability is a key in both worlds. It allows you to stay current and relevant. So what's next? In this age of OpenAI, ChatGPT, will we have a new revolutionized way to deal with APIs? Something that is so generalized that AI can produce and consume it? I don't know, but I'm very eager to see and hope you are too. Thank you very much. You can scan this QR code. It will take you to my blog. And there you can find all the links and some notes from this presentation. Thanks.
Thank you, Alexandra. Alexandra was a little nervous backstage, so it's always funny seeing that and then just seeing the speakers get on stage and absolutely kill it. Great job. Okay, so we're going to go ahead and grab, oh, yes, round of applause. Actually, let's go ahead and give a round of applause to all of the speakers this morning. The talks were very insightful. I hope that they give you something to go out and network about. Remember, the goal is 5 new connections each day. I hope you met your quota for yesterday. If you didn't, it's okay. You have plenty of time to make up for it. But let's go ahead and grab a refreshment break. Meet us back here at 11:20 for our next talk. See you guys.
Base is the fastest way to build innovative software and turn application ideas into seamless cross-platform experiences. Want to store relational data in the cloud, securely authenticate users, integrate multiple data sources, harness the power of GraphQL? 8base gives you all of that and more instantly, pre-configured on AWS and available through a single API endpoint. Need to conquer ambitious projects with a limited team? 8base gives normal developers the capability of back-end specialists and is DevOps free, allowing your team to confidently move at lightning speeds. Plan to support millions of concurrent users? 8base scales infinitely on top of a proven serverless cloud architecture. All of that is easily managed through a single intuitive web interface.
We did it. We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with features my users want. I can create a custom two-factor authenticator for added security and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Ow! Dang. Thumbs.
You know, there's an easier way to get thumbnails. Quickly grab a still from anywhere in your video with the Mux API. All it takes is some query params. Thumbnail.
What about GIFs? What? Not you, Jeff. GIFs.
I thought it was GIFs.
GIFs, GIFs, all the same to Mux with a simple GET request. Because video is fun with Mux.
Rabi Abdul Wahab, Managing Director of Engineering at CityTech. Anytime you join our company right now, or in the next 10 to 15 years or 20, you can actually create your own career path. There is a lot of growth and a lot of paths that can be created and still doesn't exist as positions right here. That's why I'm here. The curiosity of where can you go next with all the growth that we're seeing.
The future of this company is so bright. I'm so excited to be a part of it.
I think when you join City Furniture, you're not here for a job. You're here for a career. And I absolutely foresee a future where this is my lifelong family.
8base is the fastest way to build innovative software and turn application ideas into seamless cross-platform experiences. Want to store relational data in the cloud, securely authenticate users, integrate multiple data sources, harness the power of GraphQL? 8base gives you all of that and more instantly, pre-configured on AWS and available through a single API endpoint. Need to conquer ambitious projects with a limited team? 8base gives normal developers the capability of back-end specialists and is DevOps free, allowing your team to confidently move at lightning speeds. Plan to support millions of concurrent users? 8base scales infinitely on top of a proven serverless cloud architecture. All of that is easily managed through a single intuitive web interface.
We did it. We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulated.
Ahoy, me hearties. Thank you for making it back in time. Our next speaker is going to teach you the alphabet of performance. Community lead at Web Page Tests, also by Catchpoint. I welcome to the stage Henri Helvetica.
Bam, bam, let's go. All right. Okay, so thank you everyone for coming back from break. Yes, that is a pretty big QR code, and if you click on it, you'll just get everything that he said and then more. My name is Henri. I'm from the greatest city on the planet, which is Toronto, Canada. And not Toronto, Kansas. I found out the hard way that there is a Toronto in Kansas, and I don't know why. But I also work for an amazing company called Catchpoint, where we sort of like go into internet performance monitoring, amongst other things. And we have an amazing tool called Web Page Tests. Anyone here familiar with Web Page Tests? Cool, a few of you. Awesome. And we're going to not so much talk about the tool, but we're going to talk about web performance, certainly. So one of the things that I'd love to talk about, obviously, is web performance. And today what I'm going to do is I'm going to kind of go through web performance and talk about sort of like web performance literacy and talk about what we look at when we basically look under the hood of all your web apps and websites online, and we talk about, you know, how we can improve the user experience. So with that being said, we're going to get things going right now. So as was mentioned, we're going to go through the alphabet, and I'm going to talk about pretty much terminology associated with web performance, starting with A. A, in our case, is going to stand for AVIF. So anyone here familiar with images? Yeah, okay, AVIF is one of the newer image formats. It's been out for a couple years now, but what we get out of that is compression. a smaller image format is always going to help your user experience. In all likelihood, and I say in all likelihood, but there are some exceptions, it's going to load simply faster. So keep that in mind. That's AVIF. Let me just move this. I'll be more comfortable. Now, we're going to talk about the letter B. B is going to stand for broadly. Who here is familiar with broadly? All right. Broadly is kind of like a cousin to gzipping. All right. So one thing you have to remember that there's nothing that happens on the internet without compression. And with broadly, you're able to get better compression than gzipping. So a lot of your text assets, everything that comes down the wire essentially is being compressed, and broadly is the preferred compression standard. So let's look at C. C in our case could stand for caching, but we are going to talk about Core Web Vitals. Familiar with Core Web Vitals? Hands up. All right. So this is a way, it's like a triplicate of metrics, and you're able to sort of gauge the health of a site or a web app. So it stands for, Core Web Vitals are something called LCP, which I'll talk about a little later, largest contentful paint. CLS, which stands for cumulative layout shift, something I won't talk about later. We could talk about outside in the hallway track, and something called FID, which is kind of like an interactive metric that is there for now, but long story short, it may be sunsetted for something a little better. Now, let's keep going. We're going to get into D. D is going to stand for defer. So with JavaScript execution, sometimes you want to have it execute immediately. All good. Sometimes you want to have it executing a little later, like you might use something like the async attribute. But in this case, we're going to talk about defer, where you're going to get that executed much later later after the HTML is parsed, because sometimes you have some JavaScript that you do not need to have executed right away. That might create like some long tags or something of the sort, but that's something you want to also look up. I'll be sharing the slides later on. That's why I have some of these links, because it's ready to go. E is going to stand for emissions. Now, this is something that is becoming more du jour, simply because we are starting to really pay attention to carbon emissions. And believe it or not, the internet has a significant footprint. Anywhere from 1% to 2% of carbon emissions right now on the planet are due to the internet and everything that we do. So we are starting to look at that very closely. You're going to see some mandates coming out of Europe in terms of reporting around carbon footprints. And this is very closely associated with page weight. So if you don't manage the weight of your page properly, you're probably creating quite the emissions into the atmosphere. Let's talk about F. F is going to stand for fetch priority. So in this case, the internet is a wonderful thing. Browsers are a wonderful thing. And we're able to start to create situations where we want resources to load faster and earlier. And with fetch priority, we can do that. Now, has anyone played around with fetch priority yet? All good, a few of you? No problem. It's sort of like akin to like prefetching, preloading, pre-connecting. But what we're trying to do is to get the resource to execute or load as quickly as possible, because it might be something that we need to have done right away. Anyone know what the next letter is? Okay, that actually is mine. They put out a little campaign, and it is a soft G, folks. I'm sorry. So GIF, yes, the letter G. And, you know, I was just trying to be playful, but the problem is that this image format is long in the tooth. Surprisingly, we still see a lot of it on the internet. It's a lossless format, which means it tends to be very heavy. People love animating the GIF because they want dancing cats on their page. Hey, that's all good, But the problem is, like I said, it is a heavy format. And we're finding out, again, as I mentioned, the heavier the page, the more emissions you're creating. All right. So there are ways of managing the GIF. Most of us like to have like maybe an actual video instead, but we understand the GIF provides this user experience that people love. But all I'm saying is manage it as best as possible. The greatest letter on the planet, which is H, obviously. This stands for HTTP. All right. The protocol that we love that basically gets all the resources down the pipe that we need. Now, most of you are probably using HTTP2, which allowed for something called multiplexing, where you're able to sort of get a lot more resources on one connection. You probably, if you look under the hood, you'll see that some resources are coming down using H3, all right? But unfortunately, you still see some resources on the net using the antiquated H1.1, where you're essentially not getting the speed and the connections that you can. So this is something that you definitely want to keep in mind. Sometimes you might have a slow site. You're like, okay, what's going on? I thought I did everything well. And when you pop the hood open and you see that there's a bunch of resources still coming down on H1.1, and it's actually a little surprising when we see that, because it's an old protocol that we really don't necessarily need because H2 is here. The letter I. Now, this is always kind of interesting because people love images, but in recent years, we've really found out that images are very challenging. And essentially, between like, screen densities and, like the formats that we have, ultimately, you might want to sort of like, how could I put it? Offload that to a service, maybe something like Imagix, something like Cloudinary. But the bottom line is images do create their own problem. Years ago, I gave a talk about images, and I was like, oh man, images, new formats, and people didn't really know what I was talking about. But they've become, like I said, a bit of a burden, and that's because page weight. That's also because, getting the right size down, because we're seeing, again, as performance practitioners, we pop the hood open and we're seeing poorly sized images, desktop assets going down to mobile. So these are things that we try to remind folks to manage as best as possible. Now, the letter J. So once upon a time, I gave this talk and I used to say like J stands for jank, because that was actually a term that we used to use. But in our case, I'm just going to talk about J standing for JPEG. And again, images being a bit of a challenge. The JPEG, the reason why I brought it up is it's actually a 30-year-old format, all right? Who here is under 30? Okay, like the JPEG was around, when you guys were born. So, and it's still around right now. Why? Well, it's a format that people love because it was a lossy format. It was the first one that we could actually sort of like populate a page with, and not really have some of that burden of page weight that we're experiencing with something like the PNG or something like the GIF, all right? The most popular format as well, simply because, again, it was lossy. But I'm saying right now, there are formats out there that can replace it, all right? So this is something that you want to keep in mind when you're sort of deploying. K. K is going to stand for kilobytes. Believe it or not, we do have a problem with the size of pages that are coming down the pipe. Man, like, at the 75th percentile, pages are like 4 megabytes. At the 90th percentile, they're almost, they're just a little past 8. All right. We're being liberal with the resources that we're sending down the pipe. So this is kind of a reminder that optimize as much as possible. Don't use resources that you don't need. And ultimately, things like lazy loading come in to play. These are very important. And I get back to the idea that you're going to see more regulations come down around missions. This is like a very early conversation, pardon me, but these are things that are literally happening as we speak. This is a good one right here. L is going to get back to something that I talked about earlier, which is the Core Web Vitals. And if you remember, I talked about LCP, which stands for Largest Contentful Paint. Now, why is this important? Well, A, it's one of the 3 Core Web Vitals, as I just mentioned. B, it's actually a metric that you also see. I'm sure some of you are familiar with Lighthouse. Yeah, no, show of hands, maybe. So, okay, cool. So you may recall seeing largest contentful paint. Well, let me share to you that largest contentful paint is one of the metrics that developers struggle with the most. In fact, if I'm looking at my data right here, boom, only about 55% of pages have good largest contentful paint. What does that mean? Well, that means that it loads in 2.5 seconds or faster. That also means that 45% are doing it in 2.5 seconds or slower. And here's also a little nugget. Largest contentful paint challenges are mostly due to images, all right? So I get back to the idea that you get an image size properly, you're probably going to improve your largest contentful paint. I get back to the idea if you use a more modern format that's going to come in smaller, you're probably also going to improve your largest contentful paint. Now, there are some other factors involved with that, but since it's kind of like a 70-30 split, by having properly sized images, properly compressed images, you're probably going to be able to improve that. And by the way, the other 30%, text. M stands for Metallica, one of my favorite bands, thank you. It also stands for measure. You cannot improve what you do not measure. I didn't mention it, but I'm a runner. Shout outs to the runners who came with me this morning. If you're in the room, big up, thank you. Ran a little 30-minute. It was like, was it 5K? I think we did a 5K. Yeah, it was. I'm trying to improve my 5K, all right? And I can't go in there blindly, you know. No big deal, PB, 19 minutes, thank you. But the fact that I know that's 19 minutes, I'm gonna go in and be like, okay, can I break 19, all right? So you cannot improve what you cannot measure. So you absolutely have to measure performance of the app, because you cannot go in there blindly. I'm going to do an M prime. You also have to monitor, all right? Great companies out there will always monitor their performance. You know, Saturday night, you get that page saying something went wrong. That's monitoring right there. Deploying on a Friday, yo, I'll see you on Monday. Chaos. Saturday morning, if you don't monitor, you're going to find out the bad news on Monday. All right? Monitoring, very important part of the workflow in web performance. Oh, sorry about that. N. This is actually one of my favorites right here. N stands for the Network Information API. Anyone's heard of that API? Super, super cool. So what you could do, you could actually poll the network. All right. Browsers are amazing. It'll let you know whether it's like, it feels like 2G, feels like 3G, maybe it's 4G. And once you have that information, you can start to make decisions on what resources to run to send down the wire. Let me get back to images. Just say, you know, you have, I don't know, a newspaper and a sports page, and you want to talk about, you know, the Dolphins' next draft pick. You got a picture and, you know, high resolution image, whatever. But using this API, you find out you're out in the wild and it's like a 2G connection. Well, you can indicate then, oh, you know what? We're in a bad connection. I'm going to send down this black and white, or I might send out an SVG of the Dolphins logo instead, because it's going to come in smaller And it's going to benefit from broadly compression because SVG is just text math, right? These are things that are available to you so that you can make really good performance decisions. I got 10 minutes. Damn, I'm doing good. Well, at least I think I am. O is going to stand for offline. Kind of a bizarre case, but totally a case that you should keep in mind. A few years ago, I think it was like Jeep. They had this campaign, and it was about like, you know, obviously be out in the wild, whatever. And their page worked offline, you know, because they assumed that you might be out in the woods, and we all know what connectivity is like in the woods. All right. So you can make a case for having offline capabilities, you know, subways, hello. I mean, some subways are getting Wi-Fi now, so whatever. Not in Toronto though, you know. So these are things that I just want everyone to keep in mind because we have the tooling available for us to do so. Now, P, yesterday, I remember, was it Hassan? I think he talked about over at Next to do some prefetching, you know. They might even do some preloading. Now, this is, again, the browser's able to take some direction from you, and you're going to say like, hey, I want this file to load immediately. And it might be an image because you know that's going to be your largest content from Paint. So you're giving the browser the ability to bring in some of the crucial resources very early so you can create that awesome user experience, have a good core web vitals. Now, I've seen, again, because we pop the hood and we look at sites, people get a little liberal. They're like, oh, I'm going to preload everything. Well, the browser knows, and they're going to say something like, hey, do not preload a resource unless you're going to have it used immediately. You'll get the warnings in the console for those of you, for the 3 of you who go in there and look. All right? So just be very judicious. Q, oh, I made a mistake here. Q does not stand for quit. Stands for quick. Essentially, another protocol, been around for a while. I don't want to get into the hairy details, but you know, we're talking about right now 0 RTT, round trip times. Like we're trying to get these assets down the wire as quickly as possible. And these are the technologies that are available to us today. R, here's one of my favorites. R is going to stand for requests. The quickest request is the one never made. Take that in. You mean you're going to have lunch and it's going to hit you like, you know, things are going to look different. So, but to be very honest, you know, again, we pop the hood and we see sites with like 800 requests. Okay? If you don't need it, don't request it. All right? This is going to add to the performance conversation. You know, and I could go through like a bunch of examples. It's kind of crazy. But ultimately, like I said, every piece of request is going to add to more or less your load time. All right. So if you don't necessarily need it, don't load that onto your page. S is going to stand for speed index. Again, if you're familiar with Lighthouse, you pop the hood and you see like you get this score. And speed index is really one of my favorite actually metrics because you're able to really, by looking at this graph, you're like, okay, I know what's going on here. It basically gives you an idea of, how could I put it? sort of like the completeness of the page load. All right. And again, this is something that you'll see when you pop the hood, and you may not have understood it real quickly, that well, pardon me. But at Web Page Test, we actually associate it with a graphic, which I'd love to, again, talk about if you have some time. T is going to stand for time to first byte. All right. It's not an official core vital, though there's been a discussion that it could be, but this is a very important metric as well, because what does it mean? Well, how quick is that first byte coming down the wire? All right. Really quick example that I like to give is, again, because I run, 100-meter runner, you know, they get into the blocks and they work on their start for hours and hours and hours because they realize a late start likely means they are not winning the race. Time to first byte is essentially the same thing. If your time to first byte is coming in late, your load is probably going to be nice late as well, which is not good. And again, ruining the user experience. U stands for User Timing API. I don't know if he's in the room, but who talked about it yesterday? Ken. Is Wheels in here? Okay, so, well, I know Wheels is not here. He's probably at the pool somewhere. Amazing API where, again, he talked about it yesterday. You could actually create marks in your app and measure a particular section that you think might be problematic. All right, so there's a bit of customization there. It's not discussed a lot because people actually don't like messing with it too much because it's not super complicated, but it doesn't really provide the best developer experience, at least the ones that people like. V is going to stand for velocity. I'm sort of taking it back here. Velocity was a conference that used to happen as part of like O'Reilly's set of conferences. It was purely performance related. It was really awesome. A lot of the content is still out there if you want to look at it on YouTube. But it was kind of like the foundation for a lot of people. I used to go to this conference. It's sort of how I got my chops up as well. W, I'm sorry, but W is going to stand for Web Page Test. I'm sorry. No, but it really does. This is an amazing tool. I mean, I'm happy to sort of like give them outside, but this is what a lot of like big engineers use, you know, my DMs. It's like, hey, what's going on here? I'm like, okay, boom, 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 I got you, you know. We provide a lot of metrics, I'll be very honest, but the point is that by understanding what a lot of these metrics are about, things just look different. So, but W also stands for waterfall. Who here likes to look at the waterfall in DevTools or anything? I mean, it's cool because I know a lot of you don't, you know. Waterfalls can be intimidating, but once you understand what a waterfall is providing in terms of info, game changing. The way I describe it, it's kind of like, yeah, I like food. I like eating in restaurants. Then you became a chef. And it's like, oh, I know what's going on here. And understanding a waterfall is basically what happens because so much can be determined just by looking at a waterfall, and especially ours. I'm sorry about that. X, easy peasy, user experience. Everything that we do right now, whether it be performance or anything else, it's all about the user experience, you know. Do you have return users? I talk about, I go to Amazon sometimes because I'm bored, but I also know it loads fast, but I still go back. That's a good user experience. Y is going to stand for Y slow, old school performance tool out there. You know, it's still, you know, in the wild. So this is kind of like a history play. I just wanted to be cute. And Z stands for Zoffly. And again, getting back to some compression. And again, this is not super duper important, but I was like, let's use Zoffly. But to summarize, I really want to say this. This was about performance literacy. Because again, I really believe that if you understand performance, the terminology, the technology that's available to you, things will be different in your development career. And this is a coworker of mine, Scott Gell, big OG, put out a course last year, and we repackaged it and put it out there for free. And if you want the full QR code, it's here, and I'm going to tweet out the link as well. You could polish this off in a weekend, but again, it goes through some of this terminology that I went through, and this is really just for the web. Like, if you go through some of this stuff, your sites will load faster by default because you'll understand what needs to be dealt with when it comes to all the resources that are coming down the wire. And that being said, merci, gracias, and thank you.
Hello. Like many of you, I am sure that you work remotely, as I do. You know, it's one of the great things about working in tech, right? We get to work from anywhere. And about a month after I started with my current company, I got the chance to actually meet with my colleagues for a conference because, of course. And during that time, we, got to know each other better personally, professionally. And we also talked quite a bit about some topics that are of interest to us. And one of my colleagues talked about micro frontends pretty briefly. And I remember thinking, was I supposed to know what that is? I'm a front-end developer, but I've not heard of that. And so what I did was, I went to Google, like most people do, looked it up. And as I started to read about it and learn more, well, I had a lot of questions. Like, for example, how is it spelled? We've got this hyphen in between, without the hyphen, one word. We really just need to come to an agreement. I really hope that happens soon. But, in addition to that question, there were so many more. And so, however, I think what's really important is that for any team, before they decide to use a micro frontend, is to really just think about some questions. And that's what I'm going to talk about a little bit here today. And so hopefully after this, you and your team will be able to decide whether to micro frontend or not to micro frontend. But first, just a little bit about me. My name is Danielle Maxwell, and I'm a Gene Distributed Systems Engineer at Rotational Labs. And so I work with React on the front end,
I work with Go on the back end. So I guess that makes me a full stack developer. And then just a fun fact about me, I am a really big fan of the team called Liverpool FC. If any soccer, football fans here, you may know, yes, great. However, we don't talk about this season. No, we do not need to talk about this season ever again. Okay, and so those are just a few facts about me. And because I know she's probably watching, I just want to say, hey, Mom. All right, so micro front ends. So what is a micro front end? It's an architecture style. And what you do is that you will break front end code up into smaller parts. So instead of it being in a mono repo, you will have multiple repositories for your apps. Each front end is then integrated in the browser to provide a uniform user experience. So when the user goes onto your website, they don't have a clue that they're actually looking at apps that are all created separately by separate teams. And a couple of examples of companies that use micro front ends are Capital One and IKEA, or I read that IKEA does. However, I couldn't find anything more updated than like maybe a couple of years ago, 3 years ago. So hopefully IKEA actually still uses this. And a thing I want to note is that like this approach kind of came out of the microservices architecture. Many people thought, well, have the services that are broken up. Why aren't we doing the same thing for the front end? And as you can see here, just like a visual example, with the monolith, kind of start from the bottom up. At Rotational Labs, we use Go for our backend. So, that's our service layer. Then in the middle, we have a REST API. And then we have our React app, for example. We even have for like one of our clients, we have 3 separate React apps inside of one repository. However, as you can see with the micro front end, something that you can do is actually break this up into multiple parts. So for example, I decided to say, hey, let's like kind of break this up by feature. So I forgot to update billing at the bottom. But if you see payments, it means billing payments. It's the same. But so we have a Teams feature, for example, and it would be, have a Teams microservice for example, have billing, payments, and then we could also have like a projects feature. And again, they each have kind of like a separate microservice that works for them. And so now let's talk a little bit about the pros and the cons of a micro front end. So incremental updates, because if you have a smaller app, it's going to be much easier for your team to be able to make updates. If you discover that your users prefer something more, even if it's an internal tool, because I remember that Capital One kind of has like a lot of internal tools for their micro front ends. And they mentioned that, a lot of their employees said, hey, can you do this? Can you do that? So whether it's internal or external customers, when you use this, it's much easier to be able to make updates that will make your users much, much happier. Also can reduce deployment bottlenecks, because again, if you have smaller apps, it's going to be much easier for you to deploy. You don't have to really wait on other teams in order to be able to make your updates and ship them. And then you're going to have a much smaller code base. Now, it's kind of hard for me to really say, like, how many lines of code are really too many lines of code. Only you and your team can really decide that. However, I'm sure we all have seen an app that, as it continues to grow, as your team grows, it just gets bigger and bigger. You have more components, you start to see more lines of code, start to see more files. And sometimes it just becomes really difficult to find sometimes even the simplest things within the repository. Now a con as well is complex. And as I talk a little bit more, you'll kind of get an idea of what I mean by it's complex. But the traditional way, most of us, we just kind of go, we use Vite or Next.js, and we start up our React app. We start, putting our components together, and then we ship. It's good to go. However, with the micro front-end approach, you have to kind of think about a little bit more. Also, you can have like duplicated code and dependencies. You know, if you have, like in my example, there were three apps. And so there's a great chance that those three apps are going to use very similar dependencies. And then a large build size, because if you have 3 apps, 4 apps, 5, and they all have their own dependencies, then they're all going to have their own individual build size. And that's just going to continue to increase exponentially. Again, it's kind of hard to say like, well, you want to keep your build size under this amount. But one thing we want to do is always think about our users. And of course, the larger the build size, then the slower the performance. And that's something we definitely don't want. Okay, so I'm going to talk about integrating your apps. But before I get to that, let's just assume that your team has decided, yes, we want to go with the micro front-end approach. You've decided that you know exactly how you want to divide up your code. You know, for example, like the features that I showed, or, you know, if you have additional features that you want to divide them up into. So you said you had your meetings, and you said, okay, this is how we're going to have everything divided up going forward. But now, how do you integrate them? So question number 1 is, which integration method will you use? We have build time integration, runtime integration. And with runtime integration, you can have like the server side. And so that, if you choose this option, then the backend would determine exactly which micro front end would be loaded. You can also use edge side. And with this here, you actually have a CDN that makes this decision. And then you have client side. And with the client side, you're likely going to have like a container or a host app that is also deployed separately. I'm going to focus more on the client side because, well, we're at a React conference. So here, you know, teams, payments, projects, we have our 3 separate apps, have their 3 separate repositories. And so just on top of this now, connect these 3 will be a container app. And what that does is it will communicate with each app, determines when exactly to show them based on, of course, when the user is actually on your website and is navigating your site. And then you can also actually use it to display like shared UI elements so that you don't have to have a header in each app, for example, or a footer in each app. And so with build time integration, our team will create a micro front-end app, but then they will publish it like a package, publish it as a package. And so with the container app, it will then be installed as a dependency. We all have done this several times, you know, our npm or npm install, yarn add, we're all quite used to this. The container will have to be deployed, however, anytime there is a change to one of the apps that has been installed. And in a way that kind of defeats the purpose of having a micro front end, right? Because the great thing about this approach is that each team is working separately and they don't have to depend on each other in order to deploy their changes and to make updates. However, this is really easy to set up. And so although it's not quite ideal, if you're experimenting, if your team is experimenting, really trying to decide if this is what they want to do, or if your team is, you know, trying to get something together pretty quickly, then taking this build time approach might be the best way to go. And then going forward, you can kind of like, you know, get together again, revisit it and decide, hey, do we want to keep continue to work with the micro front-end approach, and then decide if you want to move to another integration option. With runtime integration, each app is deployed separately, has its own URL, and then the container app will then fetch each app once it is loaded to the browser. However, with this approach, it is much more difficult to set up in comparison to build time. Because with build time, you're just installing a package, deploying, and then you're good to go. With runtime, you have to actually, you know, configure the apps in a way so that the container is actually able to pull in the separate apps, the separate micro front-end apps. In addition, we have some options for like this client-side runtime integration approach. One is module federation, which I'll talk a little bit more about. You also have the option to use import map. You can also use iframes. I know that this is kind of one of those things where you hear iframes and you're like, really? Like, you really want to use an iframe for this? However, this has actually been an approach that several companies have used over time. And so I think one thing that makes it kind of beneficial is the fact that a lot of other devs have experience with using iframes. And it might be much easier for you to actually find more information of how to actually integrate with this way, with this approach. And then also you could use web components. Haven't read as much about teams using web components, but this also is an option that you could use with React in order to integrate your apps. Okay, so now, module federation. Has anyone here heard of module federation or used it? Okay, cool. Okay, so next question is, should you use module federation? Module Federation is a plugin that was included in Webpack 5 and released in 2020. With this plugin, it essentially can load external modules and libraries, and it can also import and export micro front-end apps. That actually makes sharing dependencies much easier, and it makes sharing the apps, like the container fetching the apps, significantly easier. Another great thing about module federation is that, because one of the downsides I mentioned was the fact that you can have duplicate dependencies. So one thing that module federation can do is that it can look at the versions of the dependencies that are installed in each app, and it can determine if they are compatible, and it will use the highest version available if they are compatible. However, if the dependencies are not compatible, then each one will load. So then here's just an example of using module federation. Have a Webpack config file. You would declare just the module federation plugin, have this module exports. Here I have development, but of course you can have production as your mode. You set a port for it. And then here I'm using, I'm naming one of the micro front-end apps payments. And then you can see here with shared, I'm just making a note of some shared dependencies, for example. And then within the container app, again, here we have development, we have the port that is declared. And then we also say this is the container. And you can see the container is pulling in the individual apps like teams, payments, projects, and the specific file for each one. However, there's a great chance you may not want to use Webpack, depending on your experience with it, or just the fact that you just don't want to have this module federation option. Maybe you want to use something that's a bit more native. And if that is the case, then you can use import map. And as you can see here, we just declare a script, make the type import map. And then with the imports here, you would again just kind of declare the name, have the link to the particular apps here, their URL. And then you could pull in the dependencies, like in this case, we're here with React, and then you just close your script. Oh, sorry, go back. Well, before I get to that next part. And so when you have the module federation, like I said, you have to use Webpack. But with import map, you don't have to use Webpack. However, one of the things about import maps is that they, I believe, was late last year, or maybe earlier this year, it finally kind of became majorly supported in all of the major browsers. And so with older browsers, you would have to use a polyfill. So that's just something to keep in mind. Although both options are still quite relatively new, so who knows? Someone else may come up with something that's better than import map and module federation. Okay, so next, how will your apps communicate with each other? Now, if you go online and if you ask, people are going to say, don't share state between your micro front ends. And that makes sense. You know, you have divided up your apps so that you have different features, different services. And so they really shouldn't need to communicate, right? But I mean, come on, let's be real. There's probably a good chance you might have to have some communication between your apps, right? And one idea that comes to mind immediately is authentication. If a user goes into your website that is using a micro front end, if they authenticate in one place, you do not want them to have to authenticate every time they navigate to a separate app. Because again, they don't know that it's a separate app, and we don't want them to know that these are separate apps. So there are many ways in which you can, have your apps communicate. Events is definitely a great way. You can use custom event in the browser. However, I think it would be really great to have your own custom event bus. The thing that makes this really great is that your apps don't need to know exactly where the event message is coming from. As you can see here, we have one app that is a publisher. And when you can create a topic. Maybe the topic is, we'll say payments, payment received. Every time a payment is received, that micro app could then send a message to the other apps to let them know, hey, payment is received. And it would be the same approach with authentication. Once someone is authenticated, it could send that message saying, hey, this has been done, and then the other apps would know. But it wouldn't need to know that it came from the container app or the payments app or the Teams one. And so I think this is something that's really great and can make communicating with your micro front ends much, much simpler. And there's a chance that you're probably thinking events, on the front end, you really want me to use pub sub? But hey, I think it will become much, much easier to actually work with that. Okay, now we have to think about consistency. You have multiple apps, different teams. And one of the great things about having different teams is that they can choose their own stack. I've been talking about having different React apps, and that's great. That's what we want, honestly. But it is possible that someone could say, hey, we want to use Angular. We want to use Angular with React. And it's okay, is it possible? Yes. Should you do it? I don't know. But with the micro front end approach, that could be possible. But you have to think about the consistency of your apps because user experience is what we really care the most about. And so, how will you make sure that your apps look consistent? First of all, we have to think about what can cause consistency issues. No single design system. So if you have multiple teams and each team has its own design team and then they have their own design system, then there are going to be clashes because there's no consistency there. And so when team 1 deploys their changes and team 2 deploys their changes, when you go look at the actual site altogether, there's a chance that the coloring is going to be different, the buttons might look a little different, the components could look a little different, and it's just not something that you want to see. And so you have to really think about should you have one team that does the design system? And if so, then that's probably a bit of a trade-off, right? Because here at this point, you're sharing one single design system across multiple teams, potentially. So it said no single design system, different component libraries. One team is using Material UI, another team is using Chakra. It could be, again, a bit of an issue. And so you have to, again, decide here, Are you going to use the same component library? Are you going to create your own component library if you haven't done that already? Exactly what will you do to ensure that the components are looking consistent across each app and for each team? And then CSS conflicts, because of course that will definitely happen. And there are different reasons why CSS conflicts could happen. You know, teams could use different CSS libraries. Maybe one team uses like a CSS and JS option. Another team uses handwritten CSS, although I don't think that really happens much anymore, right? But hey, it could happen. And so when the sites are deployed, if your teams aren't actually like, you know, doing a really great job of like, you know, scoping out the class names for each app, if they're not, you know, really thinking about like what can happen once it's deployed and all of these apps are together and how they can cause issues, then, you know, a user can go into your site, go to register, for example, click the registration button, and then the top of the page could have, I don't know, like a header with maybe like a blue background. Then once they complete the registration, they get redirected back to kind of like a home page. If that registration page maybe had like a different background that was like a light green, when they go back to the home page, then they're going to see this light green color, and it's like, wait, what just happened? And although that's just a very minor example, that is something that could still just make a user go, wait, am I still on the same site? Like, what just happened? So you really have to think about like exactly how much should you share in this case in terms of like ensuring that your apps look consistent. Okay, just to recap. Question number 1, which integration method will you use? Will it be build time or runtime? Number 2, should you use module federation? You know, as I mentioned, import map is another option. You can use iframes, or you can even use web components. How will your apps communicate with each other? Because it's going to have to happen. You know, we want to keep that to a minimum, but they will need to talk to each other maybe every now and then. And number 4, how will you make sure that your apps look consistent? Now, that's only 4 questions. And the last one, will a micro front end solve your team's problem? Because I think it's really easy to say, hey, you know, our code base is getting huge. We have multiple apps in one repository. We have multiple teams that are working on multiple apps within one repository. But is that really going to solve your problem? You really have to think about exactly what are you trying to resolve? And then from that going forward, you can then determine if the micro front end is really the best solution for you. Okay, thank you all so much for listening to my talk. And I also just want to say thank you to the organizers over at Miami for giving me a chance to speak at my very first conference. So thank you very much. And if you want to follow me, I don't tweet a lot, but I should definitely do a much better job. Oh, sorry, touched the mic. But you can follow me at the Danny Maxwell and at rotational.io. We actually do kind of blog at our website at Rotational Labs. And I actually am planning on posting some blog posts about micro frontends going forward. So again, thank you very much and enjoy the rest of your time here in Miami. Bye.
That was amazing. Wow. 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 So everybody's scrolling on their phones all the time. We're building all these amazing experiences. But how do you actually get new inspiration for UI patterns? I have to say this next speaker, head of development at Basement Studio. basement studio, is going to enlighten you with more inspiration, with some examples and code snippets. I cannot give it up for this new term, Scrollytelling. So please give it up to Julian.
Some arrangement going on here. 1 second. Okay, I think we should be good. Hi all, I'm Julian Venegas, or JB, and I'm the head of development at Basement Studio, a boutique digital studio with work done for top tech companies such as Vercel, Linear, Solana, and iconic entertainment people such as Mr. Beast, Carl Jacobs, Patrick Mahomes, and more. By the way, we also designed the cool shirts for this amazing conference. Did you like them? Awesome. So my talk is about Scrollytelling. Scrollytelling is a storytelling technique where the narrative is conveyed through a combination of text, images, graphics, and animations, all of which are revealed or triggered as the user scrolls down the page. It is a highly interactive and immersive way of presenting content, as it encourages the user to actively engage with the story and explore it at their own pace. The purpose of this talk is to show you why this technique is so amazing, why we should be building more of these, but better, as well as help you get started in your journey to building more of this. So I wanted to open up with a small disclaimer. Remember that website that when you started scrolling, it just blew you away? It ran animation after animation. Everything's scaled up, down, stuff faded in and out. You entered the portals and switched themes. It was so cool, except you probably don't remember anything else about that website. You don't even read the copy or paid attention to what they were trying to sell you. So my disclaimer is don't overdo it. When you know how to build these kinds of websites, it's easy to get caught up in thinking more equals better, but that's just not the case. You need to think about the reaction you're generating to your visitors as they scroll down the page with all those animations. If you go too ambitious or too sloppy, you might get performance issues, accessibility issues, user fatigue, and all kinds of bad stuff that we don't want on our websites. As always, everything we develop should be aligned with the company-wide objectives or personal objectives And as long as we keep it that way, it will be fine. And so with that out of the way, let's get to the fun stuff. Why Scrollytelling? Besides making your site look really good and increasing the chances of it going viral on Twitter, Scrollytelling is actually a great way to explain complex flows, present data visualizations, or just tell a story with a strong visual component. It's a really special technique that we love at Basement because think about it. The scroll is like a user-controlled timeline. Scroll animations give the user more control. By scrolling faster, they can speed the animations up. By scrolling slower, they can slow them down. They can even pause them or play them again if they want to see it, to understand it better. So for a user, it can feel as if they are part of a journey, which will make your website feel more alive to them. The most well-known company using this technique is probably Apple. We all know them. Every new product they launch comes with an amazing website that presents all of its features in an engaging way. Their features are oftentimes not easy to explain, so they use scroll animations to do so. We all talk about their new websites because they are interesting. When you enter a brand new Apple website, you are entering a story of the new product they're launching, its new features, and now suddenly you've unlocked a new need. Of course, this is not only achieved by doing scroll-based animations. This is just a small part, but it's a small part that they get right. Another example is a project from the Basement. Boost sells immunity gummy vitamins, and they wanted to tell exactly why their product was so great. The website we developed for them showed the real package as a sequence of PNG images rotating in the middle as the user scrolled. Further down the website, we show all of the ingredients the gummy package came with, while animating some assets and changing the background. This launch was a long time ago already, but I do remember there was a lot of hype behind this. Overall, the website served as a great opportunity to show what made Boost different, while expressing fun and keeping it lighthearted. My final example was also made at the Basement, the amazing Replay.io site. Replay is building a new way to debug. It's an incredibly powerful product, and we wanted to show how it worked in an easy-to-understand way. We built a Scrollytelling part on the hero of the website that showed their main features as you scrolled. And the result was more developers understanding their product and more signups. That Scrollytelling looks really good. You should check it out. The Replay team actually saw a 24% increase in user interaction and key features 3 months after launching the website. Thank you, Jason and Jared from the Replay team, for providing us with this valuable data. But let's not fool ourselves. Developing these types of experiences is still way too hard. It still takes a very experienced team and sometimes months of development to build a polished experience like the ones I mentioned. I'm sorry to say, I'm not gonna make it magically easy, but if you leave this talk with just a bit more confidence in building this, then I'm happy. I remember Una's talk, which showcased some of the new CSS features regarding scroll-based animations, and they are amazing. I would love for them to be stable sometime in the future. But for now, we do have JS. And one of the most important tools that will help us build this is GSAP. GSAP is a very powerful animation engine. Besides its non-negligible weight of 26 kilobytes, we often choose it because we know it can scale up to any use case we can imagine. It's one of the most battle-tested libraries out there. It has a very active community, and it's super performant. Creating a timeline with GSAP looks something like this. I'm not gonna get into details about how exactly all this works, but what we need to understand is that we're basically creating a timeline and then concatenating twins or animations into it. Now, by default, this animation will play when this code executes, but we don't want that. What we want is for the user's scroll to control the progress of this timeline. That's why we reach for GSAP Scroll Trigger, one of their plugins. Scroll Trigger, as its name implies, syncs the timeline with the scroll position. We import it, register it, tweak some variables, and then we're good to go. Except to control the start and end of these animations, the twins accept a duration parameter. The thing is, this parameter is not based on time anymore. As remember, now the progress is controlled by the user's scroll. The duration in scroll trigger actually represents how long the animation will run relative to the other animations, as the whole timeline's length is fixed to the scrollable container. We need to be really careful when dealing with this mental model, because altering one duration can impact the other ones, as it's all proportional. So as you can see, I can alter one, but the proportions will switch. Notice how this all code is looking a bit more complex. And this is the moment we add React into the mix. We use effect and do all our timeline stuff in there. And on the effect cleanup, we just revert this timeline as GSAP recommends. But this is a bunch of code already. At this point, we have a powerful way to build UI and animations with GSAP and React. But we've identified a couple of problems. Firstly, we need to have a deep understanding of how GSAP works in relation to scroll trigger. Secondly, we need to be careful about running our animations in a use effect and then cleaning them up. Thirdly, we can't think about scroll animations in terms of a start and an end. We are still stuck in the paradigm of a time-based duration parameter, even though the actual duration will be controlled by the user's scroll. So to help alleviate these problems, me and the Basement team built something. While preparing this talk, I was really hyped just to show a cool demo for you all. But I also thought it was nice just to give something back. So I'm happy to introduce now Basement Scrollytelling. Basement Scrollytelling is a thin abstraction around GSAP scroll trigger designed to help you build these kinds of animation faster. Let's see how this works in a side-by-side comparison. In Basement Scrollytelling, you won't need to use effect to create or clean up the timeline and scroll trigger. This is managed to you by the root component. You won't need to work with durations. Instead, you'll work with a start and an end. Additionally, its component-based approach feels more aligned with React's declarative approach and pairs well with React server components, as we'll see later on. As a summary, this library will abstract some of the parts from GSAP, especially around integrating GSAP with scroll trigger. It will manage timeline creation for you and also cleanup. It will allow us to use a start and an end instead of a duration, using absolute positioning for our animations. And it will let us keep most of our code as server components, as the components we provide do use client, but you won't have to pass all your app or pages that wrap it to client components. So I think the most important difference, put visually, is about these absolutely positioned timelines. They won't depend on the durations of the other animations. You just define a start and an end for each. And this is especially nice when tweaking all those animations with this kind of stuff. You really need to tweak it for a long time to nail the timings exactly right. And so you don't want to worry about what is going to happen to the other animations once you tweak this animation and get the timing exactly right. Okay, how are we doing so far? All good? Awesome. Are you all ready for a demo? Yeah. Nice, nice. So we prepared a demo. Let's see if I can bring it up. Yes, this one. Okay. So this demo was made exclusively for the React Miami conference, in which we'll just showcase some couple of animations that are using our new library. Now, remember I said don't overdo it. So in this website, we are actually really overdoing it. But it's all because we want to showcase this kind of animations in the first place. So my point still stands, sorry. So the first thing we'll see, okay, a couple of things are happening in this hero. So we first have like some text scaling in the x-axis. Some of the text are actually SVGs, so we can just alter the widths and do nicer stuff. We also have a 3D rendered model down here, and this thing rotating in here. This section also pins for a bit, so that means it has position sticky, and it will wait for all of the animations in it just to keep, it will fix it, and then once the animations are done, you can still scroll. So after this one, we have this text animation that starts with highlighting this text. This feels very Apple-y. It's nice. And also some 3D rendered caps that rotate while they enter. Now here, we have like a marquee kind of thing. This is not that readable. I don't recommend it, but I thought it was cool, so I just left it. It says from the laboratory. And after this one, we have like this word scaling in here. We have like some text in relation to our lab here at Basement. Our lab is just a place where we explore some new stuff or old stuff, even whatever we want. So we have some small parallax and some more marquees down here. And now this incredible animation that is like a cylinder kind of thing, which just showcases a couple of our experiments that we made at the lab. Shout out to the amazing Matti from our team, which nailed this animation. And basically, that's all for the demo, okay? Hope you like it. So besides the demo, I wanted to jump in quickly to VS Code. Hopefully not that long, because I will get into rabbit holes. But just to show some of these sections, how they work with the new library. I think we are good here. So this is a Next.js application. These are all server components. And if we enter the hero, well, this is not actually a server component because it's using like media query. But if you go to the hero, we'll see we have the root component here. This, as I mentioned, is the one that takes care of creating the timeline and reverting it back on every re-render, and just providing the context, the React context that will be used by the nested animations. We have a small helper here, which is called a pin. This is a super thin abstraction over position sticky and a wrapper inside it that lets it scroll freely. Here we have our first animation, and this is the best component we have. This animation component receives a children, which will be the target of it, and receives a tween prop, which has a start and an end. These two values are percentage-based, and they represent basically 0% of the start of the scroll trigger and 100% of the end. This to parameter here can be a to, a from, or a from to. These are typical operations that we see on almost any animation library. And down here is what we'll do. We'll basically get this, and from 0 to 100, we'll just rotate this 360 degrees. Down here, we have the Canvas Mac model. This uses React 3 Fiber to basically load the model and show it on the screen. Here, we do a different method. We use Scrollytelling. This is the context I mentioned. We get the timeline, and on every frame, we basically update the rotation in relation to the scroll trigger progress. So simple stuff so far. Now, we have a couple more animations. 0 to 100, same thing, from to. And let's move on to another section, because that should be it for the first one. I wanted to highlight this lab intro section. This features a parallax component. This is like a helper. You can build parallaxes with the animation primitive, but this is just a simple helper. So from 0 to 100, we'll give a movement in the y-axis of -20 pixels. That should be it for creating a simple parallax. That's cool. We have some more parallaxes, and down here, another animation component, which receives an array of twins. So not a single twin, an array of them. We can basically place a lot of animations, and they all have different starts and ends, so they won't conflict with each other. Again, this is great for refactoring. And let's see, I think we have a bunch of animations, of components here. But as I said, I don't want to get into rabbit holes. All of this code will be open source. Let's go back to my slides. And that should be, oh, I think I nailed it. I went really fast, and that's good. So thank you for listening. First of all, I hope this was a fun and informative talk. You can choose your path on which QR code you want to scan. We have the code for this new library as well as the website. I think the website is really a great way to start just because it's pretty new and the documentation is not so extensive. We have Basement's Twitter and my Twitter. And one more thing is that we have some swag. Anyone want some swag here? Okay, we need to make more noise. So anyone wants some swag? Okay, cool. That's amazing. I have some T-shirts here. I think. Okay. Okay. Let's put it down here so we reach. Okay. We have 2 more to go. So who else wants some swag? Okay. Down here. I'm there. Okay. Okay, that was all for me. Thank you again for listening. Thank you, React Miami, Michelle, the whole Basement team, which supported me all throughout this journey. Yeah, that's it.
There we go. All right, so everybody knows the deal. Lunch is the next hour. Please get your lunch ticket. We have that on deck. And enjoy your lunch. And we'll be back in this room the next hour. Thank you for your time.
Not yet. Oh, there we go. Okay. Just wanted to come up and let you guys know we're going to give it 5 more minutes. People are still peeling in from lunch. So I can sit here and like chit chat and bore you to death for the next 5 minutes, or you guys can continue conversations with each other. I prefer the latter. So I'll come back and introduce our next speaker in about 5 minutes. Thank you for your patience. Yes.
That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom 2-factor authenticator for added security and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Ouch. Dang. Thumbs.
You know, there's an easier way to get thumbnails. Quickly grab a still from anywhere in your video with the Mux API. All it takes is some query params. Thumbnail.
What about GIFs?
What?
Not you, Jeff. GIFs.
I thought it was GIFs.
GIFs, GIFs, all the same to Mux with a simple GET request. Because video is fun with Mux.
Rabi Abdul-Wahab, Managing Director of Engineering at CityTech. Anytime you join our company right now, or in the next 10 to 15 years or 20, you can actually create your own career path. There is a lot of growth and a lot of...
Perfect. Hi, welcome back. I hope everybody enjoyed their lunch and you got to spend some time networking and getting to know each other. We're going to go ahead and get started with our next talk. If we can give her a warm round of applause. She's a little nervous back there. I know she's going to kill it, but just give her some excitement and encouragement. That would be greatly appreciated. Let's get ready to welcome on stage Stephanie Medica. She currently is a staff design engineer in data experiences at Visa and is going to be talking about visualizing the blockchain. Let's welcome Stephanie.
when it pops up and it says new keyboard, hit continue. That's great.
Hold on, let's see. Oh, wait. All right, cool. All right, can you hear me? All right, cool. So hi, I'm Stephanie. I'm a staff design engineer on the data experience team at Visa. And today I'm super excited to share with you all a project we're creating for Visa's innovation centers around the world, visualizing the Ethereum blockchain. So for the next 25-ish minutes, we're going to talk about a few things, right? So first, what is data experience? It's a term we use to describe the combination or intersection of a few related disciplines. Then we'll dive into the project itself, the Ethereum visualizer, from concept to design to a short clip of it playing in our San Francisco Innovation Center. And finally, we'll close with some code snippets to hopefully get you all up and running, creating 3D data experiences using React. So just a show of hands, how many of you have used Three.js before? Okay, cool. What about React 3 Fiber? Okay. How about for data visualization and sonification? Anyone? Oh, okay. Cool. So hopefully there's going to be a little bit of something for everyone in this talk today, whether you're just starting out or you've used these libraries before. So what is data experience? Data visualization, right? So it all starts with the visual representation of data, whether through standard chart forms like bar charts, line charts, and scatter plots, to more complex representations like Sankey's, network diagrams, or even generative art. However, increasingly, data is becoming the product itself, and we're finding ourselves engaging with our work and our tasks in a much more holistic approach, right? Starting with user research, designing and prototyping in Figma, to developing entire applications that often extend beyond the traditional dashboard interface. So I like to define data experience as the combination of data visualization, product design, and user experience. So here we have three individuals that are really expanding the bounds of data experience today from a creative standpoint, and were hugely influential on the project itself. So on the left, we have Rafiq Anadol. Rafiq is a media artist. He is pioneering the visual aesthetics of machine learning. And this is his machine hallucinations Coral Dreams, which was actually here on Miami Beach a few years ago. I was able to see this, and when I did, I became untethered to the idea that data visualization, data experience had to be actionable, right? Instead, it could be contemplative. It could bring a technical topic like machine learning to the general public, right? Into the general discourse. Today we hear machine learning, AI, ChatGPT, Copilot, right? But a few years ago, this certainly wasn't the case. Maybe in our smaller tech circles, but definitely not in the general public. And then in the middle, we have Matt Delorier. Matt is a generative artist. This is from his Meridian collection. He also has a great JavaScript library, Canvas Sketch. And he does a lot of educational content online. And it was through these videos that I began experimenting in the overlapping space between generative art and data visualization. And then finally, we have Carney on the right, Carney Klers. Carney is a data visualization designer and musician. This is one of his explorations into data sonification, so turning data into sound. And while this is, sound makes everything better, right? So this is a really big topic in our space, but it's also something we're exploring for accessibility, right? Trying to expand how many people can experience the data in the ways we want them to.
So this brings us to the project itself. The crypto team said, we want our clients and colleagues to feel the pulse of the Ethereum blockchain. We have all these great charts, but we want something physically in our offices to communicate how much activity is happening on-chain in real time. So we knew we'd be able to get creative with this, right? First, feel the pulse. Also, the space itself is very open to experimentation. But this is also a challenge, right? This is a pretty wide-ranging audience from clients and colleagues, right? People in the space, people not in the space, people in tech, people not in tech. So finding a way to really speak to everyone that would view these installations. And it became really clear to us in the beginning when we were doing some research, talking to people that are not in tech. They had this very literal image in their mind's eye, you know, when asking about what is blockchain technology, right? Of physical blocks somewhere chained together. And so I saw this great quote, you can only understand something new relative to something you already understand. And I thought this was really great because, you know, we wanted to lean into this image that they had in their mind's eye and meet them where they were in their understanding and take them along with us. So we had to create a visual language to communicate. So on the left, we have transaction streets, Ethereum transaction visualizer. You can see these are South Park character heads. Those are transactions. And they're kind of hurrying into the buses. Those are the blocks. And they're stacked in a way that you can discern, okay, that's a blockchain, right? Then extending this. So first we have, right, circles, transactions, cubes, blocks, okay, some movement aspect and arranged in a way that people can understand. So then to build on this, right, what if we give them the ability to peer into the buses, right, peer into the blocks? And so we have this 3JS example of points oscillating inside of the outline of a cube. It's a little hard to see. So really giving people, okay, now you can see into the blocks themselves. And then finally on the right, I have some work I did based on Matt's Canvas sketch library, right? So each one of these squares is a block and everything inside of them are transactions. And I'm adding 2 additional encodings here. One is color for the type of transaction, right? So for Visa, it was important to highlight USDC, NFTs, and then everything else. So 3 distinct colors. And then also size, so the amount of the transaction. So now that we have our visual language, we want to turn it into a sensory experience. So some sight, some sound, and some touch. So on the left, I have Kelly Milligan's great tutorial article, Creating the Effect of Transparent Glass. So we're going to use this to peer into our blocks, right? We're going to use this for our cubes so that we could see into the transactions. And it's pretty realistic looking, right? Then in the middle, we have another 3JS example for audio. So these are ping pong balls, and as they hit the table or the plane, right, they release a sound. And so we're gonna harken back to Carney's example, where he uses, as you scroll down the screen, you could hear the data as well as see it. So what we're gonna try and do is as the transactions fill the block, we're gonna be releasing sound. So you could hear the density of those transactions. And finally, I have Bruno Simon, a snippet of his site. How many people know Bruno Simon's work? Yeah, okay. So he's got a really great course on 3JS and React 3 Fiber that I highly recommend. But I included him here because I think his website's a really great example of being able to zoom in, zoom out, mouse around, you know, pan around, really interact in a 3D tactile way, right? So this was the physical space we were given for like our proof of concept version 1 in San Francisco. This is a picture of the digital currency landscape in the San Francisco Innovation Center. It's a 7-panel array of screens and then a big touchpad in the middle. And we were given this pink part, which is the 3 in the middle and half of the 2 on the sides. And this is a little wobbly. But this is a picture of it running live in our San Francisco Innovation Center. You can see how some of the things are kind of coming through, right? This glass cube, the transactions floating into it. When the transactions are in there and the block is validated, it then gets set down on the blockchain. And so as new blocks come in, this kind of pulses, right? And then once you get a sense for, okay, I understand what's going on, right? This is a blockchain. You could then branch out to some of the secondary charts around the centerpiece. It's hard to see, but there's like this blue dot on every chart. So it always gives you that point of reference. So bringing the project to life using Pomandre's suite of React libraries, hopefully I'm saying these words right. They're a developer collective building creative tools, or tools for the creative space. Members include Paul Henschel, who is the creator of the libraries we're going to talk about today. They have a bunch of great libraries. These are just the ones they have extensive documentation for. We're going to look at the top row here: React 3 Fiber, React Spring, and Dre. So React 3 Fiber is what we're going to use to create and manipulate 3D objects in our application. It is the React renderer for 3JS, so anything you can do with 3JS, you can do with React 3 Fiber. Then we're going to look at React Spring. So this will be our animation library, right? Tweening objects from one state to another, from small to big, from this position to that position. And finally, Dre is a compilation of components that are abstractions upon abstractions to make it super easy for us to get up and running. Okay, so let's get started. This is just 20-something lines of code in your app.jsx file, and you're up and running with a cube floating, spinning through space. So let's break this down a bit. So first thing we need is a canvas from React 3 Fiber. This you can think of like a stage, right? And one thing you do is you could set a camera, right? So where you're viewing the stage from. And this is everything we're going to be doing is in a 3D space. So everything is relative to the 0, 0, 0 center point. So everything's going to go inside of our canvas now that we want in this environment. So one of the things you could do, right? So it defaults the background to transparent. So whatever the background color of your application is, this will be as well, unless you set it like using a color, right, like this. So we could set it and change it to a nice dark blue. Adding lights to the scene, right, just like it says, right, adding lights to light up what's on your stage, give it that contrast and dimension and shadows. There's a bunch of great ones. Like if you want an outdoor scene, you can use like a horizon light, right? So play around with those. And then here I've imported orbit controls and stats from the Dre package. So orbit controls is really great for both when you're developing, but also for the experience itself, right? It allows you to move that camera position around in a 360-degree. So you can see your entire scene from every angle. You can zoom in, you can zoom out, all that cool stuff. And then stats. So when we went from developing on our laptops to putting it on those big screens, it cut the frame rate right in half because it was only 30 frames per second hardware. And so for us, it was really important to keep in mind performance as we were developing to make sure we could optimize the experience. There's also a great, if you're into that, you can look into React 3 Fiber Perf library, which is also great. It gives you some more bells and whistles. So then adding the box component itself, right? So this is a 3D mesh, and the mesh takes two things, right? A geometry and a material. So you can think of the geometry as the bones, and the material as like the wrapping paper or the skin. So here we just have a box. This could be anything. It could be a sphere, it could be a car, it could be a bunny rabbit, right? And the material we just have as a standard material with a green color. And then now just to introduce this use frame, right, from React 3 Fiber. So you can use ref, attach it to the mesh, and then access your 3D objects in every frame. So this is how you would go and just rotate the cube every frame. More on that in a bit. So here we're going to start building our blockchain, right? So we need to start by the block component. We're going to just change our box to a block, and we're going to change it just a little bit. So the first thing is swapping out the geometry for a rounded box, right? Giving it a nice curve. Next, we're going to use a physical material with a transmission set equal to 1 and then having that environment component from Dre to really simplify the whole thing, right? I think in our actual project, I use the env property on the material, but this is a really great example of Dre, you can just plug those in and get going. So this gives it a really nice, like reflective, realistic look. And then here's just another material that I wanted to highlight just because I thought it was really cool and I want to try it. So mesh transmission material. So this is built on top of the physical material, but it gives it even more aberration inside of it. So it looks like there's something in there as opposed to the physical material, which is empty. Okay, so here's where it starts to get interesting and also complicated, so bear with me here. So now that we have our block, we got to create our blockchain, right? So the first thing we're going to do, hopefully this runs. It's not going to run. Okay. Okay, so this should be transitioning. My video is not working. That's cool. But so anyway, so we have this big data set, right? And it's an array of blocks. And as a new block comes in, it just gets added to this giant array, right, for simplicity. So, but we can see here we only have 3 blocks on the screen. So we need to go from this giant, array to this smaller one. So as a block comes in, we're resetting the position, the X, Y, and scale for each of these blocks. So as one comes in, one goes out, and we then put that array into a use transition from React Spring 3. And it animates it for us. And yeah, it's really cool. Okay, so here we have transactions. So now that we have our blocks set up, right, we're going to pause the animation that was there that you all saw. I know it. And focus on the transactions. So here we opted for points, because they're by far the most performant, at least for our purposes. We were thinking if we have a ton, it's going to be great if we do it as performant as possible. So we went with points. I think Dre has points, but we just opted to do it using Three.js directly here. And so we iterate through each block's transactions, and we're setting some generative positions in the vertices here. So here. So that gives us some of that generative art kind of overlap, which is kind of cool. And then we set it to the geometry, the position, and we return it in this points. And then we would put it into the transactions constant, just like we did with the blocks, so they all move together. Okay, so then adding our additional attributes, right? So we had those points, but now we want to add color and size to it. So first thing, right out of the box, points doesn't allow us to do that, right? It kind of takes in one color and one size. So we had to create a custom shader to do this. We're not going to talk about that today. I still don't understand shaders, honestly, but I got it to work somehow. Matt Delorier has some really great teaching materials on that if you're interested. There's also a book of shaders, some really cool stuff that people are doing with shaders. So anyway, we're going to create a custom shader material. And then we're going to do the same thing we did with positions, but for size and color. And then we're going to set those attributes to the geometry itself. Okay, cool. So I think you'll be able to see the movement here on this one. So now we're going to add some sound. You can use positional audio from Dre, and we're going to drop this right into our points component as well, right? So we're going to have an audio use ref, and we're going to attach it to this positional audio. One thing to note here is that you do need like an initial click from the user to kind of initiate everything. And so you can kind of see, as you can imagine, as these transactions come up into the block, right? So we're iterating using our use frame, we're iterating through it on every frame. And if once they hit that threshold, they're going to release the sound. And you could do some cool things, right? You could set the position of the sound itself. You could set the volume based on the size as well. And you kind of, as you could see there was like 2 different types of sizes, right? So you can imagine hearing, okay, maybe a less sound for one of them and more sound for the other. So what's next, right? So we're in San Francisco's Innovation Center, but we're looking to expand into new spaces, new innovation centers around the world, also online, which is going to be cool. And then looking to add additional functionality. The crypto team has some additional data. They want us to be able to click on a transaction and really drill down into it. So that's going to be fun. And then adding more immersive features. So maybe we can get some touch panels or really enhance the audio, make it like a true installation. So that's it for me. Thank you so much for listening. Please reach out. I'd love to hear from you. Thank you.
Thank you, Stephanie. See, the nerves are for nothing. You were amazing. Thank you. Next up, we have a first-time speaker, also a little nervous. So if we could give him a shout to encourage him, that'd be great. We have Ryan Magoon, who currently is a senior staff engineer at PayPal and is going to be talking about building for disabled power users. Let's go ahead and give Ryan a warm, warm welcome.
Hello, everybody. Cool. So today I'm going to talk about why I picked this talk, do a little discussion about like what a power user is and what their persona is like, and how we're like playing off of it, some more specific accessibility stuff, and then some case studies where I think these things have actually gone well in certain apps, and then next steps that you can take away in your own work. So yeah, I'm Ryan. I work on PayPal checkouts, doing some product work and some things on the web platform team. In the past, maybe 5 or so years ago, I've done some pretty big web accessibility overhauls at big e-commerce sites that you've probably used. And as it pertains to this talk, a lot of my interest for it is growing up in a deaf family, having ASL as my first language, growing up around sign language interpreters, blind, deafblind people. It's like really affected how I see, just assistive technology in general, how people are using it. So I want to tell you a story about why I picked the talk. 8 years ago, me and my partner were just starting our careers. I was doing the JavaScript stuff, and she was a lawyer, and she had just gotten out of law school, and she did really well, went to a good school, winning like moot court competitions, had a lot of accolades, and she passed the bar on the first try, all the stuff you want to see. But when she started getting interviews, she got interviews at good places. One of the better places in our state, she went and interviewed there with a senior partner. And like one of the first questions they asked her was like, if you're blind, how do you read? Other questions were like, who's helping you do your work? So it didn't go well, to say the least. It's hard to get into the brass tacks of like, practicing law if they start with like questioning like if you're literate. So anyways, the punchline of that is that she actually started her own law firm, and it's one of the biggest employment law firms in the state. And she's actually won cases against those people. Yep. And she's also a traditionally published novelist at the same time, and she's got a book coming out next year and a few more on the way. So needless to say, she's getting stuff done. Although her story is a positive one, this mindset is like not unique to lawyers, and I think it's really pervasive. But obviously, in my career field, I've seen it as well. And so I want to do the talk to kind of compare and contrast there and see if we can take some lessons from it. So almost positive, if you work in accessibility, you've heard these things. especially when you're asking like, okay, should we do it? We don't have disabled users. Disabled people aren't in a hurry, or we can make it accessible later. Like from a naive perspective, this might seem like these are valid questions, but I do think they're the result of just being culturally unaware and just like going with status quo about what the mind think is about treating accessibility. So I want to propose a different mental model for reasoning about users with disabilities, and especially those using assistive technology. So yeah, it's very clear to me that there are stereotypes about what disabled users are doing, and like how they use the computer and stuff like that, that is like fundamentally causing a first principles problem here, like cognitive dissonance. So I want to talk about power users. This is the Wikipedia definition. It's user of computer software, other electronic devices, who uses advanced features of computer hardware, operating systems, programs, or websites that are not used by the average user. A power user might not have extensive technical knowledge of the systems they use, but is rather characterized by competence or desire to make the most intensive use of computer programs or systems. So to go further into that, these are the people who know all the keyboard shortcuts. They love telling you about it, about your workflow. They evangelize it. They're always giving feedback to the people making their tools or even working on the tools themselves. Always looking for efficiency improvements. Ergonomics matter to them a lot, and they are usually not satisfied or well served with casual experiences. I want to contrast that with a disabled, like I'm quoting power user, who is also learning their tools very deeply, using advanced features. They're very loyal to those tools. They don't like to change them often because these tools have a high learning curve, and they prioritize efficiency as well. Because of the learning curve, they're really sensitive to changes in functionality that affect their workflows, and efficiency is extremely important. With a person who can use a mouse and can use a keyboard, the order of magnitude for like not being able to do one or the other isn't that big. But if you break the workflow for somebody who can only use a screen reader, it can become extremely slow. Like a 5-second task now takes like several minutes, something like that, or even longer. So I made this diagram. I believe there's a really complete overlap between these two user personas. And I think if we treat our assistive tech users the same way that we would treat market to prioritize a power user, we could get really good outcomes pretty much across the board. The benefits here, in terms of just thinking about it, you have average customer value going up. The reason is because these are like stable long-term users of your product. So they realize lots of value. Like they're literally professionals with it. And they can make it work for them with like minimum friction and maximum impact. They're probably going to be the ones writing like all the customer reviews for you. They'll be the otaku people. Like if you hear somebody, a friend of a friend was like telling me that I got to use this app, it's probably going to be like this class of user. And what's so attractive about them is they help you market and sell your product because they're enthusiasts and cheerleaders. They'll provide testimonials, case studies, and they'll just refer your service to everybody they know and build communities there. I want to take a step back and define accessibility and usability. For me, accessibility has more to do with, can I do a task? Can I technically do the task? Is there anything blocking me from just like actually completing it? And usability is more addressing like, how well can I do that task? How effectively? Like in timely manner. When we talk about compliance-based accessibility, this is like the traditional work that we're all doing, that we get assigned our JIRA tickets after we get sued. This is basic stuff though. Color contrast, keyboard navigation, font sizes, captions, focus, more stuff like that. AA is the standard that they hold you to, and then AAA is feasible. And if you have a specialized app, some of those AAAs would be required because they're like really pertinent to the use case. In terms of the automated testing that we'd use for that, there's Axe. That's going to be in like most of your front-end frameworks. There's going to be some way to put Axe into like Jest or Playwright or something like that. where it just like statically analyzes what's going on and tells you if you have some kind of violation. And they map pretty cleanly to these WCAG guidelines. You also have Wave and Lighthouse, which are more like Chrome plugins or whatever kind of browser plugins, where if you have a site running, you can hit a button and it'll give you a rundown of what's going on the site, and you could maybe click through it. On top of that, React Testing Library is actually quite good for catching accessibility stuff. If you write your queries well, if you use the accessible roles and like actually write the queries as if you're a screen reader user, that's really powerful. You can actually get quite a bit of surface area to cover stuff. So that being said, compliance and automated tools are just straight up not enough to ensure accessibility and usability. I pulled up this article that we found a few years ago where a guy actually like made a 100 Lighthouse score site that was straight up unusable. You couldn't click anything, you couldn't see anything. It's like really slow. Yeah, it's really funny. You should look it up. I have the link, but I remember Swick shared it with me. But yeah, the point is, if you can do that on purpose, you can definitely do it on accident. Yeah. So if you can follow the WCAG, but you choose like not to take the time to test the implementations by real users, I think you're exhibiting a lack of care to like take time for people who can help make your product more accessible. And what it looks like is a success gap between classes of users, just due to poorly planned or poorly vetted feature development. Yeah, accessibility testing can be partially automated, but the usability testing, which is going to drive success for power users, people who don't have a lot of time and are trying to accomplish tasks quickly, that kind of testing and validation can only really be done by people. But that being said, all the automated stuff is important. It's like TypeScript, it's like the static analysis layer almost of like, okay, cool. I'm covering most of the dumb stuff, so I don't have to think about that so much. Then I can focus on like these core workflows and like optimizing and milking everything out of them. I have a few case studies I wanted to go over for apps that I think are getting this right and making first-class experiences for like disabled power users. And I think they're best in breed and have staying power because they're doing that. Discord is the first one. Normally, you have to read some docs to figure out how to do special keyboard stuff. In Discord, the first time you hit tab like 3 times, it has a pop-up and it's like, hey, buddy, you're tabbing through stuff. Guess what? There's like all these other ways you can do that even faster to jump around and get to stuff and interact with things. It tells you how to use the keyboard shortcuts, and then you pull those up. And it's great because normally you'd have to like tab to a message, read the message, then you're tabbing to a button to get to the emoji picker. Then you open that up. Then you like tab to the thing you want, or you tab to you're just tabbing everywhere. If you have the ability to just like go to a message, there's contextual key bindings where you can just hit a thing and like, boom, you have a heart or whatever. And it's customizable to the point where you could even do more specific workflows for that. If you like had a specific emoji, you always hit it or something like that. You also have drag and drop for organizing lists, which is super cool. Adjustable text to speech, and just for like across the board accessibility accommodation stuff, like reduced motion, color blindness settings, things like that is like all really changeable, which is cool. It's also one of the few apps that makes adding alt text really easy, and then giving you inline support to like make sure it's like, hey, here's a help article to like make better ones if you're worried about it. VS Code is actually amazing. It has so many cool power features for this kind of thing. It's kind of mind-blowing. So it has audio cues. So normally if you have like a TypeScript error, you have like a squiggly or a warning squiggly, they all have different sounds. If you scroll past the breakpoint with the screen reader, it makes a different sound. If you have like a build error, it's a different sound. And anything that can be tracked as an event in VS Code, you can also make unique events for that. It's really cool. Every action is a command. So like every discrete action you can do in VS Code is like a piece of functionality that you can then plug into like other stuff in the app. So it's really extensible in terms of like workflows that you can create. And then you can like tie that into like voice commands and just do all kinds of things in a really cool, efficient way, depending on what your setup was. Obviously, the theme is very customizable. You have the command palette, which is great. That's innovated by Sublime Text back in the day, but then you see this feature in like every power user app now. Superhuman for email. This app has a fantastic one. Obviously, things like Raycast. It's really cool. But for this, it's amazing. And then depending on what kinds of stuff you have going on, there's Zen modes. If you have like ADHD, it's really good to just like bleed the UI away and just focus on your code. I was like debating whether to include this one because I don't know how long it'll be true for. But Twitter does have amazing accessibility. Their team is wonderful. Was wonderful. I love that they made alt text a first-class citizen of the UI. I feel like millions of people know about alt text and what good alt text is now that just wouldn't have any clue what it was before, which is amazing. It has really good keyboard shortcuts. And like I mentioned with Discord, it makes it really easy to just be on a message and contextually take an action instead of fumbling through the buttons to figure out how to take an action. And then the UI is pretty customizable in terms of colors and things like that. So I have compiled a list of next steps you can take as an organization to address some of these things. And kind of in priority order, I think the absolute most impact thing you can do is hiring disabled developers, designers, and leadership. And it's actually leadership first. From the top down, you need that. Because if they're bought in and they understand the concerns and the needs, you won't make so many dumb mistakes because intuitively you just would never make them. And so that's really where it starts. You'll get the most mileage out of that. But without that, you have to do training on your own to kind of get there with your own knowledge. So regularly measuring time to complete critical app workflows with assistive tech. I think you would call this usability testing. I'm just even more specifically saying usability testing with specific assistive tech setups. So like with a screen reader, with a Braille display. Yeah, even like mouth control, it really depends on what you have going on. Yeah. Including accessibility immersives as part of onboarding. There are certain companies, I think the Q is one of them, I'm not sure, but you can like go on site and get really super good accessibility training. So like not just learning how to use the tech, but you can simulate like macular degeneration, retinitis pigmentosa, all these different types of blindness, so that if you did that and you learned the tech, I think it can really help you understand what you're dealing with and who you're building for. Making accessibility part of OKRs and evaluation across the org is a great way of holding yourself accountable to doing those things and living your values, so to speak. Onboarding and documentation are really important. Having good tooling is great, but oftentimes this is custom and it's not something that's going to be able to be looked up anywhere else. So you have to provide the docs and maybe even reach out to specific users, have great knowledge bases. Discord had a good example of that where it kind of like jumps up and it's like, hey, I see you might be trying to use this. Those kinds of things are really great. It goes without saying, I think, from your product leadership all the way through design and to development, everybody actually needs to be able to understand how to use screen readers and keyboard users. As a baseline, I really think you have to do that to build the empathy required to make sound decisions around products. And then when it comes to UX and community building, you always need to make sure that you're including disabled users. Getting feedback from them in forums like where it's more about like product support, and then also building actual community. For individuals, I would say some of the same things. I would say learn assistive tech very deeply, get very good with the keyboard nav, get very good with the screen reader, and I have a few listed. So like if you're a Mac person, definitely do VoiceOver. Talkback is probably also relevant. It depends on what kind of stuff you're doing, but yeah. One of them will pretty much get you ready for all of them. Get good at writing really good alt text. It makes a big difference. Just writing it is one thing, but I think if you actually look up what good alt text is, you can make a big difference. Listen to disabled voices and make disabled friends. It's really going to help you build empathy. And participate in accessibility and disability communities. Depending on where you are, that might be hard. You can go online and definitely meet people. I know there's like Slack groups and things like that. Yeah. So I want to like begin to close by saying the problem here is that you can't build products for people that you've never met. Going back to the story, like people don't even believe that high performing disabled people exist, and yet I would say they're pretty much everywhere. And I've met so many, and so the point is the exclusion in our industry is the problem, and the better outcomes can only be reached by including disabled users in research, hiring disabled people in leadership and product development, learning the tools that those users use, and expanding our cultural horizons so that we can stop causing poor user outcomes from lack of awareness. So looking in the future, until now, disability tech has been like an overlooked multi-trillion-dollar global market in terms of total statistics. It's actually bigger than the GDP of China, I believe. So disability is a through line for the entire global population. And as people age and the rate of non-communicable diseases rises, the global disability community is going to be 3.5 billion by 2050, which is up 130%. So as stewards of the next wave of technology, we have to make sure that we're building systems and tools that include as many people as possible. And at the pace technology is accelerating, we're running out of excuses not to do so. So like I put in the slides, we have self-driving cars coming. We have AI mixed with augmented reality. So you're gonna be able to put on glasses, you're gonna be able to figure out all kinds of stuff. We have really fancy refreshable braille displays that are like multi-cell that are becoming affordable. So deaf blind people are probably going to pretty accessibly easy to make it easy for them to become coders in the next wave of educated kids learning this tech. So I think companies and individuals who embrace these changes will be at a distinct competitive advantage over those who don't. That's all I got. Thank you.
Thank you, Ryan. That was an amazing talk, and thank you for sharing the inspiration behind your talk. Next up, we're going to go ahead and welcome our next speaker. We have Rashmi Nagpal, who currently is a software engineer at Cactus Communication, and Rashmi is going to be talking to us about building your machine learning model on Edge with React Native. Let's give it up for Rashmi.
Okay, thank you. Hi everyone, I'm Rashmi Nagpal. I'm a software engineer by profession and a researcher by passion. So this is my first time presenting here at React Miami conference. I am a bit nervous, but at the same time looking forward to share my learnings with all of you. So the topic which I'm going to talk about today is build your machine learning model on Edge with React Native. Without a further ado, let's get started. The agenda of the talk is, firstly, I'll talk about why this topic is the need of the hour. Then we'll cover about the basics of machine learning and the edge computing to bring all of us on the same page. Then there is an application demo, which I'll be demoing, and also the what are the use cases possible from the machine learning on the edge devices. And towards the end of the talk, we'll discuss about what are the challenges that we can face. And further on, there is a summarization and a bunch of resources for your future reference. So let's get started. Imagine that you have trained an incredible machine learning model whose accuracy outperforms your wildest dreams. Now, you are ready to deploy that model into production to make it accessible for your end users. So, the logical next step for you is to package the model up and to deploy it using any of the existing managed cloud services, either AWS or GCP. However, you are in the state of shock when you see the cloud deployment bills. It's $20 million. That's big. To support the story with real-time statistics, as you can see on the screen, on the left-hand side, companies like Asana and the Datadog, they invest like half of their revenue on the cloud. And the graph on the right-hand side shows that the companies like the Pinterest, Capital One, they are increasingly investing in the cloud. Now, because of the rising price in the cloud in itself, more and more companies are looking to the ways to shift their computations on the edge devices. And that's where edge computing comes into the picture. Also, in 2022 alone, approximately $490 billion have been invested on the cloud computing, and out of which 30% was wasted, which is approximately $197 billion have been wasted. So these are big numbers. Let's see how the edge computing comes into the picture. But first of all, what exactly is edge computing? So edge computing, according to the Wikipedia resources, state that it refers to the distributed computing paradigm wherein the computing resources are placed closer to the edge devices, thus providing faster response time, lower latency, and of course, reduced cost. But wait, how does edge computing help in this case? So cost reduction. When you are deploying machine learning models on the cloud, you need to get the data back and forth from the cloud, which implies you have to do some real-time prediction, and also for the data-driven decisions, you need stable internet connectivity. What if that's not available? So when you are building machine learning on the cloud, and if you are handling the user-sensitive information or personal identified information, then it also could raise the concerns of the security and privacy. Next, so if you're also running machine learning on the cloud and handling, again, the user-sensitive information or just getting the data from the cloud in itself, then it also, again, does lead to the concerns of the security and privacy, but it also leads to the concerns of the reliability. And also, if you're building models, and if your models are deployed on the edge devices, then it's okay to have a lower inference latency than the network latency. What I meant by the inference is when the model is given some data-driven decisions. So let's have an overview of the concepts. What exactly is machine learning? Because the core of this talk is built upon what is machine learning, and we'll be building machine learning model from the scratch. So AI is, in a nutshell, a bigger umbrella under which machine learning and the deep learning comes in. Machine learning is basically when you're training the models on a labeled data set, and the model is learning from that labeled data set in order to give some predictions. Deep learning is a subset of the machine learning, which is going one step ahead, in which it is extracting the patterns from the data, and then it is performing whatever the algorithms or the mathematical computations in order to give you some data-driven decisions. The example shown over here is the handwriting recognition for the deep learning. And spam email detection is the example which is given here for the machine learning. Given that you have labeled emails data set, and you need to determine whether the email is a spam versus not. So what you will do, your model will learn the patterns / you are also explicitly programming your ML algorithm. Okay, this is the data set, these are the features. Now apply this algorithm and let me know whether that email is a spam versus not. So far, we have covered a lot of theory. Now I want to test. I just want you to take a minute and think which of these faces are real. The face A with the women and something in the background. Can't justify exactly what it is in the background, but yes, there is something. Or the face, please raise the hand if you think it's a face A. Okay. Nearly 5% of the people in the audience. Please raise the hand if you think it's a face B, which is the real one. Okay. I see approximately 50% of the people. Okay. Please raise the hand if you think it's a face C, which is a real face. Okay. There you go. Okay, sure. Well, the news is none of these faces are real. This is an application of the generative modeling. Unfortunately, none of these people exist, at least on the planet Earth. I can't talk about the extraterrestrial planets, but of course. So the generative modeling, what happens in the generative modeling is you are given the human faces data set, which is publicly available, and then you are training on those publicly available data set. So to synthesize data set which looks very much similar to what it actually exists, like in the real world. So generative modeling, or you can say deep generative AI, it's a very powerful and it's a very complex idea. For example, OpenAI has also released the ChatGPT. It's a generative AI application. DALL-E is also released by the OpenAI. These are all generative AI models. Okay, so we know about all these generative AI modeling and about the AI algorithms, but what is exactly the underlying building blocks behind these algorithms? And that's where neural network comes into the picture. So that's the basic neural network structure. It's the building blocks behind all the algorithms that you can think about in the AI space. So what this exact structure implies is, given a data set as an input, you are applying machine learning algorithms. At the moment, just understand machine learning nothing but as a black box, which has weight, sum, and bias, and activation function. And then you are finding the output. Output is nothing but which you have already predefined. Well, maybe I want to do some image classification, or maybe I want to do some spam email detection, something else. These are certain examples. Let's understand this basic neural network structure through an example to get more clarity. So here, the use case that I'm trying to identify or I'm trying to work on is, given an image, you need to determine whether this image, which category or animal category that image belongs to. So right now, your system doesn't know which image it is. So you are just providing a blank image, the image of a cat, which we can visualize right now. And so the system will understand it nothing but not as an image, but a combination of zeros and ones. And then you apply machine learning algorithms on top of it, which is what we saw in the last slide, that you are applying weight, sum, and bias and activation function. And then it will give you the output with certain accuracy or certain confidence interval, as what you can say. So now it states, after applying image classification algorithms, it is telling, with 82% accuracy, this image is of cat. Let's understand and let's also implement this image recognition using existing libraries in the JavaScript. But before that, let's also cover what are the principles behind it. So the very important and the crucial question next I want to solve is, can we really develop machine learning models in browser/on device? Well, the answer is definitely yes. There are a bunch of techniques that we can adopt and we can deploy or /build the models. First is using the quantization technique. What I meant by quantization, it's nothing but an optimization technique. Basically, it reduces the precision of the numbers which is being taken by your model's parameter. Quantization is significant. It's very much useful because it significantly reduces the memory and the compute requirements for your model, and therefore people generally adopt quantization techniques. Again, we already know that specialized hardwares are available, so we can definitely use specialized hardwares like the GPUs or the TPUs in order to build machine learning models on the edge devices. Because we know that machine learning models are very much compute intensive, and of course we need, strong hardware. And also a lot of applications, a lot of Android and, a lot of cell phones, they do have the GPUs and the TPUs inbuilt right now. So we can definitely build models on using those, accelerated, or I would say hardware features. Next, and the most important, is using in-browser machine learning frameworks like the TensorFlow-JX, ONNX-JX, or Core ML. Core ML is definitely useful for when we are building any machine learning application on the iOS devices as well. So let's see a demo. Okay. So right now, what I'm trying, so I have already the template code ready with me. I have already imported the Onyx.js as one such library. The use case that I'm trying to solve right now is here. Given an image, I need to detect what all features or / what this image comprises about. There could be like some people in that image. There could be something features will be there in the image. So the model needs to determine which particular entity, I would say, it belongs to. So again, over here, right now I've defined a constant, that's a model name. And here I'll just write the model that I'm trying to use. Here I'm defining the input parameters or / I would say the dimensions of the input. Top key implies the top features that I want. And again, I can define the threshold values. Here I'm trying to define the tensor, which is the basic building block behind all these neural network. And how I'm going to do it, I'm calling this tensor function and passing in the float, which is float parameter. And next, here I'll be applying the quantization technique because I want to give a live demo about how we can apply the quantization technique. Creating a float 32 array and then passing it input data, model input shape, and then using the reduce function. Well, never anticipated this, but it's good. Maybe we need to train the models to do the fall of this alarm detection, maybe. I don't know. Let me try it. Okay, so here I am just passing in the model input shape. Yeah, just a second. So again, definitely live demos are not the right approach for me. Okay. But of course, as a developer, we are meant to build, break, and develop, I guess. Okay. Just a second, maybe. I do have the template code ready though, but I can still do it. Yeah, there is a parenthesis I know which is missing. Okay. Yeah. Yes. Okay. 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 Oh, wait, it will not work. Because we need to define the tensor. Since we have defined the tensor, we need to use it as well. Okay. Wow. I never anticipated. It's good. Okay. So I defined the tensor, and of course, in the config, which was already defined before, I'm passing it in the YOLO v5, which is an image recognition model that I'm using. Okay, it needs to be the full screen. Yes, it's going to work. I'm not going to disappoint any one of you. Okay, so it's loading image recognition model. Okay. Well, I'm talking about latency, but I'm not incorporating latency in my model itself. Come on. Oh. Value never used. We used it. Oh yeah, I saved it, I think. Oh, thank you. Oh my gosh. What? Yeah. Okay, finally. Welcome to React Miami, everyone. Okay, now it's time for a quick test. Let's see whether it actually works. Definitely should work. Okay, cool. So we can see that using the image recognition model, it is identifying whether this image has an entity of the chair, which definitely does have, and also different people out here, and also the TV. And there is also like a backpack, which you can see in. So it creates basically the bounding box. So bounding box means whenever you need to identify what entities are there in your image, it creates a bounding box for every specific type of an image. I can also try for some other. Let's see. Image. Oh, what's happening? Okay, cool. So I'm not embarrassed anymore. Cool. So here you can see that the backpack, people, traffic signal, traffic light actually. So that's how it shows, it creates a bounding box, identifies which particular entities are there in an image. So that's a very basic example. Okay, now, come on. Okay, let me move on to the slides again. Okay. So we can do the same thing on the Android application, and that QR code on that side, you can access this code afterwards. It's available on my GitHub as well as the slides are available, so you can refer it for your future reference. Next up is let's build your own machine learning model. So the use case that I'm trying to solve right now is given a sentence, you need to identify to what sentiment that sentence belongs to. What I meant by the sentiment is whether it's a positive, it's a negative, / it's a neutral sentence. So let me give you an example. I am super excited to be presenting here at React Miami conference, and especially thankful to Michelle and the other organizers of the React Miami conference. So that's a positive sentiment, right? And the other sentence could be, I don't like pineapple on the pizza. So that's a negative sentiment. So the first thing that you need to do is install whichever libraries that you're trying to use. Either it could be the TensorFlow.js, or either it could be the Onyx.js or / other libraries, ML framework libraries that you can use. Next is you need to define your model. What I meant by defining your model is you need to create an architecture of the model. So firstly, we'll provide what is the input dimension of the input that you're trying to, the input that you will be feeding in. Then you need to define how many layers the model will have. And then further on towards doing the evaluation, which metrics you will use to define, how will you evaluate your predictions made by the model. Here I'm using the metric as an accuracy. So once we have created this model, now it's time to train the model. But before training the model, it's important to divide your data set into, like training, testing, and the validation. So what I meant by training, testing, and validation is, so there will be some, in the entire data set, there will be some part of the data set which your model will use to train and learn from. And then there will be some part of the data set on which your model will be tested / how much prediction it is, with what confidence that prediction it is giving. And the validation is used for when you want to fine tune the hyperparameters. So here I'm defining epochs as the 10. What I meant by the epochs is number of iterations your model will take to learn from the training data set. And validation split, something like 80-20 or 80-10-10. If you divide the data set into 80% will be like for the training, 10% for the testing, and 10% for the validation. So that's what I've defined here. And then, so you call this model train model. And the next is you use the prediction. Now here we are defining the predictions. Once we have trained the model, and we create this async function in which we are passing the model. 3 parameters that we are passing. First is the model, which we created in the previous slide. The architecture when we define. The tokenizer, basically splitting the sentence into certain tokens, and the text on which you want to make a prediction. And then it will give you the predictions toward sync function, and then it just gives you the prediction in that case. These are the 4 stages that you need. Of course, installation of library, training the model, and of course, defining the architecture of the model, and then making the predictions. Okay, so the next crucial question is, what are the potential applications of the ML on edge devices? I have not included the exhaustive list, but these are a couple of the applications which are possible and will give you, the idea of infinite applications which are possible. First is recommendation system, that you're getting the notification on your cell phone / on their device that, oh, this is particular genre of the movie that you might like or maybe have seen before. So it's kind of a user-centric personalized recommendation system. In the patient monitoring system, for example, you already use the smartwatches, right? So the inbuilt technology behind is when the doctors can actually assist their patients which are remotely and can assist in their healthcare. Predictive maintenance is definitely useful for the energy and the transport sector if you want to detect the power outages or if there are some outdated equipments. Next crucial question is, after all the rosy picture, these are the benefits of machine learning, these are the applications which are possible, but what exact challenges that we can face? So let's see that. First is memory constraint. We know that the edge devices have a limited memory storage, and machine learning models are compute intensive. So, you can't train from the very scratch bulky machine learning model. What I meant by bulky models are the models which are trained on billions of parameters. Like ChatGPT is trained on billions of parameters. So we can't do that. We can't train the models from scratch on the edge devices for sure. Of course, we need these specialized hardware in that case. So data quality is the next challenge. If the edge devices are producing low quality or / noisy data, so AI algorithms in a nutshell will not work, and it just kills our purpose, because AI algorithms does require a lot of good quality of data set. And again, limited computation resources is because it's the same thread which is linked to the first one, memory constraint, that you need a lot of specialized hardware / you need some frameworks which are already prevalent in the machine learning that you can use for the building the models on the edge devices. Next crucial question is, what are the best practices that we can follow to build / deploy, in a nutshell, bulky machine learning models on the edge devices? So these are some of the best practices which I have adopted and I also use in my day-to-day work. So first is optimize your model's runtime using the quantization pruning techniques. Quantization example, I've already shown it to you. Pruning, or maybe like knowledge distillation. In knowledge distillation, you have the bulky models. You can just distill the knowledge into smaller models that you can run on your edge devices. And finding the right parameters for your inference, be it the batch size, be it the epochs. What I meant by epochs, again, the iterations. For example, your model is giving 97% accuracy in 5 epochs. Then why do you want to train it for 50 epochs? So in that case, you need to think through, or maybe just do some hyperparameter tuning, wherein you are just playing hard or just, like trying and testing out different parameters which are providing into the model. Benchmark. Next one, benchmark in the sense implies that, benchmark your model or your end-to-end application to figure out if there are any bottlenecks. It could be the data processing stage. It could be data loading stage. It's just not only the inference stage, but, there are various stages when you're building machine learning pipelines. So you can benchmark every stage in order to find if there are any bottlenecks that you can improvise. Next is use the concurrent or the multiple processes / threads to revamp your code. Again, it's linked with the code optimization the best you can. Again, the better your model and the faster it will give the predictions / the real-time data-driven decisions. Again, so next one is the frameworks. When I say the mobile-friendly frameworks, it's the PyTorch Lite or the TensorFlow Lite, and the example that I gave before as well. So, there is no point in reinventing the wheel when we already have the frameworks in hand. So we can, of course, fine-tune based upon our use case that we are trying to solve. And, like just feed into the data set that we are trying to plug and play with. The last and the most important is reusing. When I say the reusing, it's reusing about the data. For example, you have trained the model on a task 1, and that task 1 could be a speech recognition, that task that you're trying to achieve. Then you can use the same data set to achieve the goal for the task 2. This concept is the transfer learning. So you can adopt, like some of these techniques in order to deploy or just reuse and just avoid some of the heavy computations that your model might require. These are a bunch of resources for your future reference. And that's all I have for you today. Thank you so much, everyone.
Thank you, Rashmi, for that amazing talk. I believe we have an announcement before we introduce our next speaker. So I am going to go ahead and hand over the mic.
Hello, everybody. So my name is Rebecca Bakels. I am a software engineer and tech community advocate at City Furniture. Some of us already met at the React Miami Docs Club in the City Furniture Lounge over there. So I just wanted to take a minute and talk about City Furniture and why we sponsored this amazing event for our second year. So this is so cool to see happen again. So City Furniture, for those of you who don't know, is the largest furniture retailer in the state of Florida, and we are currently expanding out into the rest of the nation. So why are we here? Are we trying to sell you a couch? Yes, absolutely. Come see us. You need furniture, we got you. But we also build all of our software in-house. So everything from our shipping and delivery straight into our warehouses that's connected directly into our showrooms and of course our e-commerce platform. So that's a lot of technology, that's a lot of people. So we want to be in these rooms, having these conversations with you, learning, continuously growing, and making sure that these events come back year after year. So very happy to be here. And if you want to learn more about City Furniture and what we're all about and our technology, come say hi to me or one of my team. We also have a booth set up inside, and grab one of these sweet hats, please. And enjoy the City Furniture Tech Oasis for the rest of the conference. Thank you, guys.
Thank you, Rebecca. Please make sure you swing by, grab some swag if you're from the area, purchase some furniture. But thank you for the sponsorship and the announcement. Next up, we have a dynamic duo. We have June Shaw, who currently is a developer advocate at ESLint. And with June, we have Hoshki Tsunoda, who currently is in design systems engineering at Optimizely. And they're going to be talking to us about data-driven design systems in practice. Let's give it up for these two.
Hello? Am I on? Hey, folks. Before we get started today, I just want to do a quick survey of the room. How many people here are developers? I'm expecting a lot because it's a React conference. All right, most of you, all of you. How about designers, product designers? We got a little sprinkle. How about some other disciplines like executives or product managers? We got a couple in the back. Great. Well, thanks for sharing that with me, folks. So out of everybody here, who has heard about or worked with design systems before? Raise of hands. All right, most of you, there's some hands that hasn't been raised. Well, don't worry, for those of you who don't know what a design system is, that's what we're gonna start the talk off. We're gonna define what a design system is for a front-end developer. And then we're gonna push the envelope just a little bit further. We're gonna talk about using these data-driven design systems in practice. My name is June. I'm a developer advocate for ESLint. For those of you who don't know, ESLint is a component analytics tool for front-end teams who are working on design systems. I'm joined by Hoshi today. He's a design system engineer at Optimizely, an early user for ESLint, and he's a Coachella DJ that has skipped this year to be here with us today. So Hoshi, thanks for joining us today here with me at React Miami. Can you take a little minute to introduce yourself and a little bit about what Optimizely does?
Sure. Hi, everyone. My name is Hoshki. I'm a design system engineer at the Optimizely. Like June said, I come from music background, so you might think I'm used to being in front of people, but this is different.
This is first time speaking.
Yeah, it's pretty nervous, but let's do it. Woo-hoo. Yeah, so you might know Optimizely as more of like an A/B testing company, but we actually do more than that now. So we do like personalization, optimization of website, and we even have like a CMS now too. So it's more like an all-in-one solution for web experimentation.
Cool. Yeah, I had no idea you guys went into CMS and all that kind of other stuff. That's great. That's great to hear. So for those of you who don't know what a design system is, Hoshi, can you take a little minute to define what a design system means to you?
Yeah, so the definition of design system is probably different depending on the organization and the teams. But in general, design system is a collection of reusable components, guidelines, and principles that helps maintain consistency and scalability of digital products. And it is very important for Optimizely because we acquired like a few companies in the last few years, and all those like different looking products are brought into like a product line. So we needed the design system to kind of put them together and give it the unified feel and the look to it.
Got it. So speaking of design system, today we're going to talk about 3 things. The first thing we're going to talk about is some of the challenges Optimizely face when creating a design system from the ground up. Second, we're going to share how ESLint is helping Optimizely create a data-driven design system. And lastly, Hoshi is going to share the business impact of using ESLint. So Hoshi, before we go into the challenges you faced, can you share with our friends here a little bit about the design systems team and Optimizely and a little bit about the Axiom component library?
Sure. Yeah. So the design system at the Optimizely is called Axiom, and it's been around like 5-6 years, maybe longer. But yeah, the name changed, and we are calling it Axiom, and it's the new design systems. And my team is made of 4 people, 3 developers and 1 designer, and we are like fully remote team, so we are located all over the world. And yeah, and we are a new team too. All of us joined the company last year. So, and we inherited the code base. So there's like a lot of things we don't know yet. So yeah. And Axiom includes React components and design tokens and the guidelines like documentation.
Great. So it sounds like you had an old design system in the back, and now you have a new design system called Axiom.
Yeah.
And you actually have a team behind it now, because before you probably had it distributed between maybe some designers or maybe some front-end developers, but now you have a team that owns it, which is great. Can you share really quickly where you store all your components?
Sure. Yeah. So probably just like every other team, we use a storybook to store all the components and do testing and stuff too. And we have this like one pager. We list up like a lot of components, and there's like tabs, buttons, and typographies, all those components. And we also use Storybook to kind of like a documentation purpose too. If you go into like individual story, there's like, the definition of what component that is, and there's like props and how to use them. And also if you scroll down, there's like a, usage guideline, in this situation, you should use this state of the component. All that.
Great. So are these all your new Axiom components, or are these your old legacy components?
Oh yeah, these are all like new Axiom components.
Got it. And around how many components do you have right now?
There's about 50 to 60 around there.
Cool. Yeah. Well, thanks for sharing your Storybook instance with us, Hoshi. That really colors a picture of where you put your component library in. So a design system, I think, is a product, is an internal product that kind of fuels your internal team to produce better, faster products, more consistent, and it's on brand. But just like any product, there might be some roadblocks and challenges along the way.
Yeah.
Hoshi, can you share some of the things that you encountered?
Yeah, so like I said, Optimizely has 2 design systems. One is new Axiom design systems, and one come from acquisition. So we encourage teams to start using the new Axiom components, but all those legacy code base, it's kind of hard to adapt them like right away. So we needed some way to identify those like older legacy components in more of an automated way. And also, our current goal is to visualize the component adoption percentage, so Axiom components versus custom components or legacy components, and the component usage, and also the impact of updating the components. Can we update this component safely without affecting other part of the code, or the product? Yeah.
So it seems like there was a lot of factors that are going around that you had to kind of juggle with.
Yeah.
What was going on in your mind at that point to start thinking of a solution like ours?
Yeah, so when we started this initiative, we realized, it's gonna take a lot of, effort to like achieve all of these. It requires, like getting all the data and visualizing everything. So like, yeah, and with the lean team like ours, it could have been like, really long-term goal. So yeah, and then we just came across ESLint, just perfect timing. It was just released back then as a beta. So yeah, I'm more curious, like why you guys decided to build ESLint?
Yeah, great. That's a great question, Hoshi. Thanks for asking. So over the few years, I've spoken to a lot of design system teams from companies like Optimizely, companies like GitHub, Segment, and Shopify. And there are like 3 major themes I heard. The first one is to track adoption over time. And like Hoshi mentioned, you have to do a lot of custom work, a lot of heavy lifting to kind of stand that up. Secondly, folks don't have detailed usage information about a component to make decisions on whether to improve them or maybe to even deprecate them. And lastly, if they do make changes or introduce new components into a design system, they don't know if they're effective. They don't know if they're being adopted. So those are reasons why we built Omelet.
Gotcha. Yeah, I'm so glad I found a solution like Omelet right when we needed it. So yeah, should we just go into the demo?
Yeah, let's hop in over to the demo. We'll play a little musical chairs. I'm going to take control for a little bit, and I'll just show you just the overall application. I'm going to pass it back to Hoshki so he can share his instance of running Omelet in Optimizely. So we are start off with this component adoption over time chart here. And this is a pretty useful chart to track your core versus your custom components. And then we have your core versus custom adoption by project. There's also some usage information on the bottom over time. And on the top, we have our components tab. And here, you could look up any of your components within Omelet, and we could drill down into a dependency tree, which Hoshki is going to show just a little bit. So Hoshki, why don't you take control again, and we could show off Omelet with Optimizely.
Yeah.
So Hoshki, can you tell us a little bit about the setup?
Yeah, so the setting up Omelet is extremely easy. So you just need to run the client CLI command, and install Omelet globally. And then once it's installed, you just go into each code base and then run analysis command in there. And at the end of analysis, there's it just gives you this URL, and you can click on that, and it takes you to this dashboard UI. And having this dashboard is very helpful to communicate this information to the stakeholders.
Cool. So it looks like there's a little checklist here on the right-hand side, right, to show you that all the steps have been completed. And I just want to kind of double click into your point that you just said about why stakeholders are kind of embracing this.
Yeah, so we tried like a few other solutions too, but all of them are more like a text-based or JSON format. So even though it's like a very useful information, it was very difficult to communicate that to the stakeholders.
Yeah, not everyone is equipped to decipher a JSON file or maybe just scroll through a bunch of text. So yeah, that definitely makes sense. How about we switch over to our first topic, which is adoption over time. So you mentioned that tracking adoption is really important for your overall health score.
Yeah.
Can you share how Omelet has been helping you out with this?
Yeah, so the Omelet just gives you this predefined chart, just like on the fly. Just if you go into there, it's already available. And the important metrics for us right now is the top one, adoption over time, and secondly, the core versus custom adoption by project. So yeah, and we also needed to know the number of usage of the per components in each project. So this is not predefined on this UI, but it's very easy to customize the filter in Omelet. So yeah, just just by changing the filter, I can extract those information.
Awesome. So I'm glad they got Omelet running up so quickly. I'm not really sure what these green and yellow colors mean.
Yeah.
So can you share with the audience what that entails?
Sure. So the green area actually means it's a core components, which means or the components that come from Axiom design systems. And the yellow area is more of third-party components, or it could be legacy components, or maybe it's the components that define locally within just that code base.
Cool. So is the process to kind of get the green turning higher over time in hopes that people will use more of your Axiom components?
Yeah, exactly.
Great, great. So if you didn't have Omelet, how would you go about solving this?
It would have been very, very difficult. Yeah, so adoption over time is usually very difficult to track because it requires, capturing data in a cadence and storing the data somewhere and then visualize it using like D3 or Chart.js or any kind of library like that. And the adoption rate by project is also difficult to achieve without heavy lifting, like, crawling through the code base and counting each instances and stuff. And there are other solutions too, but as far as I know, none of them provides this, already pre-made UI. So Omelet covers like all of those criteria, and and it just comes out of the box, So it was very helpful.
Great. Yeah, I'm glad you got up and running very quickly. How about we switch over to our second topic, which is detecting similar components. So we talked before, and you showed me in your design system that there's a lot of duplicate components, like your grid component. How are you going about addressing these issues?
Yeah, so for that, I use this component list view. So there's like a filters, and I already preset the filters. So what this is doing is I'm looking for the components that come from Episerver UI framework, which is our legacy component library. And I'm looking for those components within this one of our core products called Episerver CMS. So from this view, you can already see, there's like multiple components. Those custom means all the legacy components and a number of instances. And based on this information, we can think about strategy of like how to replace them or what to do with those legacy components. And also, this information is helpful to make kind of like a projection of like how adoption rate could go up if you replace all these. So like if you see like, the projected number of like, if you replace all these, then your green area could go up by this percentage, that kind of encourages people to, teams to adopt more. So.
Great. So it looks like this has your old legacy components, right?
Mm-hmm. Yeah.
And your old design system and all your new Axiom components. Just curious, how many components do you have now in Omelette?
There's so many. Just for this product, there's like hundreds of them in here. Each instance is like 40, 29 and stuff. And times product, so probably like there's hundreds. If anything, it could be like 1,000.
Oh, that makes sense because you acquired some companies earlier on, and you probably have to make it all consistent and on brand. Cool. How about we go into the dependency tree view? So let's double click into that.
Yeah. Cool. So yeah, identifying the duplicate components is one thing, but another thing we need to be careful as a design system engineer is like if we can update this component safely. Without having this kind of information, updating components is pretty scary because like if you update it, it could affect like other products or like other part of the code base too. So yeah, so from this view, you can kind of see this is more like a relationship between the components that you're updating to and how it would affect other components. So having this kind of like visualization helps us to be more confident about if we can safely update these components and have the teams use it.
Cool. So you can kind of zoom in here, right? Because the text is a little small. Yeah. Great. So this kind of gives you that 3,000 aerial feet view, and you can see all the regressions that may happen, like you mentioned.
Yeah.
And it kind of guides you on like what you could, what you could do and what you should not touch.
Exactly. Yeah.
Great. All right. Let's move on to our last point, which is migration. So understanding the usage of each Axiom component is super important because it helps you prioritize, what to put more resources behind it, maybe something to deprecate. Can you double click at this point and share how you go about doing this?
Sure. So the Omelette provides this very useful chart, components sorted by the usage. And I'm filtering this just with the core components, which means like the components that come from Axiom design systems. So, this gives you like, which components being used more. And if it's the components that being used more, that means it should be prioritized with the maintenance. And another useful information is like if you go down the list, you can see all these like lesser used components, and some of them are not used at all, like 0 times used. So we can use this information to create kind of like a possibly deprecable components list. So yeah, we use it for this kind of purpose too.
Got it. So like are these part of like your old legacy components that probably aren't being used or maybe used maybe once or twice?
Right. Yeah.
And then the hopes is to remove these to make your design system leaner.
Exactly.
So then it's easily adoptable and there's not thousands of components, maybe just, a few hundreds.
Yeah, exactly. It's the bundle size is another issue too. Like if you remove all these, the bundle size is going to shrink too. So.
Well, thanks for sharing that. How about we go into the business impact? So can you share with our friends here a little bit of the results you're getting by using Omelette?
Sure. So the initial round of Omelette analysis gave us like a lot of insight about how it's being used and stuff. And some of them are surprising, like finding out like which components are not being used and how many are there, and also like which teams are using more of design systems and which teams are using less of it. So now we have those informations. We are ready to like start planning on like how to improve the system and also like how to help the teams to remove those like pain points so that they can adapt it easy. Yeah, so we are kind of going by the saying, if you can't measure it, you can improve it.
I love that line. If you can't measure it, you can't improve it. There's been a lot of measurement talks over the past couple of days, so I think it's on brand. And going back to your Coachella days, maybe you should make a t-shirt and maybe some merch later on you could sell on. Great. So there's 3 things that we talked about. So it seems like the first thing is like measuring your component adoption over time really solve that tracking issue you had before, and you didn't have to require that heavy lifting. And then you're able to detect similar components in your design system and replace them with your Axiom components in hopes to improve adoption to get more into the green, less of the yellow. And lastly, now with data, what components to prioritize because you know the usage, right? So like you mentioned before, what resources to put behind, and maybe like those one or very least use components, you probably should deprecate that.
Right.
So I'm curious, after you got a lot of benefit from using ESLint, do any of your higher ups say anything about your initiative that you're spearheading this design system thing?
Yeah, so we recently had a little bit of a reorg, and then my team became part of the engineering team before it was like it was a product team. So our CTO is interested in knowing the overall progress of Axiom adoption, so he can encourage teams to adopt more. And also my team needed some kind of visualization to understand how our design system is doing too. So yeah, everything the omelet covers all of them, and just happened to be there, just perfect timing. So
great. So let's look to the future a little bit, and let's play a little make-believe. So if you were the CEO of ESLint and you had full control of the roadmap, what feature would you like to see the most?
Yeah, the first thing is definitely GitHub integration. We have so many repositories across the organization, and it just takes so much time to just manually run the analysis on each repo. So yeah, if I could just add it to the GitHub level and then just automate that process, it's going to be a huge time saver for us. And also another thing is a prop usage tracking. So if we could see, how teams are using those components by analyzing the prop usage, we can come up with a strategy for how to improve those components too. And I'm so curious, what's on the roadmap of ESLint for the future releases?
Yeah, great question, Hoshki. Thanks for asking. So right now, our immediate goal is to provide more visibility to component adoption. And to extend this, we are considering things like prop usage, like you mentioned, Hoshki, design token support, as well as other framework support, because we only support React right now, but we're looking into Vue and Angular as well. And looking a little bit further down the line, we are very feedback-driven. So encourage you folks to kind of try it out. We'll share a little bit of a QR code to set up you in the beta program, but we take all that feedback and we use that to figure out what we're going to build next. So Hoshki, do you have any final words you want to say to the audience here?
Yeah, so Optimizely recently released a new feature called Rollout, and Rollout is a free feature flagging platform. Comes with managing features in one place and targeting specific user groups, or if there's any errors, there's a quick recovery mode too. And the best thing is it doesn't require any credit card or payment, so it's just free feature. So if you want to try it, just go on the website and start using it.
It's great, and it was released today or recently?
Yeah, it was already released. Yeah.
Great. Well, Hoshki, thank you so much for joining me here today. It was awesome presenting with you. Here's a QR code, like I promised. So go ahead and click on the QR code, and we'll set you up in the beta program. Hoshki and I will be here all day and even through the celebration. So if you want to talk about design systems, feel free to approach us. Thank you for listening.
Thank you. Cool, we have those.
All right. Thank you, speakers. That was amazing. So we do have a 30-minute refreshment break. Please take 30 minutes, just relax, reset, and come back at 4 o'clock. 4. Enjoy.
We did it. We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Ouch. Dang. Thumbs.
You know, there's an easier way to get thumbnails. Quickly grab a still from anywhere in your video with the Mux API. All it takes is some query params. Thumbnail.
What about GIFs?
What?
Not you, Jeff. GIFs.
I thought it was GIFs.
GIFs, GIFs, all the same to Mux with a simple GET request. Because video is fun with Mux.
Rabi Abdul Wahab, Managing Director of Engineering at City Tech. Anytime you join our company right now, or in the next 10 to 15 years or 20, you can actually create your own career path. There is a lot of growth and a lot of paths that can be created and still doesn't exist as positions right here. That's why I'm here. The curiosity of where can you go next with all the growth that we're seeing.
The future of this company is so bright. I'm so excited to be a part of it. I think when you join City Furniture, you're not here for a job. You're here for a career. And I absolutely foresee a future where this is my lifelong family.
8base is the fastest way to build innovative software and turn application ideas into seamless cross-platform experiences. Want to store relational data in the cloud, securely authenticate users, integrate multiple data sources, harness the power of GraphQL? 8base gives you all of that and more instantly, pre-configured on AWS and available through a single API endpoint. Need to conquer ambitious projects with a limited team? 8base gives normal developers the capability of back-end specialists and is DevOps free, allowing your team to confidently move at lightning speeds. Plan to support millions of concurrent users? 8base scales infinitely on top of a proven serverless cloud architecture. All of that is easily managed through a single intuitive web interface.
We did it. We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard.
Welcome, 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 welcome back. Welcome back. Everybody make your way into the audience. This is going to be a great session. We're going to be talking about ESLint and TypeScript from the author of the book. What? All right. So all the way from Philadelphia, we have a latte art making professional. Give it up to Josh.
Thank you. Thanks for having me. My God, those are bright. Woo. All right. Not enough enthusiasm, not enough people. So we're going to do two things. We're going to post a selfie to Twitter from my phone, and we're also going to do some noise-making thing. In that order. 3, 2, 1. Cheers! Woo! Awesome. Thank you so much. All right. Let's make some noise for ESLint. Yeah. Everyone's like, oh, I guess I'll cheer that library. Anyone here use TypeScript? Yeah. Woo! All right. Cool. All right. That's... I forgot the hashtag. Oh, well. Cool. So hi, everyone. We're going to be talking about setting up ESLint and TypeScript for React. I realized in the shower this morning that I should have named this talk, Don't Fear the Linter. I regret a lot of things in life, but that's OK. We're going to get a bit of a slow start because I hear people coming in. And I think it would be cool if we just shouted at them to join us. So I'm thinking we should all shout the phrase, Don't Fear the Linter, in like 3 seconds. 2, 1, don't fear the linter. Now they're confused and angry and going to come in. Awesome. Thank you. We need more lint rules. This is good. So I'm going to talk about 2 of our least favorite things today. First, I'm going to talk about this thing, the linter, the stuff that gives you the little squigglies in the editor that you all hate. And I'm going to talk about emotions, specifically fear, uncertainty, and doubt. Fear. I have red editor squigglies. Oh no. Something's broken. Uncertainty. I don't know why it's angry at me, and I haven't read the docs to find out. And doubts. I know my code works. The linter is stupid and wrong. I'm just going to ignore it. No. No. No more of that. Don't fud it up. Instead, we are going to do static analysis. Yes! Static analysis. Love and confidence and appreciation for all this stuff. Are y'all ready for this? Woo! Kathleen's moving to the front row to heckle me. Okay, great. Static analysis. Why so squiggly? Static analysis is this term I keep using. You might have heard it. It is tooling that scrutinizes your code without running it, which is in contrast to dynamic analysis, tooling that scrutinizes the result of running your code. Dynamic analysis is like testing. On the one hand, you have little unit tests all the way up to big end-to-end tests. And static analysis also has a spectrum like that. On the one hand, the left, we have speedy tools, all the way up to the slower but more powerful tools on the right. The speedy tool you might be using is like a formatter. Anyone here use Prettier? Yeah? Is anyone here the creator of Prettier? Is he in the room? Never mind, not well. And then we can get all the way up to type checkers, like y'all already cheered for, TypeScript or Flow, if that's still around. And in the middle, we have the thing that I play with, linters, stuff that is a little faster than a type checker, but is not quite as fast as a formatter. So we're going to go in and explore the difference between these 3 tools and how we can combine them together and keep them separated to work efficiently. Are y'all ready to dive in? Yes. Cool. Yay. Thanks. So we're going to go in order. First, what is a formatter? And yes, this is the thing where you can all chuckle about tabs versus spaces, Silicon Valley jokes. A formatter is a tool that reads in your source code and auto-formats it for you or complains about you not having done the right formatting. That's all it does. That's all a formatter should do, which is awesome. And I'll give you an example. This is valid JavaScript. It's very ugly. It's friend equals friend or me. If you were to pass this to a formatter such as Prettier, it might get auto-formatted to something like this, friend equals friend or me, but on the same line with correct spacing, maybe a semicolon if that's your deal. That's good. This is nice. And we like formatters, right? Because they do the work for us. They mean that we don't have to manually edit the tabs and/or spaces. We don't have to futz around with the new lines. They do it for us quickly. Yay. Now, on the inside, a formatter works by converting your code to a format called AST, or Abstract Syntax Tree. This is a simplified version of that. And we're not going to need to memorize this. I'm not going to quiz you on what's an assignment expression or logical expression, whatever. But I want you to see that on the inside, this is how all the tools I'm going to talk about generally represent your code, give or take. We have type assignment expression, where the expression has left friend, operator equals, and right friend or me. This is what I work with every day, and now you're going to suffer with me. So that AST, again defining it, it's the format that static analysis tools read your source code into. And again, showing it, that's this thing. That's really cool and really useful. And I'm not going to dive too deep into it, but I want you to know that if you ever see a tool documentation thing online that mentions an AST, you don't have to be scared. You don't have to fear the linter. You don't have to FUD it up. It's just talking about how these tools think about your code. But what you really care about is the npm install commands. This is an example of just the very bare bones basic way of setting up Prettier. Has anyone done this exact set of scripts before? Just curious. Yeah, a few people, yeah, you've done this. All right, you've installed Prettier as a dev dependency. I see my hyphens got combined together, thanks PowerPoint. And then you've done like npx Prettier dot, so the current directory dash right, something like that. That's reasonable. Okay, there we go. Now, if you don't want to memorize that, I have all this stuff, all the things I'm going to go over today, available for you in this template TypeScript node package. And I really encourage you to use this or some other template that gives you auto-formatting, linting, and so on out of the box. Because we're going to go through exhaustively how to set up ESLint and TypeScript for React, as you might have guessed we will. And it's all reasonable stuff. No config file we see will be more than a dozen lines, but it's nice to have it done for you. And also, this means you don't have to like jot notes down or take pictures of the code slides. You can just copy them from there. Hooray! And I have a few more pro tips. One, use the VS Code or equivalent editor extension for Prettier. You can, in your repo, set VS Code /extensions.json, and then have a recommendation so that if someone new opens the repo, they'll be told, hey, you might want to install the Prettier extension. And then you can set your default formatter in VS Code to that Prettier extension and say that you can auto-format on save, which a lot of people don't do. And I see people manually typing in spaces to satisfy Prettier like it's 2005 or something. Ridiculous. So you can do it for you. Have it do it for you. Woo. I do this for accessibility because I'm told that people who use screen readers or other assistive technology such as that like tabs. But just fun fact, if you have any preferences, you can throw them in a .prettierrc.json file. Anyone gonna boo me or cheer me or yeah, whatever, shut up. Okay, we're clean. Yeah, accessibility, thank you. That's it, that's all that I'm gonna go over for formatting, specifically on how to format it. We're done, good. Let's actually talk about a linter though. That's the thing that really excites me. And no, we did not just cover a linter. A linter is not a formatter, more on that later. A linter is a tool that runs a set of checks on your source code. It runs a set of checks, things that actually look at the logic of your code and yell at you about it. And each of those checks is a discrete rule. A rule is a set of things that the code looks for, and it may optionally complain on if it sees your file violates it. And each of those complaints may optionally provide a way to fix for that rule. Each of those rules is discrete. It doesn't know about each other. So let's take a look at an example rule. Fun fact, the code I showed you earlier, friend equals friend or me, is actually not the cleanest way to represent that thing. If you had the ESLint rule, logical assignment operators, set to error rather than warn or off, those are the three options for ESLint rules, it would tell you, aha, you loser, that's just my internal monologue, you friend, assignment equals can be replaced with operator assignment. And then it would, in your editor, if you want, autofix it to friend or equals me. Did anyone know about this syntax? No? Look at that. That's so much cleaner. I like it. So smart. Look at you. Good stuff. So if you want these beautiful things done for you, you can npm install ESLint. My hyphen was correct this time. Say dev. You can npm init at ESLint/config, and that'll walk you through setting up an ESLint config. And then you can do npx ESLint dot. Now, fun fact about that dot. you've probably maybe seen it in tools and been like, why is there a dot in my bash script? Dot refers to the current directory. Thank you for nodding. I'm excited some people know this. So dot says to ESLint, I am providing you the path of a directory because that's what ESLint takes in, a list of files and or directory globs. So I'm just saying do the current directory, everything. Lint all my stuff. Now, if you don't want to go through the ESLint init, or if you just want to see how these things work from scratch, the first important part of an ESLint config I recommend is extending ESLint:recommended, which is the list of rules that the ESLint team has, through literally years of scrutinizing code, come to understand to be the things that most code bases probably want. So if you really want to configure rules, you can add a rules object, but like most of the time, you don't need to do this to start. Eventually, you may find that rules are not applicable to your code base, and you might want to set them to off, and that's okay. And I just want to emphasize this. It's okay to disable a lint rule in your code base. I've seen a lot of people say phrases like, I can't possibly deploy this code. The linter is yelling at me. No, just disable the rule and move on with your life. Amen. Now, if you want to get things set up for React, it is a little bit more complicated. There are two good ESLint plugins, so NPM packages that give you more lint rules that look at new and unique things. There's a nice little ESLint plugin for React, and then there's an additional one for React hooks, because back in the day, the hooks were not a part of React, or they were new. And also, fun fact, JSX is not natively JavaScript. Who knows if it ever will be. So you do need to configure the ESLint parser to understand JSX. By default, it says, no, that's not real. And then also, the plugins need to be enabled explicitly. You need to tell ESLint which plugins you're going to use so it can load them in. Lastly, those plugins, the React one, wants to know what React version you're using. It behaves a little differently in older React versions, so just tell it settings React version detect. Just look at my package.json. And this is why a lot of people hate ESLint, because I just had to spend like a minute going over the lines. So again, please, copy and paste from a template. Don't feel the need to do this all yourself if you don't have the time. All right, so if you want to run that, you can do ESLint.npx ESLint. I recommend a couple little extra flags. One is report unused disable directives. Who here knows what a disable directive in ESLint is? Awesome, like as few people as possible is my preference. A disable directive is that little thing. It says, ESLint, you might complain on the next line, shut up about it. Don't yell at me about no console. Hi. Now, if you end up changing the line to like something that doesn't violate the rule, ESLint won't normally yell at you saying this ESLint disable is unnecessary. But if you enable report unused disable directives, then it will yell at you. Because why would you want to keep these comments around? These comments are ugly. I don't like that. So yeah, definitely recommend enabling that thing so you don't get the other thing. Also, fun fact, you can run ESLint with a --fix command, so it'll auto-fix all the things that are wrong in your code base. Now, not all rules are auto-fixable, but most of the recommended ones, if possible, have a fixer. So that's useful. Fun fact, I added the ability to --fix report unused disable directives. I'm very proud of that. My little ESLint contribution. Yay, open source, woo! Awesome, all right. And then one more thing is max warning 0. Because rules can be configured with one of 3 severities: off, warn, error. A warning is still going to yell at you, but it won't fail the build. It won't cause ESLint to exit with status code non-zero, which means that people will just be trained to ignore the warnings, to ignore ESLint, and we don't like that. So if possible, max warning 0 is good. Okay, and similar to Prettier, you can add a recommendation for installing ESLint in your repo. And you can also say in your code actions on save, source fix all ESLint, which enables fixing all your shenanigans that are wrong on save. So that's nice. I like this. This is how I do ESLint. And I've worked on some linter things, so you should probably at least put that opinion into consideration. Clean, good. I don't have like a nice, clever segue for this. I just think it's cute. Okay. One more important thing about ESLint, and I want you to say it with me. 3, 2, 1. Stop using ESLint for formatting. Thank you. That was good. Stop using ESLint for formatting. That's not what it's for. Matting. This rule indents. The other rules, max lens, semi, whatever, they're evil. They are bad. Don't use ESLint for formatting. Please, for the love of all that is good. I have 13 minutes left, and 12 of them are just going to be me repeating the phrase. No. So there's not the same stuff going on. A linter is not a formatter. A formatter is a tool that reformats all in one pass. It's real fast. It's real clever. It's real nice. Props to the creator of Prettier at this conference. A linter runs a set of individual discrete rules that look at the logic of your code, which means it can actually handle discrete rules, individual pieces of logic that can be turned off and configured. But it's slower, and it has explicit logic for every edge case because it cares about those edge cases. So all the lint rules that do things like configure your indentation levels are incredibly buggy. We have a pinned issue on the TypeScript ESLint repo. I'll explain what that is later. Explaining to people why our indent rule is broken and we're not going to fix it. Do it yourself, because we don't have the time for that crap. So this is us. Do not enable formatting rules, and especially don't ask us to fix them, because they're not what a linter is for. Fundamentally, a linter is not for formatting. It's for linting, and a formatter is for formatting. I've already bored you. I'm moving on. Let's talk about something much more exciting, TypeScript. Who here uses TypeScript and loves it? Woo! Yes, buy my book. TypeScript, for those who did not raise your hand, that's reasonable too, if you haven't discovered it. It's a superset of JavaScript. That phrase means nothing to most people. JavaScript with types, otherwise known as, JavaScript describes only your code's values. You can say like, let my value. But there's no standard way built into the JavaScript language yet to describe the types of your values, the intent behind them. I intend for this variable to only ever be a number. Oh, okay. That's what TypeScript gives you, along with a few other things. Yay, prettier. TypeScript is 4 things. TypeScript is a programming language that describes the existing JavaScript syntax, plus a bunch of new things for types, like that colon number we saw. That's just the idea of TypeScript, the vibe, the aesthetic. TypeScript also provides a type checker, which is a program that reads in your files and reports if you have like a likely issue. Like, oh, you said this will be a number, then you gave it a string, you're probably wrong. Go fix it. That's a program. On top of the type checker, we have the compiler, TSC, TypeScript compiler, that runs the type checker and also transpiles your code from the TypeScript syntax to the equivalent JavaScript or other things. And then lastly, we have the language service, which is the program that runs the type checker and or compiler inside an editor or IDE, such as VS Code. And this is a very important distinction, the delineation between these 4 things, because people get confused sometimes about what TypeScript is. It is all 4 of these, confusingly. Now, this is an example of why you might want TypeScript with React. Here we have a MyButton component. It's fine if you don't scrutinize this code too closely. There's probably a bug somewhere. And without TypeScript, there's really no way for us to know whether this break the internet component that renders MyButton is correct. Truly no way. Maybe that first thing, MyButton, is intended to be okay. OnClick equals nothing. Probably not, because why would you have a button that doesn't have an OnClick? I don't know if that's an accessibility issue. It's surely a usability one. Providing a string as OnClick is probably wrong. Actually, this third one is probably fine, but you had to read the code to know that. And then that last one, it's not OnClick or OnTap. It's one of them. TypeScript lets us know when these things are wrong. So if we were to change it from button.js to button.tsx, TypeScript would yell at us saying OnClick is missing. You said it should be there. Or you said OnTap instead of OnClick. OK. Now, I will note in your TS configs, this is a configuration talk, that if you set compiler options.jsx to something, that is what lets TypeScript read in your JSX syntax. It won't natively. So if you're setting up a new TypeScript project and it doesn't understand your JSX code, do that thing. Now, there's also another thing called no implicit any. I'm expecting slightly less enthusiasm. Who here's enabled no implicit any? Yay, cool. By default, there's no way for TypeScript to know what the type of onClick is. It doesn't know if it's like a function or undefined or function with a particular parameter, whatever. So the no implicit any compiler option, which is disabled by default, unfortunately, is the thing that tells TypeScript to yell at us if it can't tell what type stuff is. So if we were to enable no implicit any, it would yell at onClick. And then if we were to do the right thing, which is like declare a props interface or type and say what onClick is, then it would know to yell at us about the onClick equals wat. Because finally, TypeScript knows wat is not a function. Yay, TypeScript. Cool. So if you want to get started with TypeScript, similar to before, install it, save dev, npx tsc --init will give you like the nice default starter ts config, and then you can run the TypeScript compiler tsc. Now, if you want to go through from scratch, these are the 4 really nice compiler options for React I recommend. JSX, I'm not going to go into the different ways that code will handle JSX syntax, if it should output that syntax or the equivalent React.create element or whatever. Module ESNext, so that TypeScript understands you're working in ESNext, and if it outputs code, it should use JavaScript modules, not CommaJS. Strict true is an awesome compiler flag that enables no implicit any and others. Yeah. Thank you. And now target is an often confused one. When TypeScript wants to know what APIs are available, it has to be told what version of JavaScript you're using, because the APIs available in like Chrome 9001 are not the same as Internet Explorer -3. So target ES 2021 tells TypeScript, I will make available the APIs that are existing in ES 2021, that edition of JavaScript. All reasonable stuff so far, right? Let's make it more complicated. All right, so a few more compiler options, optional but good. ES module interop tells TypeScript to not be so nitpicky about checking whether you're import defaulting or whatever, like the way modules import. Force consistent casing in file names is a mouthful, but it does what you would think. If you have an import with the wrong casing, upper versus lower, it'll yell at you. Skip libcheck is a really cool little optimization. By default, TypeScript will type check your node modules. It'll let you know if there's a type error in your node modules, which is like a total waste of time for most projects. So this tells it to shut up about it and skip. Yay. Awesome. Now, ignore everything I just said. Frameworks will write the TS config for you. Next, Remix, Astro, they all do this for you. So as long as they are setting strict true and you're not turning it off, yes, good. Now, if you ever want to learn more, aka.ms/tsconfig. aka.ms is like the Microsoft Bitly because they didn't want to pay for Bitly, so they built it themselves. Also, it's like a really cute URL. This has all the compiler options documentation you could possibly want. Also, buy my book, I go over it. Now, again, not the same between two types of tools. TypeScript is not a linter. Don't say that TypeScript is linting your code. Don't say that ESLint is type checking your code. They're not the same. A linter is a thing that runs a set of discretely configurable rules, which makes it faster, but it only sees one file at a time. It's just looking at your syntax. Whereas TypeScript is looking not just at your syntax, but the types, understanding your program as a whole, kumbaya, which makes it much smarter, but much slower. Which brings up an interesting issue because I thought linters are awesome, but TypeScript is so much smarter than them. Oh no, I skipped slides. I'm sorry. I forgot about this one. So little pro tips about TypeScript. If you're running them with ESLint, ESLint.rules.customizations is a thing I added to the VS Code plugin for ESLint. I highly recommend setting your ESLint errors to all be listed as warnings in VS Code, even though they block the build as errors, because it's really confusing when both ESLint and TypeScript give you the same color squiggly, and you have like 3 errors from something not being undefined. This way, you can ambiguate or disambiguate. Red is TypeScript, yellow is VS Code's ESLint plugin. Who would have thought? And then also, TypeScript.tsdk tells TypeScript in VS Code to use your specific project's version because it might be different from your global installed VS Code version. Cool? Cool. Yeah. Awesome. Okay, cool. There we go. This is what I was starting on. Sorry. So TypeScript ESLint is the project that I work on that enables you to run ESLint code on TypeScript stuff. Now, this is because similar to JSX, TypeScript syntax is not JavaScript syntax. It's not the same. So we provide 2 major things, among others. We provide a parser, which tells ESLint how to read TypeScript syntax. And we provide an ESLint plugin, which is a bunch of ESLint rules, like that React one. So if you want to enable us, you can extend from our recommended rules, highly recommend, and then also use parser TypeScript ESLint parser. I'm going to speed up now because I'm slowly going over time. So just as an example, there's a fun little TypeScript syntax thing where if you have literal as literal, you can replace that, as this prefer as const rule would tell you, with as const, which is like a nice little syntax shortcut. So smart, look at you, good. But if only there was some way to use type information in our rules, because the linter doesn't understand type information. And if we did have type info, then we would have like this new 3rd category with like a type checked linter type thing. And that's why TypeScript ESLint is awesome, because we have a new category of lint rules, a new way to scream angrily about your code base. The list of lint rules we have includes a bunch of them that use type information. Without type info, there's no way for JavaScript linters to know that console.log does not return a venable, a promise. But our lint rule would yell at you and say, hey, you don't need to await that. That does nothing. It just makes your code a little slower. and it would auto-fix it for you to just console.log lat. Awesome. So just as a little bit more complex of an example to show that linters can actually find some pretty severe stuff in your code, here we have a button component that says running is a Boolean state. On click, we disable the button by setting that running state, await on click, and set running false. But similar to before, on click is a function that returns void. We don't need to await it. So if we were to use a linter, we'd get the complaints. And one way to fix it would be to change the types to say that it returns promise void. Or if we know it never returns promise void, we could just remove the awaits, which then would let us know that this state is like totally unnecessary. Like it's always going to be false. It's synchronously changing. So we could remove that, which then means the function can be removed, which means the state can be removed, which means the button is always disabled, which means using TypeScript ESLint, we just removed 1/3 of our code base. Yes! Dead code removed. Dead code is bad. Performance. Good. Okay. So I highly recommend, if you are in a TypeScript code base, don't only enable our recommended rules, enable recommended requiring type checking, and set parser options.project to true, which tells our tooling, the TypeScript ESLint tooling, to use your closest TS config to each file to generate type info for the file. And then all those awesome type check rules will start screaming at you. Yes, scream, punish me. Good. Awesome. And then this is, we can gloss over this. This is the combination of the React configuration with TypeScript ESLint. Again, this is stuff you can find online. Tweet at me if it's not available. Cool. So again, you can find all this stuff online. I have a nice repo set up, linting TypeScript in 2023, that has like 3 even better examples of TypeScript ESLint finding issues and a little demo app. Awesome. So let's recap. We talked about static analysis. Don't FUD it up. Don't fear the linter. So proud of that one. We talked about what a formatter is. It just formats your code. We talked about what a linter is, a discrete set of rules. Stop using ESLint for formatting. Yeah. We talked about TypeScript and then adding TypeScript to ESLint. Very exciting stuff. If you want to get started with these things, if you haven't yet, no shame. It's OK. All these things have great SEO, so you can Google them or use these URLs. Good stuff. Also, I have a few recommended, really quick, simple next steps. Just try these out. 1, check your formatter configuration. See if it's super customized and weird. Make sure you're not using ESLint for formatting. 2, check your linters. See if you're enabling TypeScript ESLint's config. Make sure your editor is using like smart settings, like the things I recommended. And if you happen to maintain a large framework, such as a full-stack React.js application framework that's used by like thousands upon thousands of developers, make sure that your recommended ESLint config does extend from the aforementioned library author recommended configs. OK, also, please support us because we are an independent open source project and we have a current budget of about $30,000 each year, which is split across like 5 or 6 devs. We have an open collective. I work on that full time. I'm also a Microsoft MVP. I don't know what that means, but it seems to be good. I wrote a book on TypeScript, Learning TypeScript. Yay, it's a good book, I think. And then also I'm an independent open source maintainer myself. And I can only do the thing that I'm currently doing, evangelizing the tools, and then also working on them, thanks to sponsors on GitHub and similar. So please support me. Thank you very much. Have a great day. Nothing.
Woo! That was a lot. Very awesome. Okay, so our next speaker is trapped in the metaverse. Unfortunately, she is not physically here with us, but she is here on Discord. So everybody, open up the React Miami Discord so we can talk to our speaker. At the same time, we'll have her presentation on usability testing streamed. So you can interact with her, ask questions while we actually watch her deliver the talk. That's kind of cool, right? Cool session. Catherine is a developer advocate at Progress. And yeah, please sign up. It's on the Discord link is on Twitter, hashtag React Miami. And so if you haven't signed up already, join the Discord link and we'll get the video rolling.
Hey there, I'm Catherine Grayson Nance, a developer advocate at Progress Software. I was so excited to get to be in Miami with all of you again this year, but unfortunately, COVID had other plans for me. So I am coming to you virtually, and I'll be in the Discord if you have any questions at all. And in the meantime, know that I am experiencing major FOMO and jealousy for all of you that are together in Miami right now. So all that being said, let's go ahead and get into it. Ask nearly anyone about the process of developing software, and somewhere in the answer, they will hopefully mention the users. User research, user testing, user feedback. The end user is at the heart of everything that we build. However, for many companies, making that conversation with real users actually happen can be a challenge. And when this occurs, we often assume there's a lack of understanding about the importance of user testing and that the problem we need to solve is getting buy-in. While this can occasionally be the case, I have more often found that there's already a strong understanding of how valuable the feedback would be, but the struggle is with organization or resources. It's much more common for me to hear things like, yeah, we would love to do that, but we really just don't have any budget for it right now. People want the chance to sit down with users, but they're not really sure how to make it happen. And because it's not a requirement in order to ship, it gets continually bumped in favor of more urgent tasks. This usually happens in situations where there hasn't been a strong history of design process, or where there's very few or no UX professionals on the team who can really own the task. So if this is all starting to sound very familiar to you, then I have a recommendation. Do it yourself. In an ideal world, yes, this would be the responsibility of a UX designer or a researcher, but for many teams, for various reasons, that situation just isn't a reality. And in this talk, I don't want to discuss that ideal, big budget, perfect world scenario. There are tons of resources out there that already exist for that. I want to talk about how we can still make usability testing possible for startups, for small companies, or for your personal side project that might not have a lot of money or resources or people that you can dedicate to this work. So no matter what your situation is, I am here to assure you that running basic usability tests is something you are completely capable of, and it comes with the bonus of making you a better developer as well. The first major hurdle that we'll need to address before we can even consider anything else is figuring out what we want to test. And no, the whole app is not an option. Usability testing is most effective when it's focused on testing a specific flow, task, or feature. So take a moment and consider what questions you want to be answered about your app. Have you noticed some more support tickets coming in lately? Is there a place where you're not getting the interactions that you anticipated? Have you been getting some negative feedback? Or maybe you're ready to launch something totally new. These are all great jumping off points. You want to choose a specific task or a chain of related tasks that will take the user through the part of the application that you want to test. This flow should have a clear starting and ending point. The ending points don't have to necessarily be the same for every single user, but you should clearly know when a user has satisfied the task requirement. Some examples of flows you could test are onboarding, search and save, exporting an asset, updating a user profile, etc. You want a task that a user can complete in one sitting. There are two main types of tests that you can run. In one option, you'll watch the user move through an established flow totally unguided. The second option is to walk the user through a new flow in a way that's kind of semi-guided. And in both situations, you'll have a chance to see user pain points, misunderstandings, places where your assumptions as a developer diverge from the reality of the user behavior. In the established flow situation, you might say something like, walk me through your process for printing John Doe's time tracking report. Then you'll sit back and observe, Let the user narrate and show the way that they complete the task without any interference. It's super interesting because that kind of shows us these quote-unquote desire paths, things that your users need to do for their specific use case that haven't necessarily been built into your app, and all of the loopholes and shortcuts and hacks that they are using to make that thing happen for them anyway. In the new flow situation, on the other hand, there's a little bit more back and forth. And that might sound something like, show me how you would look up flights departing from the Asheville airport on June 1st. Awesome. Can you now talk me through your thought process for how you would choose a flight? Okay, cool. Now, what would you do to book that flight? So in this situation, you're walking the user specifically through each step of the task that you want them to complete, and you're kind of asking questions along the way. This is ideal for testing new features or working with people who have never seen your software before. And it's great because it allows you to see your application through totally fresh eyes. Once you have an idea of what you want to test, then it's time to find some test subjects. Most of the time, you'll want a mix of established users and people who have never seen your app before. But ultimately, that depends on what you're testing. An advanced search feature targeted at super users with vast amounts of data saved, you could probably skip new user testing for that. Whereas an onboarding flow, skip the established users. A new UI design theme, you'll want to mix. In the ideal scenario, obviously, you have budget to throw at this. You can just hire someone to get you that perfect mix of users all lined up for you, all ages and genders and experience levels and abilities. But in this realistic scenario, maybe you have a very limited budget or no budget at all. You can still do this, but it is going to take a little bit more work. Reaching out to your sales and support folks is an excellent place to start for finding established users to test with. Both of those teams can often quickly come up with a handful of potential candidates based on their personal interactions with your users. These tests can often be organized quickly because you already have a pool to draw from, you already have the demographic information, you have an established point of contact, and you know that these users have a vested interest in your brand and your application because they already use it. This is a wonderful place to start, but you really don't want to stop there. To cast a wider net with your established users, try posting open calls on social media or adding banners or modals to your website. Often it can help to kind of sweeten the pot by offering something in exchange. That doesn't have to be money, although it can be, but it could also be things like free trials or discounted rates or company swag. All of those can be really powerful motivators that don't require you to cut a check. And after all, you probably have a closet full of t-shirts and stickers that you've been meaning to clean out anyway, right? So win-win. New users can be a little more challenging because they do absolutely require motivation to participate in something that they otherwise have pretty much no investment in. Those free options can still work here, the trials, the discounts, the t-shirts, so always give it a shot. Friends and family members can be good options here too. You just have to make sure that you're not the one who ends up running the test for your own mom. If you have even a small budget though, something like $20 gift cards or free catered lunch can do a lot to entice participants. So even if you only have $100, that can still probably get you a handful of folks willing to do a usability test for you. If you have a more moderate budget, investing in a third-party service like a panel agency or a market research recruiter can be super, super valuable here because those folks will help you connect with specific subsets of user types, which means you will get better, more accurate results that more fully reflect your user base. If that's not an option, you can still try to connect with these user groups on your own by reaching out to the places like community centers or organizations that cater to those groups. Often if that's accompanied by a gift of like volunteer hours or public promotion of their cause, that can help as well without needing to spend. Promoted posts and ads on social media sites are also pretty reasonable in terms of cost, and a lot of those will allow you to target really specific demographics that you might otherwise struggle to reach. Ultimately, you want to try and achieve as diverse a group as possible. So consider age, race, gender, disability, orientation, identity, and experience level as you're gathering these users. But also, I do want to say, remember, perfect can be the enemy of good, and any user testing that you're doing is better than none. When you're working with limited resources, the ideal might not be possible for you yet. The long-term goal here is to establish a valuable usability testing program that shows results, so that more money and time and resources can be allocated to this down the road when they become available. I want you to think of this as just step one. When your testing group isn't diverse, you do have to take the results with a grain of salt, and remember that this might not be reflective of the community. The data is still useful, the conversations are still informative, and the process is still absolutely worth doing. But the results should not be held up as objective truth. While you're reaching out to gauge interest and get those potential candidates locked in for testing, it's time to start nailing down the logistics of the test itself. This is the part where folks often get hung up, because there's a lot of details you might not have considered if you've never done this before. So let's break it down. Ideally, you will want at least 2 people present to run the tests. They don't need to have ever done this before, you just need someone who can be polite and comfortable speaking with users. It's great to have multiple testers so that the workload of proctoring the tests can be divided. When only one person is actually administering the tests, it's a lot of work, and that can really slow down the scheduling. In addition to the person who is giving the test, you likely also want a second silent observer to be present during testing. This person will not participate beyond just watching and taking notes, but that allows the proctor to focus entirely on the user. If you're able to take a video or a screen recording, you can maybe skip that, but it's still really nice to have a second person there to kind of break the session down with afterwards and kind of compare your impressions. If you choose to record the session, that could be as simple and cheap as a microphone and a webcam in the testing room, or it could be as relatively complex as heat mapping or cursor tracking software that gets installed on the testing machine. No matter what you choose, any recording methods need to be disclosed to the user, and their acknowledgement and agreement must be gained before the test can begin. You'll also need to think about how the test is being administered, whether that's in person or remote. Both of these have pros and cons, so there's not necessarily a right answer. An in-person test has the benefit of allowing really close observation of the user, which will allow you to pick up on things like body language or facial expressions that could get lost on camera. It can feel more conversational and more relaxed to test in person. And that also allows you to provide the computer or the device for testing, which gives you a little bit more control and helps eliminate the variables of personal user device configurations. On the flip side, it means you do need a physical space to test in. And if your team works remotely or your office isn't nearby or easily accessible, that can be a challenge. Consider reserving a meeting room at your local library, which is usually free or donation-based, or maybe at a local co-working space, which is usually pretty affordable. In-person testing also means, though, that your users might not have access to their usual assistive devices, so keep in mind that that could limit your accessibility testing. A remote test, on the other hand, has the benefit of flexibility. This allows you to reach more users at times that are more convenient to them, which can help you find more people to test with. It also gives you the benefit of testing in the environment where the user is most likely to be actually using your software, and on the device that they'll be using in real-world situations. However, remote testing also comes with communication and technology challenges. It can sometimes be more difficult to get permission from users to record, especially if they're using work-supplied devices or they're calling in from their corporate office. And if your feature hasn't actually launched yet, then you'll need to figure out the technical aspect of getting the user access. Regardless of which approach you choose, there are some logistics that are universal. If you're planning to run tests during standard work hours, remember, that's a big ask, making users take time away from their job and possibly commute out to you in the middle of the workday. If you're running tests outside of standard work hours, consider the need for childcare. All of these choices could unintentionally bias your results if you don't consider them. When you run tests during the workday at a location that's not easily accessible via public transit, then you're kind of automatically restricting your testing audience to only people who have cars and can easily take time off. If you bring users into your office and you run your tests on a fast desktop computer with a large screen monitor, maybe you're not getting accurate data for an app that's going to be primarily used on tablets by users in a warehouse. So consider the goals of your test and choose a configuration that's going to make the most sense for your needs. After that, after all that, it's time to actually run the test. This part is easier than you'd think. I like to write up an outline so that I have something to reference and make sure that I'm not forgetting anything as I run through all of these steps with the user. You'll start by introducing yourself and thanking the user for their time. If you're offering any kind of compensation or gift, explain when that will be distributed. So like, you'll get the t-shirt and the sticker pack on your way out, or we'll email you the code for your free 2-month subscription. Then you're going to talk them through the goal of the testing. So today we're going to test a new feature in the app, or today you're going to look at a piece of software that you've never seen before. It is crucial to assure the user that this is not testing their personal ability in any way, that there are no wrong answers, and that the only thing being tested here is the software itself. Emphasize that you want their honest feedback even or especially when it's negative. Reassure them that they're not going to hurt anyone's feelings, they're not going to make anyone upset. This part is very important. Then let them know you won't be able to help or guide them while they're completing the tasks, that even if they ask, you really can't tell them the right answer. This can seem kind of mean, but it's really important for you to see how they would solve things without your guidance. Then you're going to ask them to think out loud as much as possible while completing the test. So you'll want to give an example, like, right now I'm looking for the search bar. There it is. Now I'm going to enter the name of my teammate, and you go on and on. And this feels silly and awkward at first. It just does, and that's totally okay. You can assure them that it will get more natural as they go, and that it's really, really important for you to be able to follow their train of thought as they move through the app. Finally, go ahead and open the floor to any questions from them. You want to take as long as needed in this section to ensure that they feel totally comfortable before moving on. This is also your chance to ask for their permission for anything that you need, like recordings, and to get any verbal or written consent. Once that's all good and you hit the record button and officially start the test, begin with some basic identifying questions that are going to give you context on this data for later. This usually includes things like their name, their age, how long they've been using the software, how long they've been in this industry, so on and so forth. Consider what aspects might impact the data that you're collecting, and as long as it's not too invasive, ask away. When it comes to the task itself, tell the user very clearly and simply what you want them to do. When they get stuck or hung up, which is almost inevitable, ask open-ended questions to help move things along. Don't guide the user towards a specific answer. Don't reach over, take the mouse. Don't give them hints. You just kind of want to say something general, like, what are you looking for on the page right now? Or what do you think will happen next? If they ask for your help, tell them to imagine that they're at home or they're on their own, and ask them what they would do in that situation. And if they really do get to the point where they tell you, like, I would just call support or I would file a ticket, if the test is like at a total standstill, you can prompt them in the right direction. But you really don't want them turning to you for the answer as soon as they feel a little adrift. Seeing how they work through the problem and what they think the answer will be is such valuable data. A little bit of silence is okay, but if it goes on too long, remember to prompt the user to think out loud. So something as simple as, what are you working on? Is usually going to do the trick there. And if a user expresses surprise or disbelief or frustration, one of the best ways you can respond is to ask, what did you expect to happen here? This will tell you about their assumptions and the ways that they have been conditioned to use software, which is, again, such valuable data. Once the task has been completed, ask any follow-up questions that you might have. this is a great opportunity to kind of widen your focus to the more high-level stuff. So their general impressions, their feelings, their emotions when they were using the software. It's also a chance to ask them to share any thoughts or feelings that you might not have asked about specifically. So usually I say something like, beyond what we've just discussed, do you have any observations or thoughts that you want to share? And of course, feel free to drill down as far as needed here to get the specific answers that you need. I also really like to ask the magic wand question here too, which is, if you had a magic wand and you could change any part of what you just experienced, what would it be? This tends to open the floor to like, oh, it would be so cool if I could like blah, blah, blah. And sometimes those are wild cards or things you would never do, but sometimes it's something really cool that you wouldn't have thought of otherwise. Finally, check to see if the user has any questions. If you're demoing a new feature, testing a new feature with them, they will almost always ask, when will this be available? So make sure that you have a good answer for that prepared in advance, and don't make any promises that you can't keep. It's also totally fair to say, we don't know yet, but we'll keep you posted, you know, and then thank them again, genuinely, for their time, and end the session. Of course, once you finish conducting the tests, you're not really done. You've got the data now, but for it to be useful for your team, you need to review it and start to form some conclusions. It can feel hard to know what to do with all of this data since so much of it is observational and not necessarily easy to just like throw in a spreadsheet. So here's my approach. First, I like to group the data by question or task. You asked all the users the same basic questions and you asked them to perform the same tasks. So that's a good starting point for dividing out the data into parsable chunks. Start by compiling the notes for each user as separated by question. Then you can start to look for patterns. This is where the puzzle kind of starts to come together, right? When multiple users take the same action or they all struggle in the same place. If multiple users follow the same flow without speaking to each other, that's a really strong indication of how your UI is being interpreted. And similarly, if they all fumble or they all make mistakes at the same point, that's a red flag. Then take a look at the numbers. Just because you don't necessarily have much hard data doesn't mean you don't have any. So check out your time to complete tasks. If you have any heat map data, take a look at clicks. See what the numbers have to say in correlation with the experiences that you witnessed. Finally, you're going to collect noteworthy quotes, findings, and data into a one-page document. Other people on your team, and maybe even other teams, are going to want to see the results of your test, but they're not going to read through the notes for every single user. So take your most impactful stuff and put it into a document for quick review and access. My main tip here is to not let one user's struggle or success overshadow the others. Don't rush to change things just because one person didn't understand it. Or, similarly, don't refuse to change things just because one person did it well. It's really easy to look for the users and tests that will confirm our own biases, but that's not actually helpful when it comes to building better software. True objectivity can be hard, which is why it's ideal to involve as many folks as possible in this testing process so that multiple interpretations of the data and the experiences can all be heard and kind of assimilated into your final findings. So that's not too scary, right? Like, yes, there's lots of parts, but they're all things that can be broken down into smaller, achievable steps and totally something you can do. I really hope you feel empowered and, dare I even say, excited to get out and talk to some users. You will be amazed at how watching a user navigate your app gives you a unique perspective as a developer, one that you will keep with you as you tackle future work and think about future features. It teaches you to resist that urge to make assumptions, and it really helps check your internal biases. Running usability tests is not just great for your software, it's also great for you. And I really hope that this session helps you feel excited and ready to go give it a shot. If you are looking for any of the resources, the slides, or a full transcript of this talk, you can find them at the links here. And of course, you can find me on Twitter at Catherine Grayson or on my website, kgrayson.com. Again, really wish that I was there with you guys. I hope you're all having a wonderful conference. Thank you guys so much.
Wow, this is different. We got 2 tables up here. What is going to happen now? That was a great talk by Kathleen. Definitely give her a shout out on Discord. I want to say our next set of speakers, we got a duo coming up. We're coming all the way from Australia. Please give it up to Selena Small and Michael Malinsky.
Oh.
10xing the programming skills without ChatGPT.
Okay, do you want to get off? Miami, hey! Oh, must be a new hire from HR. First time on stage?
Hey, I'm Selena.
Yeah, Selena. Yeah, they said a new hire was coming in today. But what's she doing here? Is she a designer? I'm Michael Malevsky, senior developer here at Aviator.
Well, I mean, it's nice to meet you, and I'm really excited to get started. Can you fill me in on how things work around here?
Well, I'm not sure about people like you who don't code, but the dev team, we've got an important stand-up.
What? Thinks I can't code. Oh, I'm a woman. Got it. It's probably why he thinks I'm a designer too. He's a bit up himself. Michael Mansplainsky over there. Suppose I shouldn't judge a book by its cover.
Ah, my story for today. To-do list delete item with Selena? Hang on, is this a joke? Oh, you're a developer. Whoa, gee. Well, come and join us here for stand-up.
Wow. Show me, do you want to tell me a bit of background on the story?
Oh, this is going to be some serious coding. This is not just some CSS, honey. Great point.
I didn't say anything.
Exactly. Let's keep it that way. Look, I think I'm even going to need Stack Overflow to work this one out.
Really? You guys use React, right? It sounds like we're just going to need a pretty simple callback function to respond to the delete action. But maybe we could start with a kickoff to get a bit of background.
Kickoff. You know, when Sam started, he wanted to make us more agile, change things up about our stand-up and give us story points and that kind of stuff. But I suppose somebody like you would need a kickoff. So we have to-do list and we need to do delete functionality.
Why do we need it?
To delete the to-dos. I think we kicked off.
Well, hold on. Why do we need to delete to-dos? Like, what's the purpose? What is the business value?
Whoa, you're going a bit above your pay grade there. All you need to know is that this is a React app and we have a list of item components and they need the ability for deletion. We're probably going to use a new callback function. You know, back in my day, we used to call them call after functions.
Don't you all just love a good splain? Any ladies out here, you love a good splain, right?
All right, I think we're done kicking off. Let's get started. All right, in the office. So there's the to-do app, and we have the code there. Oh yeah, over here you got the sidebar. That's all the files I've written, yeah. Oh, there's a failing test. Right, I think we should probably fix that first.
Okay, cool. We got a failing test. So it marks an item as complete.
You want to open the IDE?
Sure, we could read the test first.
Yeah, you could read it in the IDE.
All right, it's cool. We'll do it your way.
Yeah, app test.jsx.
So hold on, can I just have a look at the structure of the code base first, or?
Oh, of course, yeah.
Cool.
Make yourself at home, yep.
So we got the app here, and we got the test as well.
Yeah, I think line 41. Just throw a debugger in there. Let's see what's going on.
Debugger.
Yeah. Just open a new line. D, E, B.
Okay, cool, yep. Debugger, what are we trying to do here?
Whoa, I think I got it. Debugger, why would you do that? No way. Ah, right, it's an ordering problem. You got to get your 1, 2, 3s before your ABCs. That's how it's done, yeah. All right. That's some good pairing, cool. So we add and commit. All right, and just this way.
Okay. What is that? Is your camera on? What? What?
Lol commits, baby.
Wow.
If only you could type. Oh, if only it worked. There you go, yeah. You don't do those at the end of the commit?
What? Oh my God. Can you believe he was recording me? What a creep. I had no idea. Actually, I feel a little bit uncomfortable now. What else is he going to record?
Look, let's have a coffee. Yeah.
Wow.
How do you have your coffee?
Oh, black please, no sugar.
Yeah, there you go. Whenever anyone asks me how I have my coffee, I answer very, very seriously.
Cool.
It's only a joke. Come on, let's go. So.
All right. Cool. So how long have you been here at Aviato?
Whew, I was one of the first developers on this project.
Oh, so you're really across the whole code base.
Yeah, absolutely. Well, apart from John, who hired you, the CTO. Yeah, I've been here from the beginning.
Right, John. Yeah, he's known to be pretty big on TDD, right? So why was it that we started on this code with a broken text?
Whew, you seem to know a lot about this stuff. Why don't you jump on the keys when we get back then?
Okay, sounds great.
Ooh, Jane's phone left unlocked. You beauty.
Okay.
Yeah, so.
I thought I was standing on the left.
Oh. Let's write that test, hey? App.test.jsx, I think.
Okay, all right, because we're deleting to-dos, right? So what we want to do is we want to go into the editor, and we kind of have this like describe block when there's 2 items already. We got some code in here, and we're actually going to do something really similar to this. So if I just copy that.
No, don't do that.
Oh, okay. I won't do that. No, it's cool. It's cool. But to be honest, I think the scenario, like this whole describe block, is going to be something really, really, really similar. So
Cut and paste programming. No, wouldn't be doing that.
Okay. Do you know what? I'm going to go back to my first thought, because I'm very confident it's going to be something kind of like this. So in here, we're probably going to be able to just set up a new kind of context.
No, don't do that.
Look, can you just let me get my thought out?
Yeah, absolutely. Get on the keys.
Okay. So what it's going to do is it removes an item when remove item is called, right? And that's kind of like a standard function.
I mean, great try, right? Put your hands together. But let's actually get some code out here, right? So I think what you want, we just need another assertion. It removes an item when remove item. Sorry, is that, look, we can just comment, if that's annoying you, just comment that out, right? Remove item is called.
Like, isn't it kind of what I was trying to do?
Sorry if it's that. We'll just, and then we're gonna call this arrow function. You are across ES6, right? We're all over it. No TypeScript, but ES6. And then basically it's just going to do what was up here, right? And what we're going to do though is we're going to, I swear there was a remove item here before, but somebody put a space in there, idiot. So when we remove the 1, 2, 3s, they're going to disappear, and we're just going to have the ABC to do item. That's kind of what you want to do.
And so remove item, that's a function, right? What does that do?
Yep. Yeah. There you go. It's a remove. It's a prop, but it's a function. Yep. It's a remove item function. Removes the item.
Okay, but like, what does it do?
Removes the item. You're passing it an ID and it removes an item. You get it, right? You get it, right? It's a remove item function. You pass an ID and it removes the item. You get it, right?
No, okay. It's cool. That's what it does. It removes the item. It's all good. Anyway, maybe it'd be easier to see in a different font.
Different font. I used to work with a guy called Brad. He'd mix up the fonts every day and what? Why?
Oh my God, don't save that.
do
Don't say that.
Oh, thank God I can't. Yeah. Wow, look at that. Applied that. No, it's not working. Isn't that great? Right, you got fonts. So many fonts to choose from. Yeah. All right, because it's overwritten by that. Oh, we could overwrite that. Yeah, cool. Yeah, this is crazy. That's amazing.
Wow.
Imagine writing code like that. What were those web things? That is. Hey, Monaco, that was always a good one, wasn't it? Monaco. That's the color scheme. Now I'm really lost. Right, that's great.
I guess I asked for this, huh? Can we just run the test now?
Sorry?
Can we run the test?
I was enjoying resetting.
Michael, look at me.
Yep.
Can we just run the test?
Yeah, sure. Let's do it. So we've got that test, and if I jump back in here, failing test, this is how we TDD. So the remove item can't be called.
Oh, okay, cool. So can I write the code now?
Yeah.
Cool. So if I go over into the editor here.
Hey, check out that photo.
No way!
Yeah.
Who is that?
Yeah, I think that's P. Diddy's house. No, that's Shaquille O'Neal's house. Actually, his ex-wife's house now. Have you been there?
No.
Yeah. Woo! Still unlocked. Let's take a selfie.
Oh my God, that's so distracting.
Woo! Jenny's not going to be happy.
What?
That was Jenny's phone. She left it unlocked, and it's her birthday today. This is my phone, and actually, look, judging by the time, it's time for me to go for a run and grab a taco on the way back. Catch ya.
Oh, I can't believe I just lost it and threw that phone across the room. Wow. That's going to be an expensive replace, especially on Australian dollars. But seriously though, something is not right here. I took this job because this company was known to have a strong pairing culture. But we just can't seem to gel. It's like he doesn't even know how to pair. And he doesn't have any manners, slurping tea in my ear. And how easily was he distracted by all those fonts? Well, how lucky are we that we didn't save the web dings? And I thought pairing was meant to be about collaboration, right? But he won't let me see the screen. He's jumping through all the windows at lightning speed, and I have no idea what's going on. I don't think he even knows what's going on. And when I finally get my hands on the keyboard, he either tells me what to do or just rips it right out of my hands. And then he tries to take a selfie with me on someone else's phone. I don't know how this guy gets anything done. Speaking of getting things done, it's turning out to be a bloody long lunch.
Woo! Yeah! Hey, how you going?
Hey, what do you listen to when you go running?
Oh, I'm not like some people listening to music. I'm podcasting, learning all the time. Today I was listening to the Tastiest Treats JavaScript Jam podcast.
Really?
Yeah, with Alan. Alan?
Alan, who's Alan?
I mean, Scott Steinlager. Like the beer, right?
Steinlager?
Steinlager, okay, whichever. And Alan, who's going to sleep at the back. Wake up, Alan. Whew.
All right.
Where are we up to? Writing our test, right?
Well, we already wrote the test. Yep.
Cool, yep. Let's do it. Let's run it.
All right, cool.
Oh.
Let's jump into the terminal. Let's run that.
Wow. Yeah. Just run it. That's good. No, it's still failing.
Look, why don't we take a longer lunch break today?
No, it's all good. It was a pretty long run. Yeah, I think we should go. The clock is counting down. Let's just hammer it out.
No, look, let's take a longer lunch. You can go finish your lunch. We can get cleaned up, meet back here in 15.
No, come on, we've got to get our lines of code pumped out every single day.
I think a break would be good.
No, we're good to go. Got to meet the quota.
Look, to be honest, you eating is very distracting.
Oh.
And you dripping sweat all over me.
Right. Okay. Well, maybe, yeah, you're right. Let's take a quick lunch. I mean, a shower, right? I'll have that shower. Be back in a sec.
Hey, Jody, how's it going? Oh, yeah, first day's okay. Well, I mean, actually, you wouldn't believe the guy I have to code with. He must be the world's biggest keyboard hog. And honestly, you should hear this guy explaining callback functions to me. Ugh. Eh? Yeah, no, he's not my type. Like, he came back from his run, dripping sweat all over me, and Mr. Know-it-all's on the way back now to tell me how to hang up the phone. I better go. Hey, by the way, could you just check and see if my old job's still open? Just in case. Oh, awesome, legend. Thank you so much. Chat soon. Bye.
Whew. Oh, that taco was spicy. Look, I've had to think about it. Me coming here with tacos from my beard and dripping sweat on you, that must have probably made you feel really uncomfortable. Sorry about that.
Oh, wow. Thanks for acknowledging that. Should we try and write that test now?
Yep. Yeah, you go.
Okay, cool. So here we go. And
Yeah, okay. We're good. We're good to go.
Are you going to do your toenails next?
Toenails? There's a line, and I don't step over that line till RailsConf next week.
All right. So.
Woo! Did you see that notification?
No.
Cake
What?
time.
Oh my God. This guy is so hard to work with. There is a new distraction every 2 minutes, and he's disgusting. What kind of person cuts their nails at the pairing desk? This is actually based on real life. Yeah? Any of you? Any guilty culprits? No? Okay. Well, even when you're remote, you can hear the clippers through the mic, just FYI. But I'm in America, so I should channel some of that American positivity because he did apologize to me for sweating on me. So, winning! Yes! America! But still, he clearly has very little consideration for others. I bet he's one of those guys who lives in his mother's basement playing computer games and out watching girls fight on the weekend.
Ha! You girl got lucky, paired up with me today. I know more than anyone else about the code base. Well, apart from John, who hired her, gee, I don't even know if I'd pass the coding test anymore. And she certainly seems to know her stuff. Why am I having such a pissing contest with her? Maybe if I just back down, we could both work together and maybe I might even learn something. Hey, have some cake. Cake's fine. It actually reminds me of a birthday cake I had last Saturday when I picked up my son from his friend's birthday party.
Oh, you have a son? How old is he?
Yeah, I've got 4 kids.
4 kids? Wow, you must be a busy man. Guess you don't fit in much time for coding and traveling around the world for conferences outside of work then.
Yeah, pretty busy, but, still managed to squeeze in a hobby project here or there and a conference.
Oh, really? Are you working on anything interesting at the moment?
Yeah, ABA.
ABA? Is that a framework?
No, ABA. It's the Australian Breastfeeding Association. They're a volunteer organisation. I'm helping them with the website.
Wow, that sounds great. I didn't expect that from you.
So you're having a pretty cruisy day, first day, huh? Paired up with me?
Yeah, it's been a little harder to get started than I thought it would be.
Whew. The architecture on this project is pretty evolved.
No, it's not that. It's just, you know, like even at a high level, doesn't seem like anyone can explain the purpose of what we're doing here.
Maybe I haven't made it as clear as I thought it was. Why don't we go over to the whiteboard and maybe just see if we can both get a better understanding before we start coding again?
All right, cool.
Yeah, just unlock with the down arrow.
Cool. What? Oh my God. There's girl fights on his computer. I knew it.
Well, it's not what you think. It's a good friend of mine. She's a professional kickboxer. I was just editing some videos. It's not.
Ah, okay. Well, that's pretty cool. She looks a bit badass.
Yeah.
She win?
Well, we can talk about that outside of work hours. Right. So maybe we should have started with this right at the beginning. So from the outside, we have an app, and yeah, my eyesight's just so shot. Well, right, and it renders a new item form and a list of items inside of it.
All right, and we want to be able to delete an item, so there's probably going to be a button on the item component.
Correct. However, it's the app component whose responsibility it is to tell the item list which items to render.
Ah, so we're going to need an add a function to the app component, which gets triggered when we click on the delete item.
Precisely.
And in order to call it, we'll have to pass a reference to the function down to the item component.
I think you're getting it now. Do you want to try some ping pong pairing?
Ping pong. I think we've had enough distractions.
Oh, no. Ping pong pairing is where one person writes the test and then the other person writes implementation and you switch back like ping pong.
Oh, okay. Yeah, no, that sounds like a good way to stay focused. Let's
Yeah.
give it a go.
Cool. All right. So let me just jump back into the test. We've got, hang on a second. I don't think you can even see the screen. Look, I've got a second keyboard and mouse, so maybe you could use those and we could angle that a little bit your way. So now both of us, assuming you can see the script, can both contribute equally to this, to writing code. Like we can both contribute now. This is great.
Oh, that's much better. Could we just up the font a little bit in the editor as well?
Yeah, we can. Do you want me to change it up as
No.
well? Oh, good call.
I think we're good.
Cool. So, as I mentioned, we've got that failing test, and it's written at the bottom here. Do you want to have a go at implementing it?
Yeah, cool. All right. So, I might just fix up that typo. So it removes an item when remove item is called. Sorry, I just can't help it. Removes an item when remove item is called. Great. Failing test because, well, there's no remove item to be called. So over in the app here, what we can do is we can have this list of items. We can pass down a remove item function. Remove item. Oh, and there's remove item. That's what it does.
Oh, I didn't actually let you see the implementation. Yeah, right. Yeah, much easier, isn't it, now to understand what it does?
Absolutely. Cool. So we've done that. If we run the test again.
Woo! Green.
Green test.
Yeah.
Nice. Don't give me a round of applause for being a woman and implementing that. If we now, is this the one?
Yeah.
If we come over here and even refresh the page and go React Miami is awesome. Well, not that we want to delete that, but we can't because there's no button.
No button.
So back over in the editor here, we're going to need a new test, right?
Test driving all the way.
Woo! So down in the item component here, we're going to do something kind of like this. So it calls a toggle complete when checkbox is checked. What we want to do instead is it calls a remove item.
Actually,
when
cutting and pasting really helps here, doesn't it?
It does. Thinking through my thoughts is good too. So it calls remove item. We're going to actually click a button here. So just say when the button is clicked, right? We're going to find a button. Oops. Click it, and we're going to expect the mock remove item method to be called. Jump into our terminal. Now we have a failing test. Ping pong, over to you.
Right, and just to always be very clear on what I'm doing by saying what I'm thinking, find button at 0, it has found no nodes, so it hasn't found the button. So what we need to do is first go into our item, where we render an input and some spans inside of that, and we're going to throw in a button, which should at least make that first part of the test pass. And now, as we can see, it's clicked something. It's just that the actual thing has not happened. So if we see that in the browser, we've got a button, but clicking it does nothing. And your test was then to tell us to go one bit forward, which was to actually on click call a function, which will be remove item with the ID. She's hoping I'm making a mistake. Woo! Yeah, green. Okay, so we can, oh, right, we should probably.
Should we check it?
Yeah, so now if I click that, deletes it, and React after party soon. Woo! Oh, clearly that's wrong, so we can delete that. Cool. Hey, I do this thing, lol commits. You don't mind if you jump in a shot and turn the camera on and have a bit of fun with a quick commit?
Yeah, let's do it.
All right, so add commit made in React Miami. All right.
Oh my God, amazing.
Woo. Just wait for the camera.
Oh, it's on. Yes. Oh, watering computers, no good time.
Yeah, no good, not a good time. All right. Lol. Yeah.
You got to work on that. Okay. We missed the best bit, but you know, there you go.
Whew, what a day. It's almost the end of the day. Look, how about we do a quick retro just to see what went well today?
Well, you know, I think that last piece of ping pong pairing was a huge success. We managed to smash out that feature in no time.
Yeah, I agree. And stepping back to draw it all up on a whiteboard really helped to get both of us on the same page.
There are a few things that didn't go so well, though.
Yeah, actually, when I think about it, yeah, one or two.
One or two distractions. I can think of a lot more than one or two. Can anyone here think of any distractions? What's your favorite one? Clipping the nails at the desk? Yeah, that was, yeah, absolutely. And switching up the fonts and, it was a nightmare.
Yeah. Well, maybe I should have left that clipping of the nails for home, but you seemed really unfocused when I came back from the run too.
Because you were dripping like sweat and taco all over me. I definitely think it was better, more productive to have a longer lunch in that case.
Well, it did work out for us in the end, but maybe next time we pair, if we had some sort of guidelines to help us get started, then we'd be more effective sooner.
Right. And the first thing probably be to sort out ergonomics. Once we both had equal access to the machine, it was much easier for both of us to contribute and get going.
Yeah, that's a great starting point. And another one might be just to eliminate all distractions right from the beginning.
Yep. And if we take regular breaks, then there's still plenty of opportunity for things like social media and tea breaks and snacks, personal hygiene, outside of pairing focus time.
Right. And lastly, regardless of how small or simple the work seems to be, talking through it and coming up with a plan is early means that we can both focus on coming up with the most improved, with the improved design and actually get the work done.
And most importantly, we have an opportunity to contribute our ideas, both of us, and absolutely
10x our pairing.
Totally practice that wrong.
All right, go.
Ready?
10x our pairing. Rasho! You don't need much to get started, but just to kind of quickly wrap up, you don't need much to get started, just a few simple guidelines and an open mind. We hope you've enjoyed our presentation. Give pairing a go. We've been Selena Small and Michael Malevsky. Thank you very much.
Okay, React Miami. Y'all made it through this long. Wow, give yourselves a round of applause. Come on now. This has been an amazing conference. We got one more speaker for you. Our last but not least speaker before we wrap up this conference. But I have to say, React Miami would not be an international event if we didn't bring international speakers. And so with us, we have someone who has over 10 years experience speaking at conferences. And so he's very casual and very open with you, but he has over 20 years experience coding. So this talk is really going to be about React as a developer tool's health. I'm really curious. Please give a warm welcome to Tejas Kumar.
Is my mic on? There we go. Hey, so I heard at a startup you wear many hats. I've got so many. Did y'all get a hat here? Some swag at the conference? Yes? Everybody responds with snores. Okay, we'll get through this quickly. Nice to see you. My screen's looking odd. I don't know why. Let's see if we can get this working. Hey, it's an honor to be here. Thanks for coming out. Thanks for sticking it through. Hello. Nice to see everybody. Why are there 2 tables here? I'm just going to give myself some room. Okay. See? Whole body. So, hi, I'm Tejas. It's as I mentioned, it's a pleasure to be here closing out the conference. My name is pronounced like advantageous. Whether or not I am advantageous, we'll find out by the end of the talk. But I'm here to talk to you today about React as a developer health tool. React as a developer health tool. Before I go further, I mean, it's the end of the day, and I feel like we owe it to the people involved to give them just a little bit of a round of applause. Can we do that? Yeah. I think of Michelle and Gabe, and even backstage there was Patrick who put who helped me come on stage. So give it up for Patrick backstage. Thank you. Manuel put the mic on me. That's a job, huh? So yeah, amazing people, and really this conference wouldn't be much without them. So React as a developer help tool. I don't know if y'all caught on, but the theme of this conference is absolutely React. And is absolutely developer health, which is a core value of G2I, the organizer. And I had the privilege of working at G2I for a little while, and it was honestly one of the best places I've ever worked in my life because they prioritize health like this. And I feel like this conference, React Miami, would be a bit remiss if it didn't talk about this. Talk about React as a tool that facilitates, helps, and improves, even with use effect, improves developer health. Okay. I would like to talk a little bit about where React came from and why it's helpful, and look at some challenges it faces today, and then look at inspiration from other developer tools that are now emerging that are following React's mission for developer health. So if you'll bear with me for a little bit today, I'd like to start by talking about React's intent. That is, why was React even created? And how many of you watched the documentary? Yeah, okay, that's about 75% of the room. This documentary made the case for that very clearly. And if you saw it, it shows you that we were doing things before that were very complex, ensuring UI updates in a way that is scalable at the scale of then Facebook, and in a way that is testable and reproducible is not easy. And there were a lot of developers losing a lot of sleep, ergo health, over that. The real mission, as it were, with something like React, with a UI abstraction, is enabling this use case of write once, deploy anywhere, be it the web with React or be it native with React Native. And just as a palate cleanser, as a refresher, as a wake me up, I'd love to kind of do a little bit of a demo to show us the kind of stuff we've been spending time on before React and highlight React as a developer health tool for you. And then we'll talk about some ways React has maybe gotten a little bit outside of the good of developer health. Trying to say this with as much decorum as I can. So let's open up the browser. Anyone use Arc? Arc is my favorite browser. Yeah, not enough people. All of you need to. I'll give you an invite after. We're going to open up the browser, and we'll open the editor. And what we'll do is a little bit of split screen action. I want you half. And I've got a directory here called imperative. And what I want to do is just write imperative code. We haven't done this in a while if we've been using React. So let's cd imperative, and we'll start like npx vite. I'm just starting up a little dev server So let's think back to before React, right? We'd have, just a standard HTML5, right? Let's call this React Miami thing. And now if we mimic what React expects from HTML, you'd expect some type of root like this. And here is where you'd normally like react.render. But yeah, we're going to do this, some imperative stuff. Let's just see if that works. Thank you, Copilot, for spoiling my awesome live coding. Anyway, localhost 51743. There we go. Okay, so that works, but it's not really interactive. There's literally no reason to use JavaScript for this. I want you, if you're writing JavaScript to do this, you need help. Okay, anyway. But we use JavaScript to make things interactive. We use CSS, by the way, to make things presentational. Great talk by Yuna earlier today about that. So how do we make this interactive? Let's do a little bit of a counter, right? So instead of hello world, we'll say my counter. And we'll add to this root thing. We'll add a, let's go before the append child. Const, I don't know. Okay, sure. We definitely need a button. What else? Nope. We're going to do increment. We'll just do a one-way counter, and then hopefully Copilot can add an on-click. Awesome. But let's do another one. Let's do a span. And notice we're talking about imperative code, and React saves us from this, which, as you can see, becomes a little bit verbose. Let's do count. And then we'll do another span, and we'll do inner text 0. And this is the one we'll increment. But we can't have two constants with span. It's JavaScript, so it actually lets you do this. This is the world without TypeScript, everybody. Const span equals, no problem. But let's say count value here. And we'll do inner text is 0. Looking good so far. So what we want to do is increment this thing. So let's now, oh, this is perfect. It actually did it for me. And okay, so now I want to append this span to, so root append child h1, and we'll also root append child span. And we'll append child, count value, and we'll append child button. This should give us what we want, right? Okay, perfect. Does it work? Hallelujah. Now I want to highlight this for you. Look at this absolute unit of code right here. All this for a counter. And this is not even a component really, but imagine if it was. Imagine if we had 10,000 of these things and we wanted them to work reliably. We wanted them to be testable in isolation. We wanted them to scale. If there was no React, this is my developer health story or my developer burnout story, really. Not ideal. In fact, React takes care of a whole class of other problems we don't even see. Like if I was to do something like this, query selector, this does conceptually the same thing. Like if I reload the page, it will in fact work, but query selector just by design is measurably slower every time as opposed to get element by ID. And in some cases, some would say, oh, but that's trivial, but maybe it's not if you've got thousands and thousands. So your use of query selector versus get element by ID is something with React you don't have to think about at all. In fact, if we contrast this code with its React variant that does literally the same thing, let's actually go split screen just to really make my point here. This on the left is imperative. This is React. I mean, so yeah, if you doubted its developer health capabilities, I mean, Now, I could add use effect to this. I'll wait with that a bit. But anyway, developer health capabilities right here. Let's move on. Lately, React has caught some negative feedback so anyone on Twitter here? Wow, there's like 3 people. No wonder all of you are so healthy. I see Mark in the back. Twitter is like fast track to problems. Anyway, some people say React is falling short, and rightfully so. React, in some ways, I want to be as respectful as possible, has deviated from this good for developer health feeling, at least among the people on Twitter, among even myself. For example, use effect, right? A lot of people say things about use effect where it's non-intuitive. I tend to agree because if you leave off a second argument, you cause an infinite loop. And I don't know why there's not even a console warning about it. So it does fall short in some ways, but there's a bigger criticism that I lean toward, and this was a tweet from a good friend of mine. Yanni, absolutely adore Yanni, a really, really close friend who tweeted this. And I think this is a masterpiece in a tweet, you know? React is in its middle-aged man era, at the top of its economic productivity, meaning used everywhere and really great, but culturally completely irrelevant. It speaks to a feeling where React is this thing that's now stable and good, and it's used everywhere. It's appreciable, but also cool to hate on sometimes, especially on Twitter. And this reminds me of a similar company whose things we use all the time. How many of you have iPhones here? I'm just curious. Literally everyone. How many of you don't have iPhones? 5. I'm joking. It's more like 10, or it's definitely 10%, I would say. Yeah, and people love Apple. A lot of the reasons why people get iPhones and things is the design. It looks nice, it feels great, it works reliably. But occasionally, you have the people who go, yeah, okay, but this. These are the same people who probably go like, yeah, React sucks because I have to think about use effect. And so these things are great. Sure, they have nits you can pick, but they're generally for your health. This is particularly cursed, though. Anyway, so how does React then fall short? What are people struggling with in React? What are people criticizing in React? And how is it not meeting its intention of helping developer health? That's what I want to talk about. I want to talk about these things with some code examples that will help us understand the nuance around it and what React is doing to get back on track with really being this optimal developer health solution for building UI libraries, okay? So what people complain about with React, this is an anecdotal list of things I hear at conferences. I go to a lot of conferences and talk to tons of React developers. And this is the 3 things I keep hearing people complain about. Number 1 is React DOM is just massive. It's like uncompressed. It's like 200 kilobytes. You ship an entire virtual DOM runtime. And now you have a trend towards things like Svelte, things like Solid, things like even Quick that ship absolutely no runtime JavaScript, as it were. They're like disappearing frameworks and libraries. Svelte is a compiler that just gives you JavaScript. Why do I need the bloat that is React DOM? A lot of people complain about this, and I have good news. Thankfully, there's work being done with server components on React. Anyone using server components? Okay, that is literally 5 people. But server components help this a lot. They help you do most of your work on the server, JavaScript-wise, and ship just rendered HTML to the client. But they don't solve the bundle size problem completely. That is, if you have an app with a bunch of click handlers and a bunch of functions that maybe the user never clicks on the button to call the function, you're shipping useless functions. You're shipping like a lot of JavaScript that does maybe not what you need. And React will still ship that currently. There's work being done to help that, and I want to talk to you about that in a minute, but I'd like to actually show you this bundle size thing by way of a little short demo about how React does it and about how Quick, anyone heard of Quick? So Quick, yeah, like, okay, not that many. But Quick aims to be the fastest, smallest, lightest way of building UIs on the web. And I'd like to show you a little demo of that just to make sure we're all on the same page. So I'm gonna close this, move this over, and come here. Nope, wrong place. Come to the browser. And what we'll do is we'll just open up Quick right here. So if we go to bundle size, Quick, and I will go start a dev server. cd Quick, and we will npm start. Why not? It's going to open. Yeah, so this is Quick. We have a counter, and Quick was made to look exactly like React. So if we go to routes, index.tsx, I mean, here, this is what you see. h1 counter, button increment. It's literally very similar to React. However, you'll notice this $sign thing. And that is a directive to Quick that says, hey, any function that comes after the $sign, code split that. Split it out into a new module, and then load it on demand. Exclude it from the main bundle you ship to your users. As a result, Quick ships absolutely no JavaScript, except maybe like 1 kilobyte of boilerplate every single time. It's every single time. Every Quick app ships 1 kilobyte of JavaScript on initial load, roughly. Okay. So this splits this out, this component out, into some other module somewhere, and loads it when the component enters a viewport. Similarly, I have this onClick function that only loads this function when I click increment. And in fact, it does work, but how does it work? So if I open the network inspector, let's maybe go halfsies, and we'll go network. What I want to show you, we'll filter on JavaScript here, is that I've loaded I have loaded no JavaScript, as you can see. Oh, actually, I have loaded some JavaScript. I was just lying. These are dev server things, so they're not quick, really. And so watch what happens when I click increment. Watch over here, the network tab. So it loaded a bunch of stuff, and some of it was 2.3 megabytes uncompressed. But had I not clicked the button, had I never taken that user interface path, it would never have loaded and slowed down my page. In the load things, I loaded this file here, which is called routes component div button onclick gurvhap8.js. And the source code of this thing is literally just a function that increments the count. But it only loaded it when I needed it. React Server Components doesn't have this yet being the keyword. I think this is worthy of a lot of appreciation because it somehow captures lexical closure scope. Like if we split this function out, maybe here, right? And we even do like something like const increment, whatever, increment. And we call increment like this. Well, technically how quick works is you do something like this, and then you call. Anyway, whatever. So if we do this, this now, because it's split out, has no idea what count is, because it was relying on the enclosing scope. But somehow, with magic, Quick will split the function out and just be fully aware of lexical scope. And I think that's very, very cool. It's also very magic, so when you run into some edge case and you want to debug it, it's going to be hard. That's Quick. React doesn't have this, but there's talk of something called progressive, or selective rather, selective hydration in React that does the same thing. So server components, meaning render on the server, ship components to the client, and then selective hydration being make something interactive only when you go to interact with it. These two combined makes React similar to Quick in this way. That gives you those health benefits for developer health, okay? Number two is server focus. So React is moving more and more to the server. Andrew Clark from Vercel on the React team says, hey, if you use React, you're going to want to use a server. If you don't have a server, incrementally adopt one. If you're starting something new, start with a server. The React team is very clear, server, server, server. And that is because it gives you a ton of benefits, like we talked about, server components et al. I need to be clear here, you can get developer health benefits from React if you don't use a server. It's just you don't get all of them. But there's people complain, oh, now it's getting way more it used to be just a piece of JavaScript I could include on my web page, and now I have to do so much more. Yes, but the benefits are tremendous. I'd love to show you another demo, but I want to be sensitive to time. But you know what? It's the last talk, so who cares? I'll try to be quick. If you don't want a demo, let me know. If you do want a demo, show me. Okay. Good. Feel free to, it's totally safe to be like, get off the stage. It will not violate the code of conduct. Anyway, with the server focus, let's be a little bit quick about it. I want to show you what frameworks do just by like server-side routing that I think is worth knowing, that'll help you appreciate the server focus. So we have here kind of a roll your own situation of rolling our own server. What I'm going to do is just start Beat. And I have a list of like dog breeds that I like. It's a little app that shows you a list of things. My favorite API in the world, dog.ceo, phenomenal API. And this is indeed a React app. It's interactive. It updates here every time I like something. The problem is it's client only, right? So there's no server, meaning if I view source, I see absolutely nothing. And this is pretty bad for search engines, for accessibility. It's just, it has drawbacks. So the solution to this is client render. Now, or rather server render. To server render, you'd probably want to use Next.js or Remix. You certainly do not want to roll your own because there's a ton of pitfalls that happen. But for the sake of developer education today, we're going to roll our own server that renders just for fun and to understand the complexity behind it. And to do that, I'm just going to quickly, and this honestly should take 5 minutes. I have no interest in taking too much of your time away. So we'll do server.jsx. And what do we need? Well, we need a server. So we'll get get a server. We need React for sure. We need our app, probably a good idea. And we need a server render function from React DOM. So we'll import from React DOM server. We'll import what, like render to string? Okay. Should I use render to string? Can anyone tell me, should I not? I'll use it. Wow, everyone's giving me the thumbs up. Yo, that's a weak API. Anyway, and we'll talk about why. So We'll create our server, and then on / we'll render our component to string. We'll listen. Oh, Copilot, God bless you. That's it. We have a server that is rendering our app component to a HTML string and sending it over the network. Let's just run this without really knowing what's going to happen and then see what happens. So I'll kill the Vite server. I've got to build this. So I'll go to my build and delineate client and server right here. So I'll actually have to build this with ESBuild, which is an absolutely great tool. And I'll say this is for Node.js. This is Node. And then I want to compile my server and client at the same time. So I'll just have a general build, and I'll do run in parallel, build all of them, okay? And now I'll just npm run build. Cool, cd dist. And normally, node server.js should give me on 3000. Great, I have a server. It's awesome. There we go, server render. If we inspect the markup, we do in fact have a bunch of things. But yeah, actually, it's pretty great. I can't fault this. You shouldn't use render to string. There's nuance here. First of all, this isn't even interactive. Like, you notice the counter doesn't count because we're not using React on the client. We can fix that as well by interspersing like client and server here. Should I do? You know what? It's not worth it. There's limitations here. Also, render to string is probably something to avoid because it like serializes your entire React app into a string. So if you've got deep components, it will synchronously do that for each client that connects and block the event loop and crash your server, and it's just not good. So you want to use something asynchronous like a stream. So there's a function called render to pipeable stream, and this is pretty bananas because what it'll do is it has a slightly different API. So we'll get a pipe function out of a call to render to pipeable stream. So we'll do this. And in the second argument, we get some events we can respond to. On shell ready is a good one. So this is when our shell is ready. A shell is an application with data loading placeholders. So we fetch dog breeds from the dog API, and we tell React using suspense, just show loading while stuff is loading. So that's the shell. This loading string is the shell. So when the shell is ready, when we just have the loader visible, we will pipe to the response, just like this, okay? Notice we're not using React. This is very important for you to know. This is just HTTP. So I'll kill this, rebuild my things, and start the server once again. Reload. So there's the suspense boundary, but it still worked. And we're not using React on the page, though it did update the UI. Did y'all see that? Here, let's do that again. Loading, the UI updates, but there's no React on the client side. This is purely using some inline JavaScript that React has added to our page to swap out the suspense. So this little function here, React injected from the server to say, hey, when that suspense data is finished fetching, update the UI. And that is a benefit you get from the server focus. You don't have to think about these things. Again, all this in favor of developer health, okay? So bundle size, the server focus. And lastly, cognitive load. Unfortunately, I don't have time. I really wanted to do this demo for you, but there's literally like 5 minutes left, so I'm not going to do it. People complain about, yo, React just updates all the components from the tree down when some component state changes, and this is non-intuitive. They expect fine-grained reactivity, like you get with signals in SolidJS and Quick. There's an upcoming project from Meta called the Forget compiler that will do this. It will automatically, at compile time, add use memo to like strategic places. And it knows this because of React's rules, the rules of hooks, the rules of one-way data flow, etc. It just knows what to memoize, and that'll just be part of your build step, and you'll get your fine-grained reactivity. All that to say, these are some issues people have with React, and those are some ways React is answering them while trying to kind of get back to this React is a developer help tool. React is and has been a tool primarily focused on, this is my hot take maybe, I don't even know that it's that hot, to be honest with you. We just proved what life would be like without React, okay? And this has enabled us to do some phenomenal things. For example, because React has handled a lot of the problems for us, it has allowed us to build some really ambitious applications. You all know any ambitious applications out in the wild that partly exist because of React? Yeah, I see a bunch of hands over there. I think of I think of Notion. Who uses Notion? Yeah, a lot of you. That's possible because of React. I think of similar applications like Figma that doesn't even use React, but with with React, we have the possibility. And I want to spend my last 3 minutes with you talking about how some products exist that are really paying it forward and furthering this mission of developer health. I want to share with you, so Sunil did a talk yesterday about PartyKit, great primitive. And similar, yeah, absolutely. And similar to PartyKit is live. Anyone heard of LiveBlocks? Like 2 of you. LiveBlocks is like PartyKit, but maybe a little bit higher level that does more stuff for you out of the box. And last 3 minutes, let's do a few demos about these things. And I want to leave you with a very important question at the end. So stick around for that. So I want to open up my browser. And what I want to do is, let's get rid of all of this. CD back, CD light. Whoa, CDL, it's a new command. And we'll npx next. I'm using Next.js here. Next.js also, by the way, phenomenal for health. So let's get rid of this and go to LiveBlocks, my little directory here. I want to show you. So LiveBlocks' mission is to make like real-time multiplayer collaborative things like Figma, like multi-cursor, approachable. It's a developer health tool. I want to show you developer health is the focus. And I want you to keep that in mind. So what we have here is, if I go to localhost 3000, I should have, I am a boring page, make me fun. Okay, I want this to be multiplayer, and I want us to have a little bit of an engaged multiplayer experience here. I need you to, a lot of people tell you, hey, don't pull out your phone and be distracted. I'm gonna do the opposite in just a minute, okay? But this is a boring page. What I wanna do is add multiplayer capabilities to this with a few lines of code. Maybe not quite 8 like Sunil yesterday, but that was pretty amazing. So what we'll do is, I'll create a folder here, a file rather, and I wanna import some functions from LiveBlocks client and LiveBlocks React. And again, the point here is to focus on and show you just the developer health, how ridiculous it is. We'll create room context. So I'm gonna create a client, which is, maybe I can spell create client, needs a public API key. And I have this in .env. Don't look, everybody cover your eyes. It's public, I kid, it's fine. I need a type for something called presence. And in LiveBlocks, presence is a thing that says, hey, I'm here, I'm a player in this multiplayer thing. And I want to create an app where each one of you and me can write here a CSS rule. And together we compose like a bunch of CSS that completely destroys this page. Okay? So we'll do rule string. Everyone can enter only one. And I highly recommend adding a semicolon, else you'll break it because CSS. And look, it kind of does it for me, but I'll export a const. And I'll just create a client with presence as a generic. Not create client. Oops, it's create room context, my bad. And so what I want to do here is extract some stuff. So definitely the room provider and some hooks. Use my presence, use others. Yeah, that's a good one. And maybe use error listener. I hope I don't have to use this. Okay, next, it's a Next.js app. So I'm going to wrap my app in the context. So I'll just come over here and be like, what is it? Room provider. I love TypeScript. I would not have a career without TypeScript. That's another developer health tool. Just think about all the developer health tools that exist. And at the end, I'm gonna have a question for you. I think you can kind of guess what it is, but don't spoil things. Initial presence is just, the rule is empty, okay? And that's kind of all. I think this should now be multiplayer. So I'm just gonna add it to my app here. So if I go to pages index in Next.js, this is just a React component. I wanna make it multiplayer. So what I want is my presence, so set P, and I'll use my presence over here. And I want others, that is all of you, all the other players, and I'll use that. Maybe import, that's a good idea. So there are 0 people here. I want this to say how many people are there. So there's definitely me, I am 1, plus the length of others. I don't know what that is, but length. And then what I want to do is kind of iterate over everyone's CSS rules and add them. Oh, look, it kind of worked, nice. So let's go over here, and I'm going to multi-cursor this thing. So I'll put my rule, that's the one I wrote. And I'll iterate, I'll map over others. So I'll say, oh, wow, Copilot. Others.map, O, and we'll do O.presence.rule. I just want the rule, and then I'll join it with a new line. This looks nice. Okay, so I'm just going to do a solo test, and then I'd invite all of you if you're up for it. So color, red. Huh, doesn't work. Classic. Why doesn't it work? Oh, I didn't bind the input. Silly me. Value is p.rule. On change, we get the event. You thought that error was an accident. All right, let's go. Color red. Okay, kind of works. I don't like that spacing. I don't like when multi-line strings do this. Y'all ever have that? Nasty. All right, let's go. And then we'll get rid of that line. Perfect. So this is cool. Let me pull this up on my phone and see if it responds. So I have color red. Let's go, I don't know, background. Is it working? Oh, it is. Nice. Background green. Wait, I can't type. Green. So, okay. So it kind of works, but now let's get wild. It's after party time. I'm just going to clear all of that, and I'm going to record this session. We'll talk about that in a second. Now, I want you, very important, to scan this QR code. And you let me know when you're done by saying done. All right, great. You should be here, and I want you to, oh my Lord. Wait, stop. Everybody stop what you're doing. Okay, whoa. This has gone horribly awry. Did someone do like height 1 million or something? What happened? Oh my Lord. Wait, maybe if I make the screen really small. Wow, you let something happen on the internet and people really, one person type one thing. Okay, how do I have no idea what to do at this point. I didn't expect, can everyone, what if I inspect element? What am I gonna see here? This, y'all are part of something now, something greater than all of us. Oh my goodness. And it's still, someone typed haha. This isn't valid CSS. Yuna, fix them. What is happening? Dear Lord in heaven. Okay, wow, I've created a monster. That's what I've done. Okay, can y'all leave? For reals, because I have a really cool demo I want to show you, but now I can't even use it. Oh, yeah, whoever's typing invalid CSS. Opacity. Kind of just enjoying reading this now. Okay, I think we're almost there. Look at this, opacity, display none. I'm gonna give it 3 seconds, and if people don't leave, I'll just do a different room, it's fine. But I would really like it if whoever's screwing up the style could just get out of the room. Like, you have to close the tab on your device, otherwise it's gonna stick. What an awesome chaos moment. Kathleen thought she had issues with the distractions. Okay. Oh, we're almost. Who has the AAAA? Someone. Oh, there's a live stream. Oh, you live stream people. Transit. Come on. Okay. It's been 3 seconds. I'm sorry, y'all. I'm gonna have to do. Oh. And it's back. Hit that like button. I have to give it to you. That's a. Okay, hit that like and subscribe. Okay, anyway, I'm going to still whatever. So it kind of works ish, and then there's so 29, 30, 31, whatever. What I wanted to show you, I'm just going to leave this running. If somebody can make this, actually, never mind. No rabbit hole. I'm going to leave this running for a bit. But while React as a developer help tool has enabled us to think about what else can we simplify the developer health around. We have products like LiveBlocks, like PartyKit. But what you'll notice is these things become increasingly hard to debug. Anyone ever tried to debug real-time multiplayer nonsense? Like, yeah. How was your experience? Burnout. It's hard. I'm trying to debug this literally right now on stage, and I'm burning out just thinking about it. Okay. So someone's adding important. Oh my Lord. Anyway, so I'm thinking about debugging this. I wanted to share with you, as these things become hard, enough. As these things become hard to debug, so we need an evolution in debugging as well for developer health. And that's the last demo I want to show you. The basement dude, JB, Julian talked about this earlier, but I've stumbled across a tool that I think is extremely valuable for debugging exactly this kind of thing called Replay. Anyone use Replay here? like 5. I want to make that more because I think it's worth it. So I've been recording this entire session, and with replay, it gives me something that I can use to debug. And God knows I need to debug this. So we started with this. And if I hit play, what's going to happen is it will play the thing like a video, kind of like a failing Cypress test, mouse events and all. The awesome thing about replay, though, that I've really appreciated is it's not a video, while it looks like one. I can literally like pan back and forth. If I go to DevTools, and again, the focus here is developer health. I want you to stick that in your mind. If I go to DevTools, what I find is this isn't a video much at all, but I can like inspect the DOM and the errant style sheets and really like get to the weeds of it. I'm outside of what's called focus. I'm going to come in here and look at this. So I can inspect this thing and I see the HTML and I see all of your absolutely horrendous style sheets forever captured in time in a way where I can actually go in and debug exactly the multiple CSS mistakes that have happened here and kind of know, oh, even this moment right here. You see that? I can visit different elements of the code and I can even like add, and this kind of blew me away. I don't know if I can do this now because you really destroyed my page. Yeah, here, pages index. I can literally add console logs after the fact. And I think this is ridiculous. Like if I come to here, for example, p.rule, I add a console log, right? Use focus mode, whatever. Can I add a console log? I tried this earlier. Maybe that one not, but over here maybe. These things were hit 2,500 times. Yeah, let's maybe use this. Okay, I did not expect this much chaos, but I'm here for it. So I added this console log, and I can do whatever I want, right? And it shows me every single time after the fact what a value is. I even get access to the enclosing scope and so on, and really am able to debug this very, very efficiently. I could maybe even take a look at hello here at what others is. Is that going to work? Yeah, others, exactly. And I can differentiate this from the others using this like little unicorn symbol. So it's what they've done, and I think this is really admirable, is they've taken, yeah, so now I can see hello, and I can see all of these different connections from the room. And this is after something has happened. Never could you debug a live stream or a live multiplayer thing like this before. And I think for developer health, that is pretty admirable. Now, why am I telling you this? I'm telling you this because React started something. As you saw in the React documentary, React started a movement for developer health through finding the right level of abstraction, right between the amount of control we want to give up and the convenience we want to have. And things like LiveLox, Replay, Figma, Notion, whatever, they all carry that torch. I'm not saying React started this by any means, but React is a significant player. And with that, I want to wrap up this talk and really ask you one last question, which is, in the name of developer health and following suit with these, what can you build? React Miami, thank you so much for having me. This has been an absolute pleasure.
Give it up for Tejas. Thank you so much. Okay, so I know that you guys are dying to meet the amazing people who put this event together for us. So I want you guys to give me your loudest shout, like the loudest. Not
Give it up.
A light shout, a loud shout.
Woo!
Give it
Michelle
up for Michelle and Gabe.
Greenberg of G2I.
Hi, hello. I'll start because I have a very serious question. So I'll get it out of the way first. You're welcome, Christopher. So who in the room is from the Pokemon Company? There are people that joined us from the Pokemon Company. So I might be like a little bit late. That's just personally something that I would like to know because I'd love to meet you. So in any case, moving on. So this was such a fun year. I hope you guys had a really good time. I was thinking about, kind of how last year went this year, because of course this is just the second time we've run it. And we've actually had some pretty cool moments. So last year we had 2 debuts at React Miami, or 2 big announcements, and that one one of our speakers companies, Ariana the Techie, she announced that she raised $3.1 million from Yushi on the React Miami stage. So that was really exciting. And also we got to see Blitz 2.0 for the first time on the React Miami stage. So that was super exciting too. And then this year we had 3 major debuts or announcements. So Party Kit became open source. That was awesome. Christopher indulged us in his video editing explorations, which I think may have happened here for the first time. If it didn't, again, like Dax said earlier, it's not about facts, it's about vibes. So, and then lastly, Flight Control came in full force with their new rebrand, which has been a while coming, as I understand. So congratulations to the Flight Control team. And then, of course, there's everyone else here. There was just way too much to remember. This is such a dynamic group and an exciting group. We have developers and teams from over 20 countries, over 30 states joining us. That's pretty epic. And we have people like Christopher Trudeau, who have worked on React from like day 0 all the way to our students in our backyard from BrainStation, IronHack, FIU, yeah, like all of these really great boot camps and universities. And we have students that joined us from University of Cincinnati. That literally do like a fundraiser with their school, like went to their administration and compelled them to purchase them flights and everything to come to React Miami. So that was pretty amazing to learn about and to help work with them on. As far as the companies represented go, huge giants in the room. People from Meta, Google, AWS, PayPal, Adobe, Paramount Pictures, Amex, Visa, Discover, Bloomberg, we're all here. So I'm sure that somebody, I missed the Pokemon people, but maybe somebody in that group is still here. And then we also have like startups from like people in our backyard here in Miami all the way to San Francisco and around the world. People from Bundle IQ, Replay, Wondergraph, Sauce Labs, Flight Control Stately, Cool Computer Club, and Monogram too from Atlanta, and whole dev teams joining us from Argentina, Denmark, Canada. So all of this to say, it's been an incredible experience to meet everyone, get to know everyone. And if we haven't met, the after party is going to be really fun. So like, let's get to know each other. So thanks so much. I'll pass it off to you, Greg. Yep, go ahead. Oh, I love you. Thank you.
Wow, that was amazing. Can we get one more round of applause for Michelle? Come on. I've heard nothing but amazing things from almost everybody I've talked to about Michelle. And I just can't believe it. Pinched me. Like I stayed up too late on Twitter and bought reactmiami.com and you all thought it was a good idea and showed up. That's amazing. And Michelle, you know, I didn't know Michelle 2 years ago. And we sat down, you know, one Friday on a Zoom call, even though we live like an hour from each other. And in the middle of COVID still. And she says, I believe in this. We should do this. And she convinced me in 3 months and said, it's going to happen. And then I hired her to G2I, and it's been one of the best hires in the history of our company. So thank you for joining me. I'm incredibly grateful to the React community. I was watching the React documentary and I was like tearing up because this ecosystem, this community, you all changed my life forever. I was chronically ill for 8 years, from 2012 to 2020. And it was this community that I reached out to for help, did a GoFundMe. I had mold toxicity and mercury poisoning, and I had headaches every single day. I was fatigued. Just my emotions were all over the place. and I would get up, from sleeping on the office, floor, do a little bit of work and then go to sleep again. And that was my life. And I reached out, and it was the kindness of people in this room. It was the Christopher Trudeau's of this room. It was Dan Abramov. It was many of you all who helped raise money for me. And I'm finally healthy for the first time in a long, long time. So thank you. My wife also thanks you. I was a little bit on the grumpy side. My children thank you. And the developer health mission you've heard about through so many of these talks is the mission of G2I, of our company, to invite people to a healthier work life. And burnout is so prevalent, and it needs to go away. And so our goal, Michelle, and my goal is to talk more about solutions and how we can end burnout in tech one day at a time. And I think it's how I want to spend the rest of my life. And G2I, we offer flexible talent. That's what we do. It's a talent marketplace. So if you need amazing talent, we believe quality over everything. You want to augment your team to move faster without increasing headcount, please talk to me. I have red shoes on. You can't miss me at the after party. And this event has been, hosted by G2I and our partners, JSWORLD. So they've been absolutely amazing. Some of the kindest human beings you'll ever meet. And they're also quite tall. They're like 6 feet tall is average there. It's pretty impressive. So thank you to everybody that has shown up to this event. Thank you to the speakers that just absolutely crushed it. And thank you to our amazing sponsors. We cannot wait to continue this journey, this process. The year hasn't been the easiest out of all the conference years, but each and every one of you made this possible. So thank you, and looking forward to partying with you all tonight. So see you there.
Give it up one last time for these amazing individuals who are the brilliance behind this conference. Yeah, I love that. Standing ovation. Let's go.
Oh my God, that was crazy.
Oh, you guys are... Okay, so I'm not going to let you guys leave without telling you one final joke. 3 of my friends convinced me not to do it. I am in the department of naming and shaming. So please go find them and tell them how funny I am. Miles, Blake, and Toby. They said I'm not funny and my jokes are corny, but I'm still going to give you one just for the hell of it. Thank you. I love that. Thank you, Kayla. Everyone deserves a Kayla in their life. Okay, so who's familiar with Forrest Gump here? Great. Love it. What do you think? Exactly. What do you think Forrest Gump's email's password is? 1 Forrest 1.
Oh my God. Okay, that was funny. That was funny. That was funny. That was funny. You got another one?
No, that's it. That's all you guys get from me. Nothing else. I would like to keep some for my career. But...
This was amazing, y'all. So again, I just want to give it up to y'all as attendees. Like, we had a lot of first-time speakers. So round of applause to our speakers, please. This is a reminder for y'all to come next year as a speaker if you're attending and like you met all these great people, you absorbed all the talks. Now it's your time to submit the CFPs. So I'm watching y'all.
Couldn't agree more. Also, I just want to say a huge thank you again to everybody who's played a role in the background. The volunteers who made sure that all of us were registered, we were here, we had food. The AV and production team who kept the show smooth and running. Again, our amazing translator team that made sure that everybody was included. Everyone who tuned in from the live stream. Jordan, I saw all of your tweets. Thank you for joining. Chris, I saw your tweets as well. It was really great to engage with you all online. I just want to go in and echo what Gabe said. This community is one of the most amazing communities that I've had the opportunity to be a part of. I attend tech conferences, and not often do I feel like I leave with people that feel like friends. And I've gotten this feeling from here. So we just want to say what an absolute honor it has been to hang out with each and every one of you for the past 2 days. Thank you for trusting us with entertaining you with our funny jokes and introducing all of our amazing speakers. A huge, huge shout out to all of you for showing up. The past couple of months have been tough in the tech industry, and so we don't take lightly what it took for people to show up here. And so I just want you to congratulate yourself for showing up. So if we could just give ourselves a warm round of applause.
7:30 is the after party. So between now and then, definitely put some food in your belly. Meet up with attendees, meet up with friends, and just make sure you're full because tonight we are going till late.
Woo!
Doing it right. The Pasco, make sure you go to, it's a French word, Marseille. So you gotta say it like that. They won't let you in if you don't say it like that. So definitely make your way there around 7:30. And thank you again for coming to React Miami. Make sure to retweet online. There's a lot of FOMO out there. So make sure to add more retweets and likes and give some speakers their feedback as well on the Discord channel. So thank y'all again for coming. And
we're signing out.
that's it.